analyzing network traffic will be one of the most important skills that you will have as a security analyst inside of the Security Operations Center. That's what we're going to be talking about today. My name is Hank Hackerson, your trainer for the day. And to get more videos like this one, make sure that you subscribe, share, and of course, turn on the notification bell. This video will be of the network traffic basics room that is inside of the network traffic analysis module inside of the SOC level 1 pathway of TryHackMe. And this is the most recent version that they released for 2026. And so as it stands, we're just going to go through the introduction. What is the purpose of network traffic analysis? What network traffic can we actually observe? Network traffic sources and flows, how we can observe these things. And of course, there's going to be a little exercise that we're going to do for that task as well. And then we'll have the conclusion, final thoughts, and then you will be dismissed for the day. And these things have been all time-stamped in the description below so that you can go ahead and jump around if you need to. And this is, I believe, actually a free room that is available inside of TryHackMe, so anybody can get access to it and launch the exercise and go through the contents and everything like that. And of course, you can always download the softwares that we use on your own computer and kind of move along with me as I go through these videos. And there will be a lot of other ancillary supportive videos when we talk about network traffic and network traffic analysis. And as we go further into the module, we'll be talking about different tools and resources. For example, WireShark or Nmap, or I mean, there are so many different tools that you can use for network traffic analysis. So we'll be referring to these individual tools, and as we refer to them, I want you to know that there is always going to be more videos for that specific tool on this channel. For WireShark, for example, there are probably over a dozen videos just on WireShark and using WireShark and the basics of it, and then going into the more advanced videos on how to query WireShark and capture traffic and sift and sort through the traffic, filter the traffic, etc., etc., etc. And we do a lot of investigations with WireShark as well. And then all of that also ties directly into SIM tools, and we have dozens of videos on using a variety of different SIM tools. So all of these things really mesh together because, again, this is one of the bigger topics for security analysis. Pretty much the majority of your job as a security analyst, junior analyst, or just a regular SOC analyst, as you get into that job and into that role, the majority of your job is going to be analyzing traffic and what happens inside of that traffic, and really how you can tie that into an investigation for an incident response kind of a situation or anything along those lines. So all of these things are very, very important topics that I want you to just keep in mind as we go through this introduction and then as we expand further on this topic. So without further ado, a quick little note from Hackaholics Anonymous, and then we will dive into the introduction. If you want access to my notes and exclusive downloads and to get lifetime access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers. We have the supporter, the agent, the guardian, and the master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below and you will be able to choose the tier for which you want to join. I really hope I see you in the Discord chats. If not, I hope I see you in the comment section. Okay, so here's the intro. Network traffic analysis, NTA, is a process or a system, an exercise that encompasses capturing traffic, inspecting traffic, and analyzing the data within that traffic as it flows in and out of a network. Its goal is to have complete visibility and understand what is communicated inside and outside of the network. And so complete visibility means we want to see everything going on within our network and anything that has to do with our network. So it might not be within the network, but it might be traffic flowing into our network from outside of the network, which I guess technically has to do within our network, or traffic leaving our network and going somewhere else. These are very, very important. And of course, the interaction of the various machines that are inside of our network and the communication that they have with each other. So this all falls under network traffic analysis. This is a very, very important concept. It's important to stress that NTA is not a synonym for the tool WireShark. The WireShark tool is used to do traffic analysis, more so on the deep granular level of looking at the activity. But the concept of NTA is much more than that. It's a combination of correlating several logs. And so anytime you hear correlation, you can think about SIM tools, because logs are correlated and organized and centralized inside of a SIM tool. Deep packet inspection, which is what we can do with WireShark, and network flow statistics with specific outlined goals, which we'll discuss later on. So knowing how to analyze network traffic is an essential skill, not only for aspiring SOC level 1 analysts, but also for many other blue and red team roles. As L1 analysts, you need to be able to navigate through the sea of network information and understand what is normal and what deviates from the baseline. Very, very important concept here, right? So essentially, this is going to be your comparison, right? We in advertising and in scientific experiments, they call it the control. So you have the control value, right? So this is what we are comparing everything else to, is that control. And then if there are any major adjustments that we need to make internally to establish a new control, then that will end up being the new baseline. And then we will now compare everything else to that new control, that new baseline. So this is a very important concept to understand. When we're talking about analysis, it's always like, okay, well, what are we comparing it to? Right? So what are we analyzing and what are we comparing it to? And that is called the baseline. The normal activity that should be going on inside of our network is our baseline. And then anything that deviates from that, anything that looks suspicious in relation to that, is what we want to pay attention to and we want to investigate further. We're going to focus on defining network traffic analysis, why you need it, and how you can observe network traffic, and some of the resources and flows of network traffic. The learning objectives are to know what it actually is, what NTA is, how it can be observed, or what can be observed, know what can be observed, know how to observe it, and then typical network traffic resources and flows. Prerequisites for this would be pre-security and networking essentials, and these specific modules, or I think this is a room, or is it a module? I want to say this is a module. Or no, pre-security is, actually, I don't think I've even done this. It seems like I haven't even done it. So let's zoom out of this and just see what's going on here, because it looks like I haven't done it, but I feel like I have, because pre-security is like such a basic concept. No, you know what? I don't think I have, because this is a 2026 room, so, or 2026 learning path. So I don't think I've even done this. So there are 31 labs inside of it. Very cool, actually. So I might do this. It feels like taking a step backward by going into pre-security, but I think these might be useful for a lot of people who don't have a strong background in cybersecurity. So I may actually look into that. Networking essentials, I really want to say I've done this, because this, yeah, okay, I definitely have done this. So you can actually go find the networking essentials video as well. But pre-security, that's a new one. We just found something new that we could probably work on, so that'll be pretty cool. And that's pretty much it. Okay, cool. So let's go into what is the purpose of network traffic analysis. Okay, so to answer the question of why we should be doing this, right? So what is the purpose of this? To answer that question, we need to first understand, or we'll kind of use a scenario. So imagine you're a SOC analyst, you receive an alert stating the unusual number of DNS queries are coming from a host named Win16 with this IP address. The DNS logs the firewall show multiple DNS queries going through the same TLD, and each time using a different subdomain. So TLD is a top level domain, and then they just go through a different subdomain each time. So you see this is the source IP address. We just see the timestamps here. These are the queries that you see right here, and the specific top level domain is malicioustld.com, but then we now have these subdomains, right? So these two are on the same subdomain. These are two new subdomains. And then you'll see the query types. This is the TXT records that are trying to pull. These are the A records that are trying to pull for that subdomain. So that's basically it, right? These are DNS queries trying to pull information about this domain name, okay? So based on the logs, we can retrieve the following information: query and query type, subdomain, top level domain. We can check tools like AbuseDB or VirusTotal to check if the domain is malicious. Host IP address, we can identify the system sending out the DNS queries. Destination IP, using tools like AbuseIPDB or VirusTotal to verify if the IP is flagged as malicious. And timestamps to see the frequency of it, how many days or hours or weeks it has ranged across, etc., etc. So this is like basic pieces of information. Of course, this can be used inside of a SIM tool or anything like that. And to show you kind of like a reference of what they're talking about, if we go to a place like VirusTotal to actually use that, right? If I wanted to search for that IP address to see if it's malicious, I don't think it's even real. So that's why it's showing as a clean IP address. But in case it wasn't, right, we would be able to see it. Same thing with the actual top level domain, this malicious.tld.com. I don't think this is real, but just for, shits and giggles, we'll just go over here, go to search. Oh, you can even drop it into the URL here and drop search, and it'll say, of course, it's clean. So as far as that's concerned, I think these were just fake things that were created. So of course, there's no actual history attached to them, but it's as easy as that you can just kind of, excuse me, I just had a random yawn show up. You can kind of show, you can search for through VirusTotal or anything like that to see whether or not they are malicious, and it's super quick. It takes a couple of seconds, and then you'll get some kind of a report. And if it was malicious and you saw any of these specific things that we just saw right here, right? So if we see any of these right here saying that it's malicious, then you will have more information under the detail summary. You may have more information under the community summary, and then you will see more of the activities related to that specific domain, so you can kind of create a report for it. So these logs don't contain more information than that. So it's hard to draw a conclusion based on just that information. So we'll need to inspect the DNS traffic more thoroughly and check the content of the queries and replies. This will allow us to determine the nature of these queries, and is the prime example of why we need traffic analysis. Firewalls and other devices register the queries and their responses, but not the content of the queries or the content of those packets, right? Threat actors could, for example, use TXT records to send command and control instructions to a compromised system, which is what we see right here. Look, there's a query type of TXT, right? So they could be sending TXT records, for example. We can discover this by inspecting the content of the DNS queries. The packet capture fragment below shows the content of a DNS query that contains C2 commands. So domain name systems response, transaction ID, flags, etc. This actually looks like something that would have been pulled from WireShark. It's very similar. So questions, answers, authority, queries, and then the answer, and then we have the TXT right here, and this is what you see right here. So this is a base 64 encoded command. So we will take that. We'll go to our handy dandy CyberChef right here, and you can just find CyberChef by Googling CyberChef, and it'll be the first link that points to github.io. So we'll paste it inside of the input. We will do from base64, drop it in here, and look at that. This is the encoded command that was inside of that DNS query. They just said, I love your curiosity, because they knew, or well, they thought that we would probably search for it and see what it actually means, right? So this is what base64 encoding is. Fun fact, there was this girl that I was talking to a long time ago that was very much into cybersecurity. And so she would send me messages base64 encoded. And that was one of these things that I thought it was actually really cool, that you can actually kind of communicate in code with somebody. And that became one of those things that it's like, okay, well now, if I really want to test to see if somebody's actually as clever as they say they are, I'll just send them an encoded piece of text and then see if they even know that it's encoded, and then go ahead and decode it and find the message inside of it. It makes it feel like you're kind of in spy world, you know what I mean? Send a message encoded, and then they have to decode it to find the internal message and respond to you. And it could be something as simple as, you have a big nose or something, like some really stupid comment. But you just put it inside encoding and then see what people will do with it. And it can be a really fun thing. If you have friends in cybersecurity, it's like a fun little way to talk to each other, where you actually just send messages back and forth to each other via base64 encoding, and that ends up being a cool little thing. So why should we analyze network traffic? We will use this analysis to monitor network performance, check for abnormalities like sudden performance peaks or slow networks, inspect the content of suspicious communications, exfiltration, download of malicious zip files, lateral movement. From a security operations center perspective, This helps to detect suspicious or malicious activity, reconstruct attacks during incident response, and verify and validate alerts. So 2 more scenarios. Based on the logs of the end user system, the system began to deviate from its normal behavior, which is its baseline, around 4 p.m. Analyzing the traffic going to and from the system, we found a suspicious HTTP request and we were able to extract a suspicious zip file. We received an alert that an end user system is sending many DNS requests in comparison to baseline. After inspecting, we discovered that the data was being exfiltrated using a technique called DNS tunneling. So essentially, the whole point of this is that just by looking at logs, you do not get the full story. So when you analyze this log item, for example, you may find something like this specific packet. And then when you look further into it and you actually look at the TXT record, and then you see there's base64 encoding, then from there you go ahead and you decode it, and then you find what's literally inside of that one specific packet, because just by looking at the logs, we don't get much, right? So this is where the deep analysis of network traffic comes in and why it's so important. So what is the name of the technique used to smuggle C2 commands via DNS? We just saw it. It's actually called DNS tunneling. There we go. Perfect. All right. Let's go to the next piece. What network traffic can we observe? So now we move on from why to what, right? So first we figured out why we want to do it. Now we want to figure out what we can actually analyze. And the best way to do that is to look at either the OSI model or the newer version of it, which is the TCP IP stack, the TCP IP model. And so each layer, this is a key concept, each layer describes the required information to pass to the next layer, okay? And so it goes like this. So this is what we have here. So the link layer was the bottom layer, the first layer, okay? These are the headers in it. The IP header, transport header, etc. Then the internet layer relies on the information of the link layer. So it includes all of this information, but then new information is added to it, which includes the IP header, the transport header, and then the application header plus the data, right? And then these pieces right here, will then transfer all of their data to this layer, which is the transport layer. And the transport layer includes all of these, including itself, which is the transport header, and then the application header plus the actual data that's being transferred. And then finally, the application layer, which is what's presented to us. So as you're watching this right now, you're using an application to watch this. So you're on the application layer right now, and through the application layer, data is being transmitted to you. If you were to take one step back, you would see that that data was being transported via a transport type. And that would most likely, because you're watching video, it would most likely be UDP, which is the user datagram protocol, which is used more for streaming content. And you don't necessarily need a full connection in order for it to happen. So it's quicker, right? So if you needed reliability, if you needed all of the information to be transferred, you would use TCP, which is the transport layer protocol. And excuse me. And so on the transport layer, or excuse me, not transport layer protocol, I'm sorry, it's the transmission control protocol. My apologies. So TCP is the transmission control protocol. And so on the transmission control protocol, in that type of communication, there needs to be a full established connection. With the UDP type of communication, there doesn't need to be a full established connection. So the way that this works is that sometimes you watch a video and the video is pixelated, but it's still playing. So the audio is still coming through, but the video itself is actually pixelated. It's not very clear. And then it takes, let's say, 5 seconds, 10 seconds for the video to become more clear. So the reason why that is because UDP does not wait for a full connection to be established before data can be transferred. Hopefully that made sense. And then if we go a layer underneath it, then it's like, okay, now we need the transport header, which is what you see right here, plus the application header and all the data, which is what's going to end up finally being sent to this final application. But the base of this layer is the IP header, which is from one IP address to another IP address. So for example, you are watching this on YouTube, the IP address of YouTube is communicating with the IP address of your device, whether it's your computer or your phone or something like that. The IP address of YouTube is communicating with the IP address of your device. When I upload this video to YouTube, the IP address of my computer is communicating with the IP address of YouTube, and then the data is being sent to it. And then through that kind of three-way interaction, you end up finally watching this video. And then this very bottom layer right here is where the full connection of my computer to my local router takes place and how I actually connect to the internet. So in the link header, there will be things like my MAC address for my computer, and then the IP address that is established from my computer that will connect to the IP address of my gateway, which is my router. And then that connection will allow me to send data to my router, which will then send from my router to YouTube's router, and then they'll receive that video uploaded into their servers, and then their router will communicate with your router at your house. And so it goes like this, right? So for me, my computer would be on this layer. I connect to the internet, and then I connect to YouTube and upload my data, and then it goes into YouTube, right? And then on your side, from YouTube, you will receive the data and it'll come back to your local router and it'll connect to your computer, and now you're able to watch it on your computer. So it's like it goes up and then it comes back down. That's kind of the way the direction element of this works. I really am probably going way too deep into this. It shouldn't be that serious, but it's just good to know those details just so the rest of this will hopefully now make a lot more sense. So on the application layer, we can find two important information: the application header and the application data itself, which is the payload, which is the video in this case. This will change depending on which application layer protocol is used. So HTTP, for example. The code snippet below shows the application headers of a client sending a GET request and server's response. So this actually is also working on your video as well. So your computer sent a GET request to YouTube, and YouTube from their side sent a POST request to your computer, right? That's HTTP communication. Most web proxies and firewalls log this header data when they don't log it in the application data or payload, or what they don't log, is the application data or payload. From the GET request, you can determine that the client is requesting a file named suspicious package and includes this 200 code, which is successful. However, what you can't see is the content of the zip file. So this is what we see. This is the request. We're going to get from the downloads a suspicious package zip, and then it's coming from tryhackme.thn. So tryhackme.thn, or actually it's tryhackrne.thn. So this is what we call typo squatting. It's like at first glance, RN technically kind of looks like an M, and then THN instead of THM, right? So this /downloads /suspicious package is what's happening here. So that's what's being downloaded, and then it's being done through a curl request through the command line. The response is a correct, meaning successful. So when you get a 200 response, that means it was successful. It came from a Nginx server, application zip file, content disposition, attachment, file name, suspicious package.zip, and it was downloaded. And then now we have binary zip file, bytes follow, etc. This many bytes. That is the number of bytes that is included inside of this zip file. So that's the size of the file essentially that was then downloaded. So that was the application layer. And so on the transport layer, the data segmented and encapsulated at this layer is in smaller pieces. Each piece includes a transport header, TCP or UDP, so we can look at the firewall log. So accept TCP from this source IP to this destination IP, etc. So let's look at the timestamp. I mean, they both happened on the same second, so it was instantaneous. So I don't know which one was first, and it doesn't tell me. I want to say this was the first one. I want to say this, or maybe this was the first one, because it came from port 51432. It went to 443, which is HTTPS, and then this one came from, and then you can see that this IP is right here, and then this IP is right here. So it here to this one, it was I'm guessing making the GET request, and then this is when this IP address responded to this IP address from port 443 and sent the data back. I want to say that's the order. Sometimes the top one or the first one is at the top. Sometimes the first one is at the bottom, but we can't really tell because the seconds are not changed, so it's kind of tough. Firewall logs often include the source and destination ports and the flags, but all the other fields are not included. However, they're valuable for detecting certain types of attacks like session hijacking. And this can be detected by analyzing the sequence numbers included in the header. If the sequence numbers are suddenly far apart, further investigation is warranted. The output shows a series of packets captured within WireShark. So the time, again, super close to each other. Source, destination, source, destination, different source completely. So this is, I would say, a communication that's happening right here. And then, so what we see, length is 74, 66, 1500. Okay, that seems to be that there might be a session that's being hijacked because there was such a long delay between this to this. That means it needed to go through a separate IP address so that new IP address can actually capture that session. It could hijack the session, and now we actually see a completely different thing. And now also right here, sequence 0, 0, 1, 1, 1, 345, 6, 7, 2, 3, 2. So what is that? 34,567,232. So it went from 0 and 1 to 34 million. You see, it's like, okay, that kind of seems to be a little bit, and I totally misread this. This is the length. This is not the time. I misread this completely. So I apologize for that. This is the length. This is not the time. The sequence will be closer to the time than anything else. If we were to look at it right here, there might also be a fairly large jump. It seems to be, right? Because it went from, 120, 220, all of a sudden 10,000, and then 10,600, 200,000. So now these are much closer to each other now, right? But these, from between this one to this one, there was a much larger gap. So that can also be a good little thing. The first 3 lines show normal, right, as we expected. And then all of a sudden, 4th and 5th line show legitimate data transfer. And then 6 shows a packet from another source trying to inject itself into the session. So this is what we see right here. But we don't see what is trying to be injected. So being that we're looking at this on WireShark, the next step would be to actually click on this line and look at the details of it just to see what's inside of it. Then we have the internet layer. So when the transport layer sends down a segment, the internet layer also adds its header. If the segment is larger than the maximum transmission, it will be divided into fragments and a header will be added to each of them. The fields that are most often logged are the source and destination IPs and then the time to live. This is sufficient for most cases, but if we want, for example, to detect fragmentation, we'll need to inspect the fragment offset and total length fields as well. There are different variations from this. So for example, an attacker can create tiny fragments to evade the intrusion detection system or mess up the reassembly fragments by using overlapping. The example below shows overlapping byte ranges. The offset in line 3, highlighted in yellow, overlaps with one in line 2. So if we go here, highlighted in yellow, I don't see an offset in, or maybe, no, I don't. This is the only one that actually has a yellow highlight. Down here, we don't see anything yellow highlighted. So, but it does say that the offset in line 3 overlaps with the one in line 2. So this is line 2, this is line 3. What do we see as an offset here? Length, maybe, fragmented IP protocol, offset 1480. So that's it, length 1480, 64. Okay, so this could be it. So this is the one, there said overlap right here. And I think that was supposed to be highlighted, but it's not highlighted. So they're referencing this one to this one right here. And then one more time, it's saying the offset in line 3 overlaps with the one in line 2. This means that the complete packet can be reassembled one way or another, and attackers can use this technique to bypass an IDS. Finally, the link layer. Once the internet layer finishes encapsulation, the IP packet is sent to the link layer, and it adds its header containing more addressing information. Most logs will display the source and destination MAC addresses for certain types of attacks. ARP poisoning or spoofing, the information in the logs won't be sufficient. For these types of attacks, we need to full packet and context For example, you can't see in a log when a MAC address appears from multiple interfaces or when many gratuitous ARP packets are sent out with conflicting MAC addresses. The example shows a packet capture detailing ARP poisoning, and the host with this is replying to each ARP request with the same MAC address. So ARP poisoning has to do with more the MAC address itself. And so we'll see the MAC addresses. These are MAC addresses, and these are the IP addresses, right? So we'll see relayed via the attacker right here. This one has been relayed. So this will be the first one technically. So the ARP request is who has this IP address, tell this IP address. And then so this one says that, or on this line it's saying that it's not at this MAC. And then it is at this MAC. And this one is also at this MAC, which doesn't make sense. You can't have two IP addresses being at the same MAC address. That's typically not the case. So when you see two IP addresses coming to the same MAC address, it's like, okay, there's probably ARP poisoning taking place or MAC address spoofing taking place. So looking at the example in the task and answering this, what is the size of the zip attachment included? Note down in the answer in bytes. So it was up here, right here. So this is the size. Let me highlight this. Boom. I don't think that worked because my keyboard went to sleep. So let's right click and copy. And let's go down here and paste that. Okay. Please ensure it follows the exact. It does. I included the commas. So that's okay. So I can't. Good Lord. Got to delete that. Got to delete that. So what comes after the 7? 60 comes after the 7. So there we go. Which attack do attackers use to try to evade an intrusion detection system? And so we saw it just here. I can also just search for IDS to try to find it a little bit faster, but it was in here somewhere. So let's just search for IDS. And then, so there we go. For example, an attacker can create tiny fragments to evade IDS or mess up and we can to bypass. So this means that one way or another, what is the name of the attack that they're looking for? The name is fragmentation attack. I'm going to copy that. I want to say that's the answer that they're looking for. So I think fragmentation is what they're looking for. All right. What field in the TCP header can we use to detect session hijacking? So that is another thing that we can just go ahead and kind of search for. Session hijacking can be detected by analyzing the sequence numbers inside of it, and voila, boom. All right, let's go into sources and flows. Okay, so now we need to look at the various specific sources and the flows of traffic. So sources could be endpoints, and flows would be considered in transit or intermediary. So corporate network typically has some predetermined network flows and sources. You can look at them as endpoints or intermediary. So the flows can be grouped into two categories: north, south, or east, west. Traffic that exits or enters the LAN and passes the firewall is considered to be north, south. East, west is something that stays within the LAN. So it's all inside of the local area network. It's our network and they're going back and forth with each other. And the LAN that also extends to the cloud is also a part of east-west traffic. So north-south is in and out. East-west is internal, right? So let's explore these. So sources, two network traffic sources, endpoint and intermediary devices. These devices can be found within the LAN and or the WAN. Intermediary sources, they're devices through which traffic mostly passes. While they generate some traffic, it is significantly lower than what endpoint devices generate. Under this category, we can find firewalls, switches, web proxies, IDS, IPS routers, access points, wireless LAN routers, and many more. So maybe less relevant for us, but all the infrastructure of internet service providers, also known as ISP, so basically where you actually get your internet, is also considered part of the intermediary. These are the internal, right, in transit. They're all internal east-west traffic. That's what all these things are. The traffic that originates from these devices comes from services like routing protocols, management protocols, logging protocols, and other supporting protocols. Endpoint sources, these are the places where traffic originates and ends. So These take the bulk of the network bandwidth. Devices that fall under this are your servers, hosts, meaning individual computers, or IoT devices. Actually, IoT devices have their own category. Printers, virtual machines, cloud resources, mobile phones, tablets, etc., etc. So technically, IoT in this particular case is not being referred to as a mobile phone or a tablet, but technically mobile phones and tablets can be IoT devices. An IoT device in this particular context would be something like a smart TV or I was going to say a smart printer, because the printer is also connected to the internet, but like a smart TV, a smart fridge, a smart thermostat, or anything along those lines, right? Flows. So traffic flow is typically determined by the services available in the network, such as Active Directory, server message block. Yeah, server message block, I want to say. HTTPS, so on. In a typical corporate network, we can group these flows into, is this server? I'm stuck on this. It is server message block. I was just, my mind wasn't allowing me to move on. In a typical corporate network, we can group these flows into north, south, east, west. Again, so north, south in a corporate network, right? North, south is often monitored closely as it follows from the LAN to the WAN and vice versa. Most well-known services would be the client-server protocols like HTTPS, DNS, Secure Shell, which is for remote connections, virtual private networks, SMTP, remote desktop protocol. So SSH is typically for Linux and Unix, and RDP is typically for Windows. SSH is also used for Mac, which is a Unix based, but it's considered to be Mac OS. So, but it does have a Unix base. So the terminal commands inside of a Mac terminal are pretty much identical to what is inside of Linux and Unix machines. So each of these protocols have two streams: ingress, which is inbound traffic, and egress, which is outbound traffic. All of this passes the firewall in one way or another. Configuring firewall rules and logging properly are key to visibility. So this was the north-south in the corporate network. Then we have east-west in the corporate network, which is staying within the corporate LAN. So it's often monitored less. However, it's important to keep track of these. When network is compromised, an attacker will often exploit different devices and services internally to move laterally within the network. As we see, there are many services within this category. You can expand on them. So directory services, Kerberos, Radius, Certificate Authority, LDAP, Lightweight Directory Access Protocol for authentication queries to Active Directory. Then we have TechHacks and Radius, which is for network access control. Then we have Certificate Authority issuing internal certifications. So certificate authorities, we talked about this, I think, in the last video. But if you click on this on your browser, if you click on that, depending on your browser, so I'm in a Chrome. So when I click on that, it looks like this thing right here. But sometimes it's like a lock icon. So when you click on that, this is here. So if you click on that, it says certificate is valid. If I click on this, then it opens up this thing. And then it says certificate authority. So where's my certificate authority? Well, actually, it should be this right here. So the issued by is where the certificate authority is. And so in this case, the organization that's issued it is Google. But sometimes it's actually referred to as a CA, and then it'll say Google Trust Services. But in this case, it's issued by. So this is my certificate authority right here. And let's see anything else over here that we might find useful. No, but that's basically it. So that's a certificate authority. So certificate authorities for web traffic, for internet usage, usually need to be a known CA. Otherwise, your computer or your browser will not recognize it unless you actually manually tell your browser to recognize it. But if somebody is just a client of your website and they're not familiar with that process, they will get this error message, like this "don't move forward" kind of a message. You probably have seen it, and it's like, be careful before going into this website. It's likely a malicious website, and you may not have a malicious website, but you created your own certificate. Therefore, you're not a recognized CA, and so the browser doesn't recognize you. Therefore, it doesn't automatically allow people to go through your website. File shares and print services, so server message blocks, CIFS, IPP, LPD, so accessing network drives, printing over the network, router switching, and infrastructure services, application communication, backup and replication, monitoring and management. These also, if you want to like pause the video and just go through them in case you don't have access to actual TryHackMe. So 1, 2, 3, pause, good. Next one. 1, 2, 3, pause, good. Next one. 1, 2, 3, pause, good. Now you can read through all those if you wanted to. So let's have a visual. So HTTPS, there are different versions of this. We can look at what a web proxy does, TLS inspection. So this is kind of what the visual of it looks like right here. So web server, this is the internet, right? Or the cloud, we can say. TLS session between web server and web proxy. The proxy will act as the firewall here. And then this is our local area network. The wide area network is considered the internet. So the internet is just a very giant wide area network that includes a bunch of local area networks inside of it, right? Millions of LANs. So what you see is that a web server from some website is connecting to the internet, trying to connect to you on your computer right here, but it has to go through this proxy first. And then the proxy will connect to your router, which will then connect to your switch, which will then connect to your host. Many people inside of their home networks do not have a switch. However, their router will kind of act as a switch because it'll have Ethernet ports that you can plug into it and attach to various devices should you need to do that. But for the most part, in a corporate environment, there will be a router that will receive the internet service from your internet service provider. And then from the router, it'll connect to the switch. And then the switches will then connect to different sub networks inside of your company, inside of your office or your building. And those will all individually be their own little mini LANs, or if we call them virtual LANs. So external DNS traffic within a corporate network starts when a host sends a DNS query. So this is what we see right here. So again, the internet is represented by the cloud in the wide area network, the local area network with the router and the switch. And then now we have the internal communication being back and forth down between the DNS server and the host itself. Now, again, inside of your local area network, your actual computer is doing its own thing by using the host's configuration, which connects all of the IP addresses to domain names that you've ever used or visited, and it kind of acts as that DNS server. But in a corporate network, the domain is much larger. They have subdomains and individual computers inside of that subdomain. So they need to have an internal DNS server, which will then serve as this kind of the internal traffic, which we call the east-west, right? And then back and forth right here, this would technically be north-south. I know this is confusing because east-west goes this direction and then north-south goes this direction, but because this is inside of the network, this is considered to be north-south. And then when we're going back and forth between the internet and our network, that's called the, I'm sorry, this is east-west. I think that's what I said, right? East-west, and then this would be north-south. I confused even myself. Okay, so SMB with Kerberos. When a host opens a share, for example, this, an SMB session is set up. First authentication is done via Kerberos, which is a ticket sharing, ticket granting kind of a system. And then when a user logged in on the host is authenticated with the key distribution center on the domain controller and receives a ticket that grants other tickets to request server authentication tickets, also known as tickets granting service. Now the host requests a service ticket using the ticket granting ticket, and the host then uses this ticket to establish SMP connection, SMB. Once the SMB session is set up, the host can access the share. Below, we see a simplified network diagram of this flow. You see it right here. So there we go. The cloud or the internet connecting to our network. Inside of our network, we have these various services. Our computer is trying to get access to a service, right? So first, the computer needs to communicate between the key distribution center. The key distribution center grants the ticket granting ticket. So a ticket that grants other tickets. And then our computer will use that ticket to go get a ticket for a service. So this ticket will give you access to more tickets, and then you use this ticket to get tickets that access services, right? Hopefully that makes sense. I've said tickets so many times that it's lost all meaning for me. Which category of devices generates most traffic in the network? And these were the internal, right? So it was the what is it called? It wasn't called internal. They were calling it intermediary, right? So while they generate some traffic, is significantly lower than endpoints. So endpoints, they're the traffic take the bulk of the network bandwidth. So I would say it's the endpoint devices that would generate most of the traffic. So let's try endpoint. All right. Before an SMB session can be established, which service needs to be contacted first for authentication? And that would be the ticket granting Kerberos, right? So Kerberos, that would be the Kerberos system, which access the key distribution center, and then ticket granting, ticket Transport layer security is what TLS stands for. And we're good. So TLS is just kind of extra note here. TLS is in the same spirit as SSL, and SSL was the first layer of encryption when web communication and email and a bunch of things were happening. SSL stands for Secure Socket Layer. And then when TLS was developed, SSL kind of became grandfathered, and it's not really used as much because it's not as secure as TLS can be. Now, let's go and do this exercise. Okay, for this exercise, we're going to use this view site button, which has opened this site on the right-hand side. There is a good amount of instructions for us here, though. So we have a few different sources of information. We have logs, which is our first entry. So the authentication log, Apache Web Service access log. These are some samples that we can see right here. Even though there's no standard logging way, there are some protocols that offer a standardized way of sending log messages. When the logs don't provide enough information, we have to dig deeper, which would be done with the full packet capture. And this can be done with something like WireShark, for example. So network tap is a physical device that you place inline your network, and they create a copy of all the network traffic that passes without affecting performance. That copied data is then forwarded to a packet capture box, IDS, or other system using the dedicated monitoring port. It is interesting to know that a network tap operates only on the link layer because it is a physical device that's actually connecting to our devices via Ethernet cables. And it doesn't need a MAC or IP address because it copies the electrical light signals, sends them to its monitoring port. There's no added delay to the network. The image shows the example of a network tap. So ProfitShark, I'm guessing, sounds kind of like it would be Connect or ProfitShark, not ProfitShark, ProfitShark, I think. It sounds like it would be by the same people that developed WireShark. Port mirroring is a software approach copying packets from one port to an intermediary device that is attached to, for example, an IDS, the packet capture box, or other systems. Each vendor has its own name. Cisco calls it SPAN. On the terminal below, we can see the how to configure SPAN on a Cisco device. Packets going through fast Ethernet are duplicated and sent to fast Ethernet 2. So you can see right here, the switch configuration mode is on, monitor session 1, source interface Ethernet 1, and then monitor session 2, destination interface, or excuse me, monitor session 1, destination interface is Ethernet 2. There you go. So this is what that looks like. So you have the switch itself, and then you have a variety of different devices, right? So on step 1, the host itself is connected to the switch. The switch sends the data to the DNS server, and it also sends those packets to the monitoring device. So 2 and 3 are happening at the same time right here. So whatever is requested will be sent to the server as well as the monitoring device, and probably vice versa as well. Okay, so the intermediary devices do not necessarily need to be physical. Port mirroring can also be configured on a virtual device such as VMware, vSwitch, cloud environments. Also have specific devices that offer mirroring, AWS for example. When doing full packet capture, we need to take some things into account. Placement, depending on which traffic we want to capture, we need to place the tap or configure the mirror in the right place. Duration, full packet capture will require a proportionate amount of storage. If you capture traffic on a 1 gigabyte per second line for a whole day, we would need an average of 10 terabytes of storage space. Imagine the amount of storage space we would need on a 10 gigabyte or 40 gigabyte line. Very crazy. Mirror versus tap. Physical taps offer close to zero performance reduction. Mirroring can impact performance. So open the static site. Okay, so this is what we're going to end up doing. That's the part of the exercise. Is there another piece right there? No. So from here, we'll just do this. So it says open the static site and complete the 2 exercises by placing the tap in the correct position and uncovering the flag in the traffic. Fill in the flags. You can open the static site by clicking OK. Okay, very good. All right, so let's look at this right here. Come on, let's zoom out. All right, here we go. So let's go here. Right here, we have the packets. That's the network here. It can be done in full screen or no. It says it can be done in full screen, but it's not doing it. Can I zoom in and out? I can't. Okay, so here's the first one. After a user using a random workstation clicked on a phishing link and an HTTP request was initiated and downloaded a malicious PowerShell file. If we had wanted to capture this web traffic, where would we have had to place the tap? Place the tap at the most efficient place to view web traffic, find the HTTP response containing PowerShell script, and get the flag. Okay, so where are our devices? These are our devices. It says user using a random workstation. So I'm going to read through these real quick, and then I will go ahead and also read through the rest of these notes because I think these are actually important. So we have the devices, reset. Oh, that's basically it. Okay, all right. So let me go and do full screen like this so we can look at it like this. Okay, great. Alrighty then. So now we need to go ahead and place the tap. Now, right here. So if I'm going to click start right here, and then the tap will be given to me, and then I can go ahead and drop it into any of these locations that say drop, for example, like this. So if I go here, we can see that I can drop them at any of these locations to try to capture the traffic that we're trying to find. So in this case, the user clicked random workstation. In a random workstation, clicked on a phishing link. So we have our workstations here. And then from here, that connected an HTTP request and downloaded a malicious PowerShell file. So let's see. If it's a random workstation, we don't know which one it is. So we need to be able to find a place to drop this that will capture everything for all of the workstations. So I will go ahead and do that. Most likely, let me zoom in here. So, server, Windows 1, Windows 2, Windows 3. So these could be all the users because these are servers. So these could be all the users. So technically I could just drop it here. That would probably be the best way to do it because this is a switch that connects to all of the individual users. So that might be the easiest way to do it. I'm probably just going to drop it there. So let's click start, drag the tap right here. Wrong place. While you could view all traffic, one device is connected to switch. Capturing and analyzing traffic and time consuming. Okay, so fine. So then what? Do it here. Wrong place. Why? Why is it wrong if it's not any of these things? It doesn't make sense because I want it to, and it definitely wouldn't be on the server, so I don't exactly know. I don't understand why that's not the case. So what? I go here? That's also not the case. And what the hell? It also would not be the case. That's the one. So this is what? I don't get it. So random workstation clicked on the phishing link and it downloaded malicious traffic. If we had to capture this, where would we have had to place? And I don't get it. I thought that it was something that we would need to do with the individual workstations, but it's asking us to do it right before. Oh, I guess maybe it's because it's going into the firewall. I don't know. Okay, so now we're looking for the HTTP response containing PowerShell script and then get the flag format. So there are very many of them and there needs to be more details in here, and it could probably be inside of the, my God. So I will most likely need to find the specific document that actually has the PowerShell script download, assuming that it actually shows it which it doesn't seem to, because these are zip files, JS files, and we are most likely looking for a PS1 file. PS1 is a PowerShell script. Oh, there we go. So it actually is a PS1 file. Okay, so then in this, we're looking for the actual flag itself. So it's THM, etc., etc. So what do I need to do now? It says inspect the packets inside to find the flag, then click on the proceed button to continue to scenario 2. So this is the PowerShell script. So now it says where would we have had to place it to find the PowerShell file, place it in the most efficient, find the HTTP response containing the script, and get the flag. So it's in here for sure. So we're just looking for something that would actually have the flag in it. So let me see, what would it be? It was in the very next packet. So if we pay attention to it here, the source IP connected to this destination, which did a GET request, so it downloaded the PowerShell file from this destination. The very next flag down here is from that destination to our source IP, and inside of it is actually the flag itself. So that's what it is. So there we go. All right, cool. Relatively simple. Let's make sure that that's the one. All right, great. So let's now move into this next exercise, saying proceed to scenario 2. So workstation was compromised. Malicious C2 instructions were infiltrated via DNS TXT records. If we had wanted to capture this DNS traffic, where would we have had to place the tab? Please tap at the most efficient place to view DNS traffic. So I would put it at the DNS server. That is right over here. There we go. So easy money. That one was very quick. So now it says find the TXT DNS record and get the flag. So what is it? It says malicious C2 instructions were infiltrated, and then we need to find the flag for those TXT C2 instructions. So this one, let's see, it's still also 3 pages of data. So we're looking for a TXT record. So this is very important to understand. This right here, as you can see, this is an A record. Oh, I didn't want to open it. Good Lord. Okay, so that's an A record, name server record, CNAME record, etc. So we're looking for TXT, right? So that's the type of record pool or DNS call that we're looking for. MX record. This is IPv4, so it's not that either. So, all right. So it seems to be TXT. Okay, so there's a TXT record right there. And that's the only one. So let's look at this one and let's see what's in here. Query TryHackMe TXT. There's nothing inside of it that would imply C2 connectivity, and there's no flag in there either. So let's try to find another this is another TXT. Okay, so the second TXT here. Does it have? Oh, it does. There we go. So there's the flag. So boom, there you go. I mean, this is like really straightforward. This is very, very simple. But I think the biggest lesson here is where to place the actual tap that they're talking about. And so the specific point right here, the WP1, I'm really curious what WP1 was. Web proxy, that's why. So all web traffic passes through this device. Okay, so that makes sense because we were doing, for that first scenario, we were doing we were trying to find which device captured or downloaded that PS1 file. And I was like, okay, well, why don't we just put it next to the position where all the devices are? Which also, by the way, it's like, okay, well, that means that I think the error message that we got when I did this, it was that, if you put it right here, you're going to capture way too much data. And it makes sense because it would capture all of the data between these guys to each other and internal network to the server and the DNS right here. So it would capture way too much data. And we're mostly interested in web proxy data or website data because it was something that was done via HTTP that downloaded something from the internet. So in that case, we want to look at the web proxies data because the web proxy only has to do with the web. So that actually makes a lot more sense. I should have paid closer attention to this list of devices that they provided to us, and that would have made so much more sense, and I would have been able to find that answer much, much quicker. If you found value in this video, then I encourage you to like, subscribe, and turn on the notification bell so that you can get notified the next time that a video comes out on our channel. And of course, there's videos coming out all the time. The current playlist that we're working on is the SOC Level 1 playlist. And as soon as this one is done, we'll be going back into the CompTIA Pentest Plus and Pentest Plus labs just to make sure that we wrap that up as well. And then by then, I will have done a lot of experimentation with artificial intelligence integration via API endpoints and source code and things like that. So I will have a lot of data and intelligence and lessons that I can share with you so that you can go ahead and learn about integrating AI, because that is where the future is. We are currently, as I'm recording this, we're on 499 videos, which is really insane. We're about to hit 500. I think actually by the time that you see this video, because there's a couple of other videos that I've already recorded that will be posted. So I think by the time you see this video, it will be over 500 already, which is really, just really crazy to think about. Very crazy journey. We've been on a very, very crazy journey for this channel. If you have any comments or questions, drop them in the comments section below. If you just want to say hi, if you want to make comment recommendations or content recommendations, drop in the comment section below. Keep an eye out for everything that we're doing for SOC Level 1, as well as all of the CompTIA stuff and hopefully our application being approved with CompTIA to become one of their approved vendors and educators, accredited educators, I should say. And there's just nothing but good things down the line. So the future is very bright. I'm very excited to be working with you guys on this and to provide as much value as I possibly can for you. Make sure, if you have not done so already, to like, subscribe, and share. And of course, drop a comment and turn on the notification bell so that you get notified the next time that a video comes out on this channel. And finally, if you have not done so already, make sure that you check out Hackaholics Anonymous. If you want access to my notes and exclusive downloads and to get lifetime access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers. We have the supporter, the agent, the guardian, and the master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below and you will be able to choose the tier for which you want to join. I really hope I see you in the Discord chats. If not, I hope I see you in the comment section. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease. And I will see you in the next video later. Today we're going to talk about WireShark, which is the industry standard tool for packet capture and for granular packet analysis. If you've never used it, you're going to be very pleasantly surprised. My name is Hank Hackerson, your trainer for today, and to get more videos like this one, make sure that you like, subscribe, and turn on the notification bell. For this video, we're going to be using the WireShark basics room inside of the TryHackMe module for packet analysis, network traffic analysis, which is inside of the SOC Level 1 pathway of TryHackMe. Now, you can actually download WireShark for free on your own computer, and you can essentially do everything it is that we're going to be doing for the next several videos, which is all centered around WireShark. If you don't have access to TryHackMe, I do recommend that you actually get access to TryHackMe. They have hundreds of rooms for free available, so you don't need to have a paid subscription. But if you do get a paid subscription, you get access to all of the other rooms in addition to all of the virtual machines and the attack boxes, etc., etc. So it's a very good, in my opinion, it's a very, very good deal, and it's a very good service. I get nothing from it. Other than the fact that I get to actually share this information with you and hopefully to kind of help train some of you guys on using these tools, because WireShark is a very important tool for packet analysis. You're going to be using it in security analysis a lot. It'll go in conjunction with tools like Splunk and Elasticstack and things like that. So we use WireShark both for defensive analysis as well as offensive pen testing, and it can serve a variety of different purposes. So very, very cool tool. I think you will get a kick out of it. The machine for this room I've already started because it takes a couple of minutes for it to start. We're going to go through the introduction, the overview of the tool, packet dissection, so what it actually means to look at a packet, the navigation of a packet, and then the filtering of packets. And then we'll have our conclusion, we'll wrap it up, and then you will be dismissed for today. And all of these things are going to be to be timestamped. I kind of froze there a little bit. They're going to be timestamped in the description below, so you'll get access to that as well. And that's pretty much it. So quick little note from Hackaholics Anonymous, our membership community, and then we'll dive into the introduction. If you want access to my notes and exclusive downloads and to get lifetime access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers. We have the supporter, the agent, the guardian, and the master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below and you will be able to choose the tier for which you want to join. I really hope I see you in the Discord chats. If not, I hope I see you in the comment section. Okay, so here's what the text says. WireShark is an open source cross-platform network packet analyzer tool capable of sniffing and investigating live traffic and inspecting packet captures, which is also known as PCAP files. It's commonly used as one of the best packet analysis tools, and in this room we'll look at the basics of WireShark and how to perform fundamental packet analysis. So key point here is it's open source, and then you can use it to analyze live traffic as well as packet capture files. So essentially a live investigation or live pen test, something like that, in addition to doing digital forensics investigations or kind of reverse engineering what may have happened during a day of traffic inside of your network, etc. Our objectives today are to navigate and configure WireShark, inspect packets, and discover more information from the different layers of the TCP IP model and apply display filters. And then as we go further through our network room, or our network module, I should say, our networking module, we're going to be learning more about the advanced elements of WireShark and how to use it to do some really nice investigations. I've already launched the virtual machine for this setup, so it's good to go and ready to go for us. And we're going to be using 2 packet capture files. One of them is the HTTP1 PCAP, which, as you can kind of imagine, it has to do with HTTP traffic, also known as web traffic, or something that goes through a web server. And then we also have the exercise PCAP file to answer the questions towards the end. So should be pretty cool and exciting. It says which file is used to simulate the screenshots. I guess this is the HTTP one that is used in the screenshot, so that's going to be the answer to that question. It's kind of a silly question, but there we go. Not PCAP NB, PCAP NG, right? What is it? Yeah, PCAP NG, HTTP1 dot PCAP NG. Why am I not getting? Oh, I'm going too fast. I see. I need to wait for it to give it. Okay, and then which file is used to answer the actual questions? And that one is this one. I'm just going to copy it instead of typing it and making an error. So boom, that one's good. And then this one should also be good. Yeah, I'm still going too fast. Well, that is the right answer. So I'm just going to give it some time before I try that answer again, and then we'll go into the next section. Okay, so here we go. Being that we're going to be using that one PCAP file to go through all of these screenshots that's available to us over here, I'm mostly going to load the actual virtual machine, and I'm gonna read through each one of these sections on my second monitor, and I'm just going to display them on the virtual machine just so you can see what it's like instead of kind of looking at screenshots and trying to make sense of what it's like. And so a lot of these things are super basic anyways, so it's not going to be this like really complex thing that we would have to do deep investigation or anything like that. We're just trying to get familiar with the actual interface of WireShark as well as the different elements of it when we kind of start analyzing packet capture files or packet captures in general. So again, this is one of the most potent analyzer tools that are available. We can use it to detect and troubleshoot network problems like network load failure points and congestion, detecting security anomalies like rogue hosts, abnormal port usage, and suspicious traffic, and investing in learning protocol details such as response code and payload data. And I will again go to and say that we can also do penetration testing, investigations, and reconnaissance using WireShark because you're technically capturing packets inside of a network. So if you're connected to the network and you can see the various interfaces on the network, you can capture traffic through WireShark and then analyze what's going on inside of that. And if the packet capture is coming from a specific port or device that is not encrypted, you will get to see clear text data. For example, somebody's username and password through these packet captures, and that just by itself is like, okay, well, I don't need to do anything else. Now I have your username and password and I can hack you. So it's super, super simple. It's not going to be as common because hopefully, you know, the security posture for most companies will be a little bit more solid than that. But, you know, a lot of times you get lucky and that can be the case. A big note here is that WireShark is not an intrusion detection system. It allows us to discover and investigate the packets in depth. So you have to know what you're looking for. It doesn't modify packets, it reads them. So detecting any anomaly or network problem highly relies on the analyst's knowledge and investigation skills. So things like this specific sense right here, you know, it doesn't do intrusion detection. You need to actually know what you're looking for to see if you can detect intrusions. On here, it doesn't allow us to modify packets. That would be something that would be done through a tool, let's say like Burp Suite or something like that, because you can actually kind of modify the back and forth traffic, and before you send it back to the web server, you can try to modify the data in the packet itself. So those are the kinds of things that can be done with different tools. With this specific tool, we're not going to be able to do that. We are just going to be analyzing the data and the traffic, and it relies heavily on our knowledge and investigation skills. So that being said, we can now talk about the GUI or GUI. I don't know how you want to pronounce it. Some people told me that it's supposed to be pronounced GUI. Some people say it's GUI. I call it GUI because it's a little bit faster. It stands for Graphical User Interface. And there's actually something called T-Shark, which is the command line version of WireShark. It's not as in-depth, but it's still super cool and really useful. And we can use it for command line investigations if you're more comfortable with the command line. So we're going to be looking at the toolbar, display filter bar, recent files, capture and filter interfaces, status bar, and then the various different elements of those specific screens. So that being said, I'm going to go back up here and I'm going to click on split view, and then we'll see the split view. I'm going to open it up in full screen. Let's see if it's super zoomed in on the full screen too. Let me close this out right here. Sometimes it is super zoomed in, and it looks like it is super zoomed in on the full screen. So I'm going to zoom back out a little bit right here so that our full screen view is also zoomed out. And then gotta give it a quick second to reconnect. There we go. And we're going to now load WireShark, and then we're going to go through those different elements of it. So here we go. Once you load WireShark, at the first glance, this is exactly what it looks like, right? This is the dashboard, like the home screen, basically, of WireShark. And so we see welcome to WireShark right here, right? And then there's a couple of PCAP files that it automatically detected for us that we can potentially open with it. It actually has the paths to them. So I can technically open them by just like right-clicking or not double-clicking on these. I can just open them for analysis. Or I can go here, do file, and then do open. Very similar to Microsoft Word or any other tool you would have ever used. There's always a file open option. And then that way we can open the file. So that's one way of opening the files. And another way is to actually capture the files themselves. So the capturing of the files, or the capturing of the traffic, I should say. The capturing of the traffic would be done here. Now notice that capture shows right here. So it says enter a capture filter. If I wanted to actually filter the traffic, I could literally type something like HTTP or, you know, IP something, right? IP broadcast equals, or IP multicast equals, or IP6 if I want IPv6 traffic, etc. So I can actually filter the capture through capture filters, or I could just capture everything, and then I could choose a specific interface. Now, these lines that you see right here represent the activity of that interface. So if we look at this, system D, for example, would be the internal system for this virtual machine that I'm on. It's a architecture of Linux, right? So system D journal export, it could actually export if there was activity, we could say. But the flat line represents that there is no activity, so we really won't be capturing anything. SSH remote capture would be done for the port 22 for remote control or remote connections, but again, there's no connection being done on here, so we don't really see anything. Now, what I am curious about is because I loaded this machine right here by just clicking on this virtual machine button, and I'm really curious if I went to actually start the attack box, and it doesn't show an attack box button right here. So I think we can't use an attack box in this case because it's already just automatically loading a Linux machine for us. So sometimes we can load an attack box and we can use that attack box to do an SSH connection. As you can see right here, we can do an SSH connection to the machine that we're in right here, and that might generate SSH traffic for us. But in this particular case, there is none, so that's kind of pointless. There's the UDP listener, etc., etc. And a lot of times, the actual interface itself will show up. So let's go and look at what that actually looks like. So if you go into your command line, and for Linux, or isn't it ipconfig or ifconfig? It's ipconfig, my bad. What? How is that even not found? I don't understand why that's so crazy that we can't even see any of that stuff. So I need to see what's going on to be able to see the different IP addresses that we have available. That's so interesting that we can't see it. Usually, we should be able to do ifconfig and actually show where we're looking for. Or so maybe it's not in my environment variables. Maybe that's what it is. So if I do something like sbin ifconfig, there you go. Okay. Because I'm like, why isn't it working? I know I'm inside of a machine that can do this. Okay, all right, cool, perfect. So, all right, I panicked for a second there. I was like, am I forgetting how to use these machines? Okay, so this is the interface that's actually the active interface on the machine that we're on right now. So ENS5, right? And then the LO is always available on every single machine. It could be local, it could be loopback, depending on how you want to read it. And it's always going to have the 127.0.0.1 IP address. So this specifically kind of is useless for us. Like, we won't be able to really capture any substantial traffic or any what's a good valid, I guess is a good word, but any traffic that would mean anything meaningful, right? So the traffic that we would be looking for on this specific interface would be on the ENS5 interface. Now, a lot of times it's ENS0, but you're looking for something similar to this. And then you can also see that my IP address is right there for this specific machine. And then I can even go ahead and verify that, right, by looking over here. And then I can see that this is the IP address that's been assigned to my virtual machine. So if I were to capture anything on this specific portion right here, if it was loaded for me right here, I could just do ENS5. I could just choose ENS5 and then capture it right there, right? And then it would do a live capture. So any of these things, I would click on it, and then I would go up here, click this button, this little shark fin button. It would start capturing. Immediately, it would start capturing, and then you would see the screen start to populate. And then when I want to stop capturing, I would press this stop button because it would actually be visible at that time. It wouldn't be grayed out. And then I would be able to go ahead and stop capturing the traffic. And then now I can analyze the traffic, right? So that's basically everything that we would need on the home screen right here. So when we go through the documentation right here, it says, we want to look at the toolbar and a variety of these things, right? So the toolbar is this portion up here. This is the toolbar, basically. This thing right here, this is the actual toolbar. Everything from file all the way to help, and then everything underneath it, all these buttons right here would be the various elements of our toolbars. These could be our recent files. So I guess that it's not necessarily that it detected the PCAP files on my system. It could be that these files have been used previously for this specific exercise. So it's part of the recent files. So that could be something that's available to me over here. And then this is the capture section where we can actually capture and filter the available interfaces for us to be able to sniff. And again, so let's go back to the actual screenshot because this is a little bit more useful for that example. We can see right here that it actually says ETH0, which is the interface, and then you can see the squiggly lines implying that there's traffic on this interface. Any would be any of the interfaces that's available, and of course that's going to have traffic on it as well. The loopback LO has nothing next to it, right? Docker has nothing, Bluetooth monitor has nothing. So it's actually showing all the various interfaces, but for whatever reason, this specific machine on the interfaces shows nothing, which is kind of annoying. So let's see if what we can find under our options here, and if we can actually find anything for the inputs. But on here, again, it's also not saying anything. So let's go to manage interfaces, and it's not listed on any of my interfaces right here. I don't have any local pipes right here. So it's kind of annoying, the fact that the interface itself is not showing right here. I think it may have been configured on this machine so that I don't do any packet captures, and we actually just use the packet capture files that are available for us, which is fine. I'm really not upset about it. It's just more than anything else, I just wanted you to see what it's like. So okay, so now we are inside of the http1.pcap file, and then we can see that right here. So we are now loading the http1 pcap file, and then we can see right here that we actually have packets that have been analyzed for us. This is our packets list. So this portion, this in the central portion of the screen, the largest portion of the screen is our packet list. On this bottom left portion, these are our packet details, and then we'll go into this in a little bit. And then on the bottom right, these are the packet bytes, so hexadecimal as well as byte portion. So you can see kind of on the right portion right here, as I move my cursor, it highlights the individual bytes or the sections of bytes on this left portion right here. And then if I highlight any of these, it'll highlight that element of it on the hexadecimal part on the right hand side. So all of that stuff is available to us as well. At the bottom, we have the entire number of packets that have been captured for this PCAP file. So we have a total of 43, and then 43 are being displayed because we don't have any display filters on here right now. So for example, just to give you a quick example, if I search for HTTP and I do enter, right, press enter, now there's only 4 packets that are displayed. And so if I go down here, I can also see out of the 43, there's 4 packets displayed. 9.3% of all of the packets available has been displayed to me. So that is how you can see that. And we'll probably have to do that for some of the questions as we go on. And then we have the various colors, as you may have been able to notice. So let me kind of press enter one more time just so we can see everything. So you can kind of see that there's like different colors. Most of these are green. Okay, here we go. There we go. So we have the black lines right here. These are pre-colored. So you can always change the filters of these colors so that you can see what potentially, I don't know, customize it for your own views. The way you do that is you click on view and then you go to coloring rules, and then coloring rules will bring this up. So right now, as it stands, the stuff that's in black with the pink text is a bad TCP connection, for example. That's what it is, right? And then the stuff that's in green is the HTTP. Yellow is kind of SMB, server message block, routing, etc., right? So you actually get to see those as well. But you can always change these. You can actually change the coloring rules for yourself just to customize it. And this is when you have your own installation, not necessarily when you're using a virtual machine like the one that I'm on right now. I wouldn't necessarily go ahead and change these coloring rules, because as soon as the machine gets restarted, if I have to restart the machine, it's going to reset all of those coloring rules, which is going to be pretty useless. It's going to be kind of annoying. So I don't need to necessarily do that right now, but you can do that when you have your own installation and you're working for a company and you want to have a full understanding of everything that's going on at a glance, and then you can look at those coloring rules and customize those coloring rules so that you can really, at first glance, like real quick, you can be like, oh, this section of traffic is this and this section is this, etc. There is a portion of the text right here that actually goes through the packet capture, the live packet capture part right here, and we actually have a screenshot that's a little bit more useful, because we can see on the top left that there's actually the stop button. So they're actually capturing traffic, and they're capturing it from the ETH0 interface, and then they now have the option of going and stopping the packet capture. As it stands right now, there's 122 packets that have been captured on this live capture, and then we can see that there's a variety of protocols: UDP, MDNS, SSDP. That's basically all we see, actually. But that's what it looks like when you're doing a live packet capture. That stop button actually shows up, and then on the bottom right, you get a live count of the number of packets that are being caught. And then at the bottom right here, there's the live capture in progress as well. And then at the top, you can also see capturing from ETH0 here as well. So pretty handy, pretty useful. And then finally, we have the merging of multiple PCAP files. So we can do this as well. There's a GIF for us here. So let's see if this is actually going to load. There we go. Okay. So it's going to go merge, right? And then going to choose the merge and actually add the new button or the new PCAP for it. And then at the bottom, you see right there that there's now 58,000 packets captured instead of the basic of that 43 that we saw for the HTTP one, right? I'm not going to do that because I don't want to merge them. I don't think I need to. I think it's better to just kind of keep them separate. But as you can see right here, you can do the merge by just simply clicking merge and then just adding the new file that you want to merge into your current file. And then it'll show you the full details of it, the number of packets, and then you can do the filtering and everything else that you want to do. And then what they're doing at the end right here is that they're saving the new merged file. They're doing a save as option, and then they're just renaming it so that now they have a version of that file that includes both. So you see 43, as soon as he clicks the merge, it turns into 58,000, and then they're going to save it as a new merge file by just simply clicking save as and then saving it as a new file. And then we have view file details. Knowing the details is very helpful. So when we go ahead and do the GIF again view right here, you can see down here there's a little button that they can click on that'll show you all of the file details. So I can go right here, this is the button at the bottom right here, this thing right here, and I can click on that. So file properties dialog, click on that, and it'll show me all of the details of the file, the length of the file, the location of the file, the SHA-256 hash value, which is handy actually. This hash value, SHA-1 hash value. The format of it, encapsulation, is that it's an Ethernet encapsulated file because it's an HTTP file. We get to see more. Let's see what else we can see. Oh, right here. So the number of packets, 43. Time span is 30 seconds right here. Average PPS, pixels per second, I guess, or that's actually a good one to look into. Packets per second, maybe? I think that's what it is. Not pixels, packets. Average packets per second, there we go. And then average packet size in bytes, and then the total number of bytes, average bytes per second, average bits per second, and that's pretty much it. Those are all the details that we get from this specific packet capture file. Cool. So now, using the exercise PCAP file to answer the questions, read the capture file comments. What is the flag? Okay, so now what we can do is this. We can just open a new file because we're not merging it. So we're now going to open the exercise packet capture file. And so it should be something about 58,000 something. So it's loading, as we can see right here, it's loading. And let's see how many we get in total. All right, so 58,620. So we want to find the comments for this. So there are ways that we can go just look into the details of the file. So file comment right here. And then in the file comment, it says the flag is TryHackMe WireShark demo. If I highlight it, there's a copy to clipboard button. So let's see if that actually works for me. And if I go here, nope, it did not copy it. So TryHackMe WireShark demo is the flag. So I have to now do this manually. So let's go ahead and type this out. What is happening? Oh, I see. If I do an extra thing, I see. You don't need to do the underscores because it automatically fills in the underscores. So if you include the underscores, then you'll have 2 underscores. So TryHackMe WireShark demo. What is the total number of packets? And we can see that right on the screen right here, 58,620. Whoops. Come on. All right, and SHA-256 hash. Okay, I really hope that this actually copies because that would suck if I have to manually type this here. Okay, cool. So I actually right-clicked on it. I right-clicked and I copied and then I pasted it on here, and that part worked. So let's now go into packet dissection. Okay, packet dissection. It's also known as protocol dissection, which investigates the packet details by decoding the available protocols and the fields inside of that packet. So if you remember, we have the field detail. I'm super zoomed in again, so sorry about that. I'll zoom back out again. But so the bottom left section where we saw all the details of the packet, that's where we would see all the stuff that we're looking for. So WireShark supports a long list of protocols for dissection, and you can also write your dissection scripts. You can find more details on dissection at the specific... Oh, it's dead. Unbelievable. It was a GitHub link, but it doesn't work, and that's kind of annoying. And it's still saying too many requests. That is so annoying. So if you find a specific GitHub or any kind of other article for packet dissection, please drop the link of it in the comment section below and we'll try to check it out. Or if you can drop the name of the article that you found so that we can Google it and find it ourselves, that would also be really handy, because I think Google or YouTube kind of limits clickable links inside of the comments for the security purposes so that people don't get hacked. So at the very least, if you can find the name of the article and drop it in the comments below, that would be really handy. And I'm sure the community will be very grateful for you. So in this section, we're going to be covering the WireShark using OSI layers to break down packets and how to use them. It's expected that you already have a background and the knowledge of the OSI model. The OSI model is a 7-layer model, so please keep that piece in mind. In the packet details, when you click on the packet in the list of the packets, it shows the details, and then they'll consist of 5 to 7 layers based on the OSI model, and we'll go over all of them in a sample capture. So this shows the viewing packet of number 27 on, I don't know which one. Oh, it's the HTTP 1 PCAP file. So I'm not going to reload that because now we're in the new one. But this is on the very first one that we were looking at that had 43 packets in it. So you can see the 43 on the bottom right here. So we're looking at packet number 27 on the 43 list of packets. You can see that it's HTTP is the protocol. When you click on it, it loads an entire list of those details. So frame 1, 2, 3, 4, 5, 6, and 7. So we have 7 different lines right here. At the very, very top, we have all of the details. So when you click on this very top line, you'll see on the right-hand side, it has all of the details highlighted. So it has the full list of everything, or the contents of everything inside of that. And then each layer that we click on will actually get more details out of it. So each time you click a detail, it will highlight the corresponding part in the packet bytes pane. So if we look at the details pane, so we see frame 27, 214 bytes, Ethernet 2, the source is this specific MAC ID, and the destination is a Xerox, I guess a printer maybe. Internet Protocol version 4, so IPv4, the source is this IP address, the destination is that IP address. Transmission Control Protocol source port 80, destination 3371. 2 reassembled TCP segments are included here, number 26 and 27. Hypertext Transfer Protocol, HTTP, so we can click on that and see the details of the actual HTTP communication, and then the line-based text data. So the last 2 lines will have the most details about the actual data that's being transferred itself. So 7 distinct layers: frame packet, source MAC, source IP, protocol errors, application protocol, application data. So we'll go over each one of them here. So this is the first layer, the frame, right? So this is the first one right here, frame 27. That's the very first layer. When you expand this, you get to see all of this data right here. You do not need to make sense of this data right now, but you can see a lot of data. And then you'll see more of these arrows where if I click on this, it'll expand the interface ID. If I click on the source, which is the MAC layer address, the layer 2, it shows me the source MAC address, the destination MAC address, and then we get to see that it's a IPv4 communication basically. Layer 3, the third line, it shows the source and destination addresses, the IP addresses from the network layer of the OSI model. So it actually shows us, again, more detail here. It shows us the time to live data as well. Source address, destination address is right here as well. But you can also just see it on the very, very top line as well. Version 4, meaning IPv4. So if it was IPv6, for example, you would see a very different type of IP address. Then we have the protocol layer on layer 4, which shows the details of the protocol, which is the UDP or TCP in this particular case, and the source and destination ports from the transport layer of the OSI model. So source port is 80, destination port is 3371, and a variety of other details as well. For example, the flags that were sent, which is the push and the acknowledgement flags that were sent in this communication. Protocol errors, which is the continuation of the 4th layer, showing specific segments of the TCP that needed to be reassembled. So it says 2 reassembled TCP segments, and number 26 and number 27. And then the frames themselves. So if I click on these, for example, these are actually hyperlinked, and they will go to that specific frame and load the details of that frame. Application protocol, which is the layer 5, which shows us details of the protocol used, like HTTP, FTP, etc., from the application layer of the OSI model. So in this case, it's HTTP1, and then we have the link itself. So Google AdServices.com, etc., etc., and then at the bottom we also get to see the actual link itself. So a lot of data about the specific communication on that protocol, which in this case again is HTTP, so it would have something to do with the web, because this hypertext transfer protocol has to do with the web. And then application data, the extension of the 5th layer that shows the application specific data. In this particular case, what do we have? Do we have anything useful? We can see some HTML code, so it looks like potential contents from the web page itself. And I don't think we're seeing everything here, but we do see HTML header style, and then a new line, and then we have all these other things that are inside of it. So they're basically 3 lines of HTML text that we can potentially analyze in this case. So now we're going to take this data, everything that we've learned, and we're going to do an actual investigation on the exercise PCAP file to try to answer some of those questions. So let me kind of zoom out of this a little bit just so we can get a full view of our virtual machine. And so let's see what the question, or first question right here is, using this to answer the questions, view packet number 38, which markup language is used under the HTTP protocol? So if we go here, let me close this out. I should probably zoom out a little bit more too, because this feels like it's still super zoomed in. So let's go back, zoom out one more, we'll go to 110%. Okay, that's cool. All right, so let me delete this up here, and we're going to packet number 38. All right, so packet 38, I can just scroll to packet 38, click on it. There's also an option that if you click on go, and then there's go to packet, or you can do Control G, it'll open up this new thing right here, and I can just type 38, press enter, and it'll take me to packet 38. Did my keyboard just die? No. What's going on? Packet 38, enter. There you go. All right, cool. So packet 38, enter. We are now on packet 38. We now get to see all the data right here of packet 38. Under HTTP portion, we want the markup language here. So let's go and find the markup language. So it was actually the section right under HTTP. So not just HTTP itself. It's the one right underneath it where it says extensible markup language, which I'm guessing it's extensible markup language itself. I think that's the full answer they're looking for. Okay, cool. So now next question is, what is the arrival date of the packet? And the answer format is month, day, and year. So the arrival date of the same exact packet. And that's what we're looking for. So let's go back down here, down here. And let's see the arrival date. I'm guessing it'll be under this, right? Arrival time. So May 13th of 2004. So 2004, May 13. So May 13, 2004. What is the time to live value? The time to live value, if I remember correctly, was under the layer 3 IPv4 version. So if I go here, time to live right here is 47. So we're just going to do that real quick. And what is the TCP payload size? So that would be under the TCP layer. So if we go over here and expand the transmission control protocol, and we're looking for the payload size under this. So let's see if we can find that real quick. It's right at the bottom of that section. So it's the second to last line item in the TCP section. And TCP payload is 424 bytes. And finally, it says, what is the E tag value, for example, etc., etc. So now we just want to find the E tag value. Now that I don't remember where we saw it in detail, so I got to kind of click around a little bit. I forget where we would see the E tag value. So let me click around and I'll see if I can find it, or where I find it, I should say. Okay, there we go. We found it. It is in the, what happened? It's in the HTTP section. So hypertext transfer protocol. It's right here under last modified. If I right click this, I should be able to copy the value. So there we go, value. Let's see if that works. Go here. Ooh, it says E tag, yada, yada, yada. So it doesn't copy the full value. It actually copies that entire line. So I'm just going to copy it as a value. I'm going to go to my browser. I'm just going to paste it at the top right there. And I'm going to go ahead and highlight this mofo. And then copy that. Go right here. Paste that. That should be the answer. Amazing. Okay, great. Moving on to packet navigation. All right, this section is going to have, I think, the most amount of details and everything that we're going to be talking about. So packet navigation, as the name implies, is that we're going to be navigating the variety of packets that are presented to us. And there's a lot of details within each one of those packets that can help us. So it's like if you don't know exactly which one it is that you're looking for or what it is that you're looking for, or you have a guess and you want to see maybe if a certain value exists inside of a given packet, this is the section that will help you find those packets. So WireShark will calculate the number of the packets and assign a unique number for each packet. This helps the analysis and makes it easy to go back to a specific point of an event. So we already know this, right? So the number itself, you see right here, it actually shows the number of the packet itself, which is called the frame. So in the packet captures, each packet itself that you see right here, it has a frame number, right? So the frame number is what we see as the line number, right? And in the sequence of the traffic that came in, you got to think about that all of these things are actually happening chronologically. So in the sequence of the traffic that it came in, this specific frame was number 27 among all of the other ones, right? If you wanted to go to a packet by the number, we already did this. So we can just go to go and then go to packet and then just type in the packet number and it will take us directly to that packet. So that part's really, really handy if you know which packet it is that you're actually looking for. Now, if you want to find a packet, right? So we don't know what number it is. We know that it should have something in it. And so we want to find the packet based on what we think is in it. So you can use the find packet option to make a search inside of the packets for a particular event of interest. So there are two crucial points in finding packets. The first is knowing the input type. This functionality accepts 4 types of inputs. We have the display filter, hexadecimal value string, and regular expressions. String and regex are the most commonly used search types, and they're case sensitive, so keep that in mind. But you can set the case sensitivity in your search by clicking the radio button so it's not case sensitive, basically, right? Second point is choosing the search field. You can conduct searches in the packet list, packet details, and packet bytes. And it's important to know the available information in each pane to find the event of interest. For example, if you try to find the information available in the packet details and conduct a search in packet list, WireShark won't find anything. So again, this is the packet list, right? This section right here. This is the packet details, and then this is packet bytes. So you just need to know what it is that you're looking for. So if we go to edit, find packet, and then go based on, let me see if I can kind of zoom in on this for you here. They're doing packet details, looking for a string, and then they're looking for the word download. And then now we find download.html inside of the packet details, right? Very, very handy. So if you kind of know what you're looking for, but you don't know what packet it's in, you can go ahead and use this specific methodology, and it'll be very, very useful and very effective. So we see it again, packet number 4 right here has the word download on that download.html file. So one last time, you click on edit, and then you go to find packet. Then you go packet details. For the most part, that's what I search for. Look for a string, and then we're just going to search for whatever the string is, download, and then it'll show us where it is, and there it is. So very, very handy, specific tactic. You can then mark packets. So mark packets is basically marking packets. I don't I don't know how else to actually say it. So it's another way, so you can find and point to a specific packet for further investigation by marking it, and it helps analysts to point to an event of interest or export particular packets from the capture. You can use the edit or right click menu to mark or unmark packets, and they will be shown in black regardless of the original color representing the connection type. Note that marked packet information is renewed every file session, so marked packets will be lost after closing the capture file. So you can do mark or unmark, and then you can see that it gets marked for you, and you can come back to it just based on what you see right there. And then you can mark a section of packets, as you can see right here. And so they did mark or unmark selected, and they marked that entire section of packets. So you can do that, and then you can unmark them one by one, or just unmark them in that section. So really, really handy for going back to a specific packet of interest. And then we have packet comments. So similar to packet marking, commenting is another helpful feature. You can add comments for particular packets that will help the future investigation or remind and point out important suspicious points. Unlike packet marking, the comments stay within the file until the operator removes them. So that one's really, really handy. And then you can see that it actually has even a section inside of the packet details actually called packet comments, which is really, really handy, and we can use that. We can then export packets. So capture files can contain thousands of packets. As mentioned, WireShark is not an IDS, so sometimes we need to separate specific packages from the file and dig deeper to resolve an incident. This helps us share the suspicious packages only. Thus, the redundant information is not included in the analysis, and we can use the file menu to export packets. So again, really handy stuff. And really, honestly, like when you kind of start looking at it, it's pretty intuitive. Like the menu itself, the toolbar menu is really handy. So, they highlighted this section of packets from 1 to 12, click on file, and then they do export specific packets, and then they give it a file name just for the export. Really, I mean, it can't get any simpler than that, right? And then right down here, you just make sure that you click on selected packets only, and then it actually shows you which packets you've actually selected. And then from there, you save it, and that's it. You got that. Then we can export objects, this is really handy. Like this is probably the handiest. I don't know if that's a word, but this is a really, really handy element of this. So certain packets themselves have actual files inside of them. And this is really, really important because you would need access to those files so that you can go ahead and look at the hash value of the file and see if it's malicious and do a deeper dive on the actual file itself that is contained inside of those packets. Because sometimes, somebody goes online and they download something and you don't know if that was the downloaded file that caused everything to go, chaos, belly side up kind of a thing. So you want to look further into it. So you look at the packet capture file, our PCAP file, which shows us everything that happened during that hour of activity. And then you then go ahead and click on the specific packet line item that you think the file exists in, and then you go ahead and export the file. And then now you can see that from that specific file, from that specific packet frame, it now gives us an option of items that we can export. So you click on whichever one it is that you think it is, you go to File, and then you go to Export Objects. And then you have a variety of formats that you can export from. In this particular case, it's HTTP, and then they have packet 27 and packet 38 that exist. And I'm sorry, so it's not from that specific frame, it's actually from the entire file, and it shows you that there is on frame 27 and frame 38 have objects that you can download. And so they went ahead and downloaded those specific objects, which is, again, really, really handy. Time display format is, it helps when you're doing a reverse engineering investigation for digital forensics. It lists everything as they are captured, so investing in the default flow is not always the best option. By default, WireShark shows the time in seconds since the beginning of the capture, so it's not actually doing a timestamp for you. So when you look at it right here, it's actually, I think this is after they've done the format, because now it shows it looks like the hour. But when you look at the original, there we go. The original, you see that this is the time in seconds. So within the first second, there was 4. Within the second there was 4. So that's what it looks like. So you need to go and do the time display format. and actually change it to the time display that you want so that you can see what's going on. And so you see that there's a bunch of options for seconds since, and then there's UTC, time of day, etc., and then the date and time of day. And I guess these specific elements would be more relevant to the time zone that you're in. So the best one that we want is the universal time, so UTC. And then now you can see that it went from those frames, like times, milliseconds and things like that. Now it actually has a date and time. So you see how the format changes. That's very, very handy, because most likely they'll be like, hey, between this time and this time, this happened. And then you need to go actually find out between those times, like which packets apply to those specific times. So this is the display format, where the default display, you can see again, it has the frames by the number of seconds and milliseconds that has passed. And then over here, we actually have the UTC time display format, which is much more handy. And then we have expert info, which I think is actually the last section. Yeah, so expert info, it detects specific states of protocols to help us spot possible anomalies. These are only suggestions, and there's always a chance of having false positives or negatives. And it can provide a group of categories in 3 different severities, and these are the details. Expert info is something that comes within WireShark itself. This is not something that a previous analyst on your team went and left comments on. This is actually the WireShark. The people who developed WireShark, they have certain algorithms in place within the software that will go ahead and detect potential anomalies. So potential, possible, right? This does not mean that this is exactly right? It could be false positive or negative. So just keep that in mind. So we have severity and the color, and then the info. So chat would be in blue, information on usual workflow. Note would be in cyan, which I have no idea what color cyan is. So cyan color, what is that? This is also blue. What is this? Teal? Something like that, I guess. That kind of baby blue, maybe. So I don't know. Blue, like this would be probably a darker blue, and cyan is like a lighter blue. Notable events like application error codes. Warnings would be in yellow. We know what yellow looks like. And errors would be in red, and we know what those look like. And there's also the black, right? So remember, if you actually go down to the color rules, you'll probably see more of these color rules in place. But these technically fall under the expert info category. So this is probably something that we can pay like a closer attention to. Frequently encountered information groups are listed in the table, so we can refer to the official documentation of WireShark from the wireshark.org website to get more information about this. And it's at wireshark.org/docs. So very, very important website if you actually want to get good at this tool. This is a very important tool. So you should make friends with wireshark.org. That's a very, very important tool. And so again, you see right here, right? I have all of my stuff saved at the top right here, and these are things that I refer to regularly. So if WireShark is something that you're really interested in learning, then you should add WireShark to your favorites tab. And I need to go ahead and kind of reorganize this so that I can separate websites from tool docs and things like that. So, all right, so here we go. So we have the checksum value, checksum errors, and they are deprecated. So it's a deprecated group, deprecated protocol usage. So that's what we see here. Packet comment detection. It's malformed packet detection. So deprecated protocol usage would be under the group checksum, and then the malformed packet detection would be under the group comment. And we can use the lower left button section in the status bar, analyze expert information menu to view all of these things. And it's that blue, it's the circular button, basically, right here. That circular button on the far left, like right next to the packet details button, right there, that's the expert info button. You can also go to analyze and then go to expert information, and then it'll display this whole thing for you, and you'll get a good amount of details from it. There will be all of the information entries in a dialog box. It'll show the packet number, summary, group protocol, and total occurrence. And that, my dear friend, is it. I think that's pretty much the end of our documentation, our notes here. So now we're going to use the exercise PCAP file to answer these questions. So we're going to look for the raw string in the packet details. So let's zoom back out again, and let's go to our handy dandy notebook. No, our handy dandy tool. if you can find out, if you can guess where that line is from, our handy dandy notebook, if you can find out where that's from, you get brownie points. I don't know what to give you, but without Googling it, because then that obviously it makes it easy to just Google it. Anyways, okay, so we're going to go to edit, and then we're going to go and find a packet, and we're going to find inside of the packet details. So here we go. We were looking for packet details, narrow and wide. Awesome. And then we're looking for a string, and then we're looking for R4W. So raw is what we're looking for. And then we're going to click on find. And okay, so it's right here, right? The bottom. It's definitely found it. Packet 37,061. So let's see what the first question is. It says, what is the name of artist 1 in this specific thing? So now we need to go ahead and look at the details of this packet, just so we can go ahead and find it. So packet details here, I need the name of artist 1, and it should be available here. There we go. So artist 1, and then we have, what is it? Where's the full details? Okay, here we go. Artist1 equals R4W8173. So R4W81, I can't highlight that portion. So R4W8173, we're going to do that. R4W8173, that is the name of the artist. Go to packet 12 and read the packet comments. What is the answer? MD sum, file name, terminal command, get the hash. So what is the, oh, I see. So we're looking for, just by itself, it says that we're looking for the MD5 hash value of a file. So, and the file would be in packet 12, it seems. So I wonder if I can just kind of do export objects and see if I can find anything. Oh my God. Okay. Never mind. There's a bunch of objects in here. So that's not going to help us. So we want to go to packet 12. So we're going to go to packet, and then that's going to give us the packet thing right here. And we want to go to packet 12, and let's read the comments of packet 12 and see what we can find here. So let me see what I can find for packet 12. How are the comments displayed? Let's go and find out how we can get packet comments. So under edit, we will go to packet comment right here. So this is not a flag, this is not a flag. Okay, fine, that's great. But where's the details that I'm looking for? Go to packet 39765. Look at the details pane, right click on the JPEG section and export packet bytes. This is an alternative way of extracting data from a capture file. What is the MD5 hash value of the extracted image? Okay, great. So 39765, packet details, right click on the JPEG section, export packet bytes. Okay, 39765. So we're going to go to packet 39765. We're going to look at the packet details here, and we're looking for the JPEG section. Why is there so much information here? JPEG section, wonderful. And then we're going to click on, I'm just going to right click on JPEG, and we're going to do export packet bytes. And this should be, okay, cool. It's going to be on the desktop, I guess. And then we'll just do JPEG or image. We'll do image as the file name. And we're going to export, save. Okay, there we go. All right, so let me minimize this thing right here. There is the image. So now, MD5, they want the MD5 sum, right? Is that what they want? They want the MD5 sum. Okay, great. So this should be, if you have any experience with Linux, this should be super easy. So we're looking for the, first of all, we want to see where we are. We're over here. So we want to see, okay, we need to go to the desktop and an MD5 sum of the image. And there it is. So I'm going to go ahead and do that. And then copy that. And then go here. And do that and press that, and voila, perfect. All right, now there is a .txt file inside the capture file. Find the file and read it. What is the alien's name? This is fun stuff. I love this kind of stuff. Okay, cool. So WireShark, let's go back in here. All right, so now we're looking for a .txt file. There are a few different ways that we can do this, but I think this is where we go into the export objects portion. Let's try to do HTTP, see if I can find a .txt file here. So this one, let's kind of shrink this down. I think it's this piece right here, right? That would show the actual TXT file. Is it a TXT file? It's like a super long element. It says it's a text HTML, but it doesn't give me the full details of it. So I'm very curious as to whether or not this is the file that we're looking for here. And it's on frame 27. It says text HTML, and then there should be a text file inside of this. So there might potentially be. So we can also go and do some other things. So if I go to, I think it was under edit, find packet, and then if I go into the string and see if I can find anything that has .txt in it. And okay, there's probably a bunch of them, honestly, that have .txt in them. So let's see what this one is. Does it say .txt? Yeah, note.txt. So href note.txt. That could be one. Is there another one? Yeah, there's so many of them. So I don't know which one it would be that actually has the .txt file. But this also says the note.txt. So get note.txt. So that could be another one. I really sincerely wonder if these are the things. So, all right, so we're going to try it. We're going to go back to here, right? So the way that we did it with the image, we're just going to go right here and we're going to right click on this. If it doesn't freak out on me, export packet bytes. So let's see if I can get the note.txt file. We're going to save it. Let's see if this is the one that they're looking about. So note.txt, if we open it, oh, that's all it says. So it says get note.txt. Okay, so that's definitely not it. I will rummage around and I will see exactly how I can find it. But it should definitely be these export objects portion of it. So that's the piece that I'm most curious about, is that it should be in here somewhere where we actually get a note.txt file inside of any of these. So favicon.io. So let me go in here and maybe inside of this I can do a .txt element. There we go, note.txt 4267. Okay, so that might be it. Let me see if that's the one that I can find. Here we go. Okay, here we go. So that was actually the best way to do it. So let me kind of show you this one more time. So essentially what I did was I did export objects HTTP, right? And as we can see, there's a bunch of stuff in here. And so I just went in the text filter down here and I just typed .txt. And the only thing that showed up was this one that actually has note.txt in there. And it's on packet 4267. So I just did save. And then it opened up my save thing. And then I saved it on the desktop as note1 because I already had a note and I didn't want to potentially overwrite it, which, I mean, it's useless anyways. This first one was useless. But so this is the next one that we have right here. So let's go ahead and open it so we can see a picture of an alien. And we need so packet master is the name of the alien. Packet master. Nice. That's me. Packet master. Okay, perfect. So look at the expert info section. What is the number of warnings? So we are almost at the end here. So we're going to go right there and we're going to go and find expert info, which was, how do we find expert info? Oh, expert info, the button. Boom. Click the red button. And then it says how many, what do we need? What is the number of warnings? So warnings, right here, if we expand on warnings, okay, so how do I find the number of warnings? If I click on warnings, it should give me the number, right? So if I maybe double click it, so let's see. If I go to warnings, click on this, and then go ahead and highlight the whole thing, like all of the warnings maybe, that might be the best way to do it. There's a lot of warnings, dude. So there has to be a way that we can go ahead and find the data itself. Can I highlight all of them? I can't highlight all of them. So there needs to be a way that I can count the number of warnings because it doesn't make sense. So let me see, maybe if we just kind of expand on this little window that we're in, and it'll show, yeah, it has, there we go. There's a count button. There's a count category at the end. So the count of warnings, there we go. So 1,636 warnings. Sometimes it's so much simpler than you actually think it is. And there you go. And you complicate things as a human being, especially if you're intelligent. I don't think I'm like the smartest person in the world, but I do think I'm intelligent. And when you're intelligent, you get to think that it's more complicated than it actually is. So you're trying to find all these like fancy ways to do things, and it's like, nah, you don't need to do all that. You just need to kind of do the common sense view, and there was a column that had the count. So, okay, here we go. Last piece right here, packet filtering. The packet filtering portion of this is, I think, probably where like the biggest power of WireShark really kicks in. And this is probably the most important skill when it comes down to WireShark. So everything that we saw so far and all the exercises that we did in the last section are also super important. But then being able to use they're known as display filters. And display filters allow you to really hone in on the specific activity that you're looking for, the type of protocols that you're looking for. So it's a more advanced version of everything that we've done so far. Everything that we've done so far, especially in the last section, we're using different elements of the toolbar to try to find information and the features and functionalities of WireShark to find information. But what we're going to be doing now is something that applies to the T-Shark tool. It'll also apply to tools like TCP dump and things like that. And it requires that you have a stronger understanding of protocols inside of network traffic and how to be able to hone in on specific protocols and get a specific set of data. So, packet filtering. It has two types of filtering inside of WireShark, capture and display filters. Capture filters is when you're capturing traffic. Display filters is when you already have captured traffic, for example, inside of a PCAP file, and now you want to view them. You want to view the various packets based on specific details or specific data you're hunting for. So we're going to be talking about these in the next specific room, like in more granular detail and more detailed information. But right now we want to really touch on what these things actually do for us. So there's a golden rule, right? The first one is that it actually queries the specific data, and the second one is the right-click menu of the data. So these are the various elements of it. The golden rule for analysts who don't want to write queries for basic tasks is that if you can click on it, you can filter and copy it. So this is very, very important, right? This is what the golden rule is. So I can click on this. I can click on any of those packets. And again, this is kind of super zoomed in, so I'm sorry. I'll try to close this. I can click on any of these things. So you can see right here already, actually, it actually has filled in that portion of it. That's actually a display filter that we have. So if we scroll down with the rest of these packets, and if I can find something else in here, or not even that. So if I click on the source port, right, the source IP address, right click on the source IP address, and then apply it as a filter, the selected portion. Now you see that the IP address now equals that specific source IP address, and that is now my display filter, which is now a really cool way to understand how display filters work, because now I know what the query looks like. IP.source and then two equal signs, and then you give it a value. So by the same argument, if I right click on the destination and then I do apply it as filter, now it changes it IP.destination, DST equals value. So now you can go ahead and do that. So now we can really get into some really, really cool data here, because I can then go ahead and right click on TCP, apply it as filter, and for whatever reason, that's not working. So I guess TCP specifically won't work if I wanted to just apply that as filter. I have to be zoomed out, so I'm kind of getting ahead of myself. But you saw the example that we're looking about right here, right? If you can click on it, you can filter and copy it. That's exactly what I just did. So applying something as a filter, we just did it. And then you can see this right here. Is this a GIF, or is this something that, I guess it's not? I thought it was a GIF, but I don't think it is. Or a GIF. I don't think GIF is the pronunciation. I think GIF is the pronunciation. But so essentially, use the right-click menu or analyze applies filter to filter to the specific value, and the number of total and displayed packets are always shown on the status bar, so you can actually see how many you got, right? Then there's the conversation filter, very, very, very useful. When you use applies filter, you will filter only a single entity, and it's a good way of investigating a particular value in packets, but you want to investigate a specific packet number and everything that's linked to it, by focusing on the IP addresses and port numbers. So in that case, the conversation filter helps you view only related packets and then hide everything else. And we can do this by doing analyze conversation filter to filter conversations. And then what you see right here is that the note or the query has now changed, and it's tcp.stream equals 0 in this particular case. So really, really useful and very handy. And that TCP stream would be relevant to the TCP stream of a specific packet in this particular case, or a specific conversation, I should say. Then when you have it, you can colorize the conversation. So conversation filter, with one difference, it highlights the linked packets without applying a display filter and decreasing the number of viewed packets. It works with the coloring rules option and changes the packet colors without considering the previously applied color rule. You can use the right-click view colorize conversation to colorize the linked packet. Note that you can also use the view colorize conversation to reset the colorization to undo that. So this was definitely, I just saw movement down here. So why isn't it actually doing the GIF? I totally thought that this was going to be a GIF kind of a thing for us, but it's not actually doing it. I'm kind of upset about that. Like, I thought it was actually working, but now it's not working. Anyways, all right, prepare as filter. So apply, you see it. You see that it's working, right? You see at the bottom right here, it's actually working. So if I go down here, okay, there we go. So this, I don't know what just happened with the other ones that it wasn't showing it. It kind of like cut it off, but so, okay, so we're looking at, what is this specific one? Apply as filter is what we're looking at. I guess so when it's over, maybe it doesn't like reset the GIF from the very, very beginning. So that might be the thing, because now you can see that this also stopped. So what if I like scroll down again? No, it doesn't. Okay, so whatever. So it helps us create display filters using the right-click menu. However, unlike the previous one, this model doesn't apply the filter after the choice. It adds the required query to the pane and waits for the execution command, which is enter, or another chosen filtering option by using the and or from the right-click menu. These are operators. So and or are technically operators, very similar to the equal sign. Those are operators. Apply as column. So the packet list provides basic information about each packet. You can use right-click or analyze apply as column to add columns to the packet list plane. Once you add the value and apply it as a column, it is visible on the packet itself. So there we go. That's what they did. They right-click on the column itself, right? Come on, where are you? And it stopped. Gosh, that's so annoying. Okay, so once you click on it, apply it as column, it will be visible on the packet list pane. This function helps analysts examine the appearance of a specific value field across the available packets. You can enable or disable by right-clicking on the packet list pane. So there we go, and then follow stream. So very similar to what we saw with the conversation piece. So it displays everything in packet portion size. However, it's possible to reconstruct the streams and view the raw traffic as it's presented in the application level. Following the protocol, streams help analysts recreate the application level data and understand the event of interest. It's also possible to view the unencrypted protocol data like usernames and passwords and other transfer data. And you can right click on it and it's going to stop running. It's so annoying. I really want it to like keep going just so we can view it again. There has to be a way that I can like reactivate these things. So what if I open the image? Instance termination. Your instance has been automatically terminated. Please restart a new one. Why? Because I tried to open this image? That's so annoying. But there we go. At least now we have the image. So TCP stream, there you go. And then now you can actually see all of the stream of the TCP data. And if it's unencrypted, which is definitely what you can see right there is actually unencrypted, you can see that the data shows. If it's encrypted, it's going to look like a bunch of gibberish, but if it's unencrypted, it'll look like that. I wonder if it's because I didn't run out of time. It's impossible for me to have run out of time with my virtual machine, but I guess I did run out of time. That kind of feels like a little silly, but okay, whatever. So we're just going to restart it and wait for it to launch while we read through the rest of the data. And I mean, you know, for whatever it's worth, I guess if you right click on an image and load it, let's actually test that theory. We're going to right click, open the image. No. Okay, so maybe I did run out of time actually, which again doesn't see, I feel like I haven't been recording long enough to run out of time, but I guess I was. But So where were we? Follow stream. So there we go. You can find the thing. So let's open it in a new tab, whatever you want, right click on it, and then go ahead and follow TCP stream, and then you'll see a new window pop up, and then you can actually follow the stream of conversations between those specific packets. Once you follow a stream, WireShark automatically creates and applies the required filter to view the specific stream. Once the filter is applied, the number of view packets will change. You will need to use the X button to change it. Simple display filter queries. You can also see these right here. So this is where inside of this red box right here, this is where we would actually apply our display filters. And there is a lot of display filters. There are many, and each one of them can be extensively tweaked to show very specific results. These are some of the simple ones, the basic ones. So filtering by protocol. So you just go and just literally type in ARP or DHCP or FTP or SMTP or whatever, any of these things, and it'll actually just change all of the protocols to only show IMAP, for example. And that's pretty much it. You can change by protocol and port number if you wanted to, or protocol port number just by itself. So you can do, for example, TCP port equals port number, UDP port equals port number, right? The GIF below shows an example of the HTTP port filter. So again, TCP port in this particular case would be the example. So if we go ahead and look at the image, this is what we see right here. So you can see that they do TCP.port and then equals 80, right? So that's it. And then I would only show everything that has to do with port 80, whether port 80 is the source port or the destination port. Doesn't matter. It'll show anything that has to do with a TCP port 80. And the same thing applies to UDP port. And then what you already saw was that IP.src for IP source, and then IP.dst for IP destination. Those are the types of things that you can do. And then if you just kind of click one button right here, you can see it right here. This is actually a perfect example of it. So when you type in just one thing right there, so IP, and then all of a sudden you see a bunch of options that are available. So you can always just scroll through those and find what it is that you may be looking for, and then go ahead and type it in. Like we can kind of fill it in. It's like an autofill option that'll help you go ahead and do it. So really, really handy actually, like very, very useful information. So that can also be something that you can leverage for yourself. And again, if you really don't know, right, you can just right click on this IP address, apply it as a filter, and then it'll show you what it looks like, IP.address. So in this particular case, IP.address equals that will show you any source or destination IP address that equals that specific value. So if you're hunting down just a specific IP address and you want to see what all the communications were between that IP address, that's what you would actually see. So really, really handy, very, very cool and useful information. And hopefully by now, our new instance of our machine has shown up. So we can go ahead and zoom back out and launch our machine to answer the questions for our final section here. Yep, this is the last section. So let's go ahead and do that, and we will be done with today's exercise. Okay, cool. So we have loaded our exercise PCAP file once again, and let's go ahead and look at our question here. First one, it says, go to packet number 4, right click on the hypertext transfer protocol, apply it as a filter. Now look at the filter pane. What is the filter query? I just know the answer is HTTP. That's for sure the case, but let's just do it. So if we go right here, right click on the thing right here, and then do apply as filter, and then that piece, and then now we can see HTTP has been applied as filter. So there we go. So that's the query. What is the number of displayed packets for HTTP? It is now changed to 1,089 packets for HTTP. So there's that. So let's go to packet number 33,790. Follow the HTTP stream and look carefully at the responses. Looking at the web server's response, what is the total number of artists? So we're going to go right here. I'm actually going to delete this just in case it's not in here. We're going to go to packet, what was it? 33,790. So packet 33,790, click on that, there it is. Then we're going to right click on the packet. We're going to do follow HTTP stream, right? Follow the HTTP stream. And there we go. So now we're looking for the number of artists is what we're looking for. So we're going to go here And basically in the section, in the data itself, so none of these things are actually encrypted, so we can actually read all this stuff. So I can technically see if I can go to artist and see what I can find. So artists.php file is the first piece. Find next, artist.php, artist.php, okay. Here we go, artist.php. Let me see. There has to be something that actually starts naming the artists. Where are the browse artists? Okay, get artist.php. Come on, let's get to the actual list of the artists. So artists title in the page. So I think we're on the artist page. Artist.php again. PHP artist. Okay, here we go. Artist 1. I think that's where it is. Okay, so artist 1 is this guy. Next one, yeah, artist 1 equals. So how about this? I can change it from artists to artist equals. So let's do that. Artist equals. Let's find them like that. So artist 1 equals that. Artist 2 equals that. Artist 3. And that's it. So artist 1 again, artist 1 again. So it's, I think it's artist 2, artist 1. So 3, that's what it looks like. Artist 1, 2, and 3. That's basically all we got here. So we're going to try 3. There we go. And what is the name of the second artist? So now we're looking for artist equals 2. So the second artist is Blade with a 3 instead of an E. And just like that, my dear friend, we are done. Very cool. I love this stuff. Let me tell you, I really love this kind of stuff. So I got to tell you, the first few times that I did the WireShark rooms and the videos for WireShark, I was not as well read into WireShark as I am today. And it's one of those things that, I don't know if you've ever heard this phrase before, but there's this phrase where it's like, you know, when you reread the same book, it's the same book, right? The content is the same, but you're a different person. And so it hits you differently. It connects with you differently. And I think it's actually the same with cybersecurity tools and pen testing exercises and all those things. And this kind of feels like that. This feels like, you know, I've been doing this since what? The beginning of 2024 is when I started this channel, and I was clueless at the beginning of 2024. I literally had very, very little information. I had no idea what I was doing. And the way that this channel started was I was just reading through these exercises out loud for my own learning. And then it got to a point where I'm like, oh, I think I can explain this information in case somebody is having some kind of challenge understanding it. And then it got to the point that, oh, I think I can teach this information. And that's kind of where it feels like it is right now, because I have used WireShark so many times, dozens and dozens and probably hundreds of times between pen testing and security analysis. And all of those things were just more and just a little bit more information, a little bit more understanding. And now it's getting to the point where I'm like, oh, you know what? You can bring all of that together. And hopefully, as we go through the rest of these videos, it hits harder for you. It actually connects better for you. And you get to learn and understand it even better. And that's really the ultimate goal here, is that if I can condense my learning curve so that when you're watching this, if you've never used WireShark before, and this was the first time that you saw WireShark, my goal is that you have a much better understanding than I did the first time that I was introduced to WireShark. So that's kind of where we're at, and I feel like I can actually deliver on that goal right now. And hopefully that's what it will feel like when you go through these videos. So the next one that we're going to go through is the WireShark packet operations video, which is the very next video after this episode. And that will get into more detailed information about individual packets and display filters and finding the data that we're looking for. So hopefully all of this actually added value for you and you were able to learn some good information, especially if it's your first exposure to the tool WireShark. If you found this video useful and if you would like to get more videos like this one, then I encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel. This specific playlist that you're on right now is the SOC Level 1 playlist for 2026. There's another playlist that we're working on, which is the CompTIA Pentest Plus Practice Labs. And then we have the AI for cybersecurity. And then there's going to be another one that's going to come out, which is Linux Plus for 2026, because that was just released with CompTIA. So of course we have to go ahead and cover those. And there are a few practice exercises and a few standalone videos that I'm working on just kind of as a surprise for everybody, because I think it's really handy and really useful. So I'm super excited to work on them for you and share them with you. There are some templates and some PDF files that I want to create for you guys, and manuals and things like that. So there's a lot of stuff. There's a lot of cool stuff that I'm really excited about sharing with you, and you want to be here for that. So definitely make sure that you stay tuned. If you have any questions about the video that we talked about today and this specific WireShark introduction, please drop them in the comment section below. If you just want to say hi, or if you want to say whatever, drop them in the comment section below. I would love to hear from you. I'm very active in the comment section, so I would very much love to hear from you. And of course, make sure, if you have not done so, to like, subscribe, turn on the notification bell so that you get notified the next time that a video comes out. And if you haven't done so already, make sure that you check out Hackaholics Anonymous. If you want access to my notes and exclusive downloads, and to get lifetime access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers. We have the supporter, the agent, the guardian, and the master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below, and you will be able to choose the tier for which you want to join. I really hope I see you in the Discord chats. If not, I hope I see you in the comment section. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease, and I will see you in the next episode later. This is part 2 of 3 of the WireShark series, and today we're going to be talking about WireShark packet operations specifically. My name is Hank Hackerson, your trainer for today. And to get more videos like this one, make sure that you like, subscribe, and turn on the notification bell. In the last video, we did the first part of a 3-part series inside of the TryHackMe network traffic analysis module for SOC Level 1, and that was an introduction to WireShark. And we got a chance to look at the WireShark interface. We got a chance to do some actual packet operations where we did some analysis against some packets, but we didn't really take a deep dive into it. And this is what we're going to be doing today. We're going to be specifically going into packet operations and the research within these packets to try to find that needle in a haystack, so to speak, so that you can really get good at doing deep investigations for packets, which is basically the individual line items inside of a bunch of network log traffic that's coming in. So that's kind of the purpose behind this whole thing. And again, this is inside of TryHackMe, which you're more than welcome to get access to. This is one of the paid rooms, so you do need a paid subscription for this. But I think even within their free rooms, there are literally hundreds of free rooms inside of TryHackMe. You can still launch virtual machines inside of those rooms. You can still get access to WireShark inside of those rooms and do investigations. So if you don't want to download WireShark on your own computer, which I think you should also do because it's a free open source tool, so it's like, why not have it? Especially if you're trying to go into security analysis and do all of those things. This is one of those tools that you have to get really good at using. So this is my recommendation, is that you actually download it and use it, or at least, at the very least, get a membership with TryHackMe for free so that you can access it through their portals. But it's one of those tools that you just got to get very familiar with, and you got to get really good at using. So that's what we're going to be doing today, and doing kind of a deeper dive into the functionalities. Now, the outline like this. So we have the introduction, right? Statistics summary, statistics, protocol details. Then we'll go into packet filtering with the principles and protocol filters. And then we'll go into advanced filtering, and then we'll be done. And all this stuff is going to be time-stamped in the description below in case you want to jump around and maybe you found this video and you just want an answer to a specific part, so you can go ahead and find it that way. But apart from that, that's kind of the overview of the room. And once we're done, we'll go ahead and you'll be dismissed for today. And that'll be it. So Quick little note from Hackaholics Anonymous, our membership community, and then we'll get into the introduction. If you want access to my notes and exclusive downloads and to get lifetime access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers. We have the supporter, the agent, the guardian, and the master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below and you will be able to choose the tier for which you want to join. I really hope I see you in the Discord chats. If not, I hope I see you in the comment section. Alright, so if you have not done so already, my biggest recommendation would be to go to the WireShark's Basics video, which is the episode right before this episode, so that you can really understand what WireShark actually is, you understand what it does, and what the various elements of it are. Terribly sorry about the noise in the background. There's somebody doing some kind of maintenance on the roof of my building, and they're being extremely chaotic, and I kind of want to go outside and cuss them out, but we're going to be civilized and we're not going to cuss out the people from the HOA, because the last thing that I need is problems from the HOA. So we're moving on, and hopefully they'll just get their stuff together and they won't cause so much chaos and commotion outside. And hopefully the mic isn't even picking that up and you just you're like, I don't even know what you're talking about, Hank. And I'm like, yeah, cool, but I'm hearing it, so it's kind of distracting me. Anyways, moving on. Cool introduction to the video and my personality. As you can see, I tend to get annoyed. Mostly I get annoyed when I'm in the middle of doing something important, for example, recording a video. But if it's not this kind of things, I usually have a pretty high tolerance for annoying people. That's just me. That's just me saying. Okay, anyways, moving on. So you do need the WireShark's Basic video because it covers a lot of the fundamental stuff about WireShark that we're not going to cover in this video. So if you haven't seen it, I highly recommend you go into it, because we're going to start going into more of the novice and intermediate and advanced stuff in this video today. Our objectives are to investigate network traffic captures, view statistics, including summary and protocol details, uncover and apply packet filtering principles, apply protocol filters, and advanced filtering. Those are the goals for today's video. Prerequisites are the fundamentals of networking. You should know these already. If you don't, there's so many videos on networking inside of this channel. There's the Network Plus training series, that course from CompTIA that I also have on this channel. So there's a lot of stuff on this channel if you haven't done it already. And then we have the basics of WireShark. The environment itself is the virtual machine that I've already launched. So there's a machine button. Where's the machine button? Right here. So this machine button was previously neon green, as you can see right here, and it starts the virtual machine that actually has WireShark already installed on it. And then inside of that instance, we actually have a PCAP file, a packet capture file called exercise.pcapng, which is what we're going to be using to do our investigations and answer a lot of the questions in this specific video. So that's what I'm using for the reference. But again, you can, so if you go through the previous video, I talk about how to capture your own traffic and actually get a PCAP file. So you can actually do that on your own computer, get a PCAP file, and then implement the strategies that we're using in this video to complete your exercise and do exactly what it is that I'm doing, so that you can get that practice under your fingertips and get good at using this tool. You're not going to directly interact with any of the domains and IP addresses in this specific room. They are included for reference reasons only, and it's very likely that they are malicious domains, so don't do it on your own computer especially, and obviously we're not going to do it inside of this room. We're just using it as reference points for the exercise question so that we can get the answers. That being said, let us go into the statistics summary. Okay, so for this specific section, the way that this is going to work is that we're just going to get a bunch of details about the statistics menu item, and then from there we're going to get some screenshots as reference points, and then we're going to actually use our virtual machine instance to answer the questions at the end. So what you see here, for example, these are just the screenshots of everything, and then at the very end of this, we'll have these questions that we're going to answer based on the actual PCAP file that we have in our virtual machine. So what I'm going to do real quick, I'm going to do the split view. It's super zoomed in, so I'm going to go into full screen mode and kind of close that out. And so from full screen mode, you can also see it's still super zoomed in. So I have to zoom out of the screen in order to be able to actually see that machine and like get some good answers for you. So we're just going to do a quick little review like this for the actual concepts themselves. I'm going to read through most of the stuff, and I'm going to read through it pretty quickly. There's a lot of data, but then what's going to happen is that we're actually going to apply the information by going and doing the investigation. So we'll come back and we'll reference a lot of this data. So hopefully it'll be good enough and you can kind of capture the ideas here and the principles here. And then what's nice is that you're watching a recording, so you can always rewind it and listen to me talk again, and you'll just kind of get all the information that you need. So hopefully this will actually hit home and you'll get a lot of good information from it. All right, so cool. Statistics is actually a menu. So if you can see right here, it's this in the top toolbar, right next to telephony or telephony. I don't know how you pronounce that. I would say telephony probably. So it's like to the left of telephony. It's called the statistics menu. And then when you click on it, you get a bunch of other options that are available here. So the first one would be the resolved addresses. But let's read through this real quick. So it provides multiple statistics options ready to investigate to help users see the big picture in terms of the scope of the traffic, the available protocols, endpoints and conversations, and some protocol-specific details like the DHCP, DNS, So a lot of stuff, right? It helps you understand a lot of things in the big picture level, right? For a security analyst, it's crucial to know how to utilize the statistical information, statistical information, I guess. This section provides a quick summary of the PCAP file, which will then help us create a hypothesis for the investigation. So you can consider this to be the first step that you would take when you're doing an investigation. You look at the statistics to get the overview, the big picture, and then from then create a hypothesis for your investigation. You can use this to view all available options and etc. So, all right. We're going to be using the file itself, to go through the walkthrough itself. So resolved addresses is the first one that we're going to look at. So this helps us identify IP addresses and DNS names that are available in the capture file by providing a list of the resolved addresses and their host names. The hostname information is taken from DNS answers in the capture file. Analysts can quickly identify the accessed resources by using this menu, and we can spot access resources and evaluate them according to the event of interest. We can use statistics, resolved addresses, to view all of it, and this is what it looks like. So you have the resolved addresses, this is what it is. We have the hosts, so the IP addresses with the domains attached to them. Then there's ports, and then there's even file comments according to the statistics for the resolved addresses. Then we have the protocol hierarchy. So this is just the next item, right? So you can see the next item right after resolved addresses, we have protocol hierarchy, which again, just by looking at this, it shows us the protocols that can be used or can be displayed in a given packet. So we have, 58,000 and some change packets, and then there's IPv6. Under that, there's UDP, then IPv4, UDP, TCP, HTTP. There's some JPEG file images for 9 packets in here, malformed packets, HTML form URL encoded, internet ICMP right here, so Internet Control Message Protocol, ARP, Address Resolution Protocol. So we can see these are the various protocols that are available inside of our given packet capture, right? So the golden rule that we mentioned in the previous video is still available. So you can actually right click on any of these, right? And then say filter or add 2 filters. And then from there, it'll actually create a display filter based on any of this data. And then you can now use that for the rest of your investigation to kind of hone in on the rest of the information. And then we have the conversations menu. So you can see right under protocol hierarchy, we have the conversations menu. So if we go into that, we get a few different views. So we have the Ethernet view right here, IPv4, IPv6, TCP, and UDP. And conversations can also be considered as streams. So it's basically it's not just one packet that's included. It's, for example, in this case, we have, address A is this 4222, address B is the 192, and then there's 6 packets between them in this order. Then 10.0.0.2 and 10.10.57.178, there's 90 packets between them. And if we go here, 10, 10, 57, 178, 10, 100, 133, 58,000 packets between them. So there's a lot of conversation between these two IP addresses. So you can see right here where it's like, okay, well, this is actually really handy because you can now see just at a glance an overview of, wow, there's a lot of conversations being had between these two IP addresses. I wonder what that's about. Or if I know that a specific IP address it's malicious and I'm looking for that IP address, then I'll go find it inside of these conversations and be like, okay, this specific one, the 145.253.2203 right here, has two conversations, and it has it between this one right here. I wonder what that's about. In these two conversations, I wonder what happened. Something like that, right? So really, really interesting stuff when you look at it like this. And then, of course, if you went into Ethernet, you would be able to see MAC addresses communicating with each other. And then when we have TCP, for example, we can now see the TCP address, the TCP conversations where it says, this IP address on this port with this IP address on this port had 10 conversations or 10 packets that was included in the conversation, right? Really, really handy stuff. And again, this is kind of like a cool overview of the overall conversations that are being had between various endpoints. And here we go. So perfect transition. So the endpoint option is similar to the conversations, and the only difference is that this provides unique information for a single information field, for example, Ethernet, IPv4, etc. So we can identify the unique endpoints in the capture file and use it for the event of interest, and you can use statistics endpoints. WireShark also supports resolving MAC addresses to human-readable format using the manufacturer name assigned by IEEE. That's also really, really handy, and we can see that right here. So when instead of seeing, okay, well, what does this MAC address mean? You just go down here and you're like, well, that's actually for the Xerox machine, or Apple right here, the Apple machine right here. So it's kind of like really, it's a much simpler way to resolve the MAC addresses to an actual device inside of your network. So this is done through the first 3 bytes of the MAC address and only works for the known manufacturers. When you review the Ethernet endpoints, you can activate this option with the name resolution button in the lower left of the screen. So right here, where you actually see it on the main page, if you click on name resolution, then it turns it from MAC addresses to what it thinks they are. So if we go back right here, you can kind of see that this one ending in BD is also here, and it's still the MAC address ending in BD, which means that from the IEEE database, there was nothing that we could have, or that WireShark could have actually discovered for us regarding that. This is not limited only to MAC addresses. It also provides IP and port name resolution. So these options are not enabled by default. If you want to use them, you got to go through Edit, Preferences, Name Resolution menu. And once you enable IP and port name resolution, you'll see the resolved IP addresses and port names in the packet list pane. And you will also be able to resolve those names in the conversations and endpoints menu. So you can see it right here. So this is the Preferences, Name Resolution, Resolve Transport Names, and Resolve Network IP Addresses. And then when you save that and you go back here, you can actually see that this IP address now is turned into dial in, etc. And then the port is now the TIP2 port, which is 3372, as well as the HTTP port, which is port 80. So this is actually also, again, really handy in case somebody says, hey, I want you to go check on the TIP2 port. And you're like, well, I don't know what that is. So you go and you do the port name resolution, the protocol resolution, and then you can now actually see that, okay, 3372 is assigned for TIP2, right? And then you see it again down here, 3372 is assigned for TIP2, and then HTTP is 80, right? It's so, again, becomes really, really handy and very helpful. The endpoint menu view with the name resolution. So, this is kind of similar. So again, we have right here, the endpoints themselves, the IP addresses, right? Just the numerical value. Then you click on name resolution, and then you go right here, and then now you see the actual IP addresses, what they lead to, what they point to. So dns.google, and then dial in wireshark.org, google.acad DNS or something. So you see that, right? So there we go. So now we can actually see what the DNS, the domain names are that resolve to those specific IP addresses. Besides name resolution, there's also an IP geolocation mapping that helps us identify map sources and destination addresses. This is not activated by default and needs supplementary data like the GeoIP database. WireShark supports MaxMind databases, and the latest versions of WireShark configured MaxMind database resolver. However, you still need MaxMind DB files and provide the database path to WireShark by using the edit preferences, etc., etc., etc. Once you download it and indicate the path, WireShark will automatically provide GeoIP information under the IP protocol details in the matched IPs. So we can actually see Internet Protocol and then geolocation destination right here, United States ASN, right? And then Stockelsdorf, not Denmark. I think that's not Denmark. Deutschland. Deutschland? My God, what is the? It's not. Is it Deutschland? It's not Deutschland. Oh my God, I sound such an ignorant American right now, but you get the point, right? So it actually shows you the geolocations for these IP addresses. I really do feel like an idiot right now for not being able to. It might be Denmark. Oh my God. Okay, you know what? All right, we're gonna now Google this because this is annoying. Country code, goodness, DE. Germany. So it is Deutschland, but it's not actually Deutschland. It's like DE and it's Denmark now, but okay, all right. You know what? I don't feel as bad now. But okay, moving on. Endpoints and GeoIP view. So we can see this right here. This is really cool right here that I can actually show you right here. So this does require, I believe this requires internet access. Yeah, so it says you need an active internet connection to view the GeoIP map. The lab machine does not have it, but if you do this on your own computer, you should be able to actually see the geolocation view of these things. And that is really handy as well. So for your work computer, you can probably do this and it'll be really, really nice and really handy. So, okay, so cool. So now we can actually go here and zoom out of our screen and go into our virtual machine and answer these questions. And the first one says, investigate the resolved addresses. What is the IP address of the host name that starts with BBC? So let's go ahead and actually start this exercise PCAP file so that we can go ahead and analyze the host name that starts with BBC. And it should be fun. It should be easy to do. Let's see it. So we're going to go ahead and expand on this. So maximize that. Okay, cool. So here we go. We're going to go to statistics. We're going to do resolved addresses. And there we go. So here it is. So it starts with BBC is what they're saying. I think I can even search for this. So BBC, there we go. So we search for BBC. And now what is it saying? It says, what's the IP address? Okay, good. So can I copy the IP address? Here's the key piece right here. I can't right click it. So let's do Control C. Let's see if Control C actually copies it. Ooh, nice. Perfect. Perfect, perfect, perfect. Cool. What is the number of IPv4 conversations? So let's go ahead and do statistics, protocol hierarchy. Oh, actually, no, it's not protocol hierarchy. It would be conversations, I want to say. So statistics and then conversations. And then now we want IPv4. So there you go. So IPv4, there's 435 conversations. There we go. How many bytes? Let me turn down the volume here. How many bytes were transferred from the micro ST MAC address? So that would actually go into Ethernet right here. And we're looking for the micro ST. So let me click on name resolution. And then I want to see the micro ST MAC address right here. Okay, so this is micro ST. And this is the number of bytes. So 2934 is the number of bytes. Let's try that. Let's see if that's the one. It's not. Okay, so transferred from the micro ST MAC address. Let's see what the hint says. Am I zoomed in? I want to be zoomed out. Okay, the hint says endpoints and name resolution can help. Okay, so we got to go to the endpoints conversation here. Statistics, endpoints, and then we're going to do name resolution and micro ST. Okay, so that's definitely a bigger number. So we have the total would be bytes total is 7474. So I just had it for IPv4, and there was most likely many other types of protocols that were included in that. What is the number of IP addresses linked with Kansas City. All right, so let's go here now, and we're going to look for the geolocation portion. So statistics, and then it was the, ooh, I wonder, let me see if I can recall it. I might have to pull up the hint here. I think it is actually endpoints still. And what we're looking for is the geolocations, right? So endpoint types, and are we looking for, which one was it? Good Lord. So let's go back over here and try to find the geolocations portion here. Endpoints, resolve transport names, and then we're going to go here and then here, and it's the piece right here, geo mapping, and then we can do not activated by default. We need to do the da-da-da-da-da. It supports this, so however you still need the file and provide the path. MaxMind, once you download it, okay, automatically provides geo IP information and the protocol details for IP address, endpoints, and geo IP view. So, oh, map. So I guess, oh, map is not available. So if I click on it, it's still not available. So I need to go ahead and activate the map. And the way that we need to activate the map is by doing this instruction. So provide the database to by using this. So edit preferences, name resolution, MaxMind database directories. So let's go ahead and do that. I'm going to follow those instructions on a second screen here. So, okay, let's go here, and it's going to be under edit. We're going to go to preferences. We're going to go to name resolution. We're going to go to MaxMind. Where's MaxMind? There we go. MaxMind directories at the bottom right there. And then the database directory could be either of these. So I'm just going to do the user shared GeoIP. I'm going to click on that one. Okay, so here's what I did. So I went to edit, I went to preferences, I went to name resolution. I turned on the transport names and IP address resolves. And then down here, I think this was already on because I didn't really do anything here. You just want to click, if you click on one of those things and just click on OK, I think it should be fine. And so then when we go into statistics and we do endpoints and then we look at IPv4, now I may have, because previously I was on Ethernet, so that may have also been the issue that I just needed to switch over to IPv4, which would have been like much easier to resolve for. But then there we go. So now we can see Kansas City, United States is actually included. And so from here, we can kind of just go ahead and apply this as a filter. So if I do that as a filter and see if I can find that, that might be the case. But if I go ahead and close this out, it is just showing the IP address being as the filter. And that's definitely not what I'm trying to do. I'm trying to show everything that has to do with Kansas City. So that might be a specific element of it that we don't want to do. So we're just going to load IPv4 one more time. I'm going to click on city, and I'm just going to go to K to try to see how many are relevant to Kansas City. And in this particular case, there is, what is it? 4, it looks like. There's 4 specific items related to Kansas City. And moment of truth, we need to see if that's actually the case. So is 4 correct? 4 is correct. Okay, great. So, all right, hopefully you were able to follow along with that. Finally, which IP address is linked with the BlickNet AS organization? And the hint says endpoints can help. So, okay. So right here, we're just going to go back here. We're going to do name resolution, and then we're looking for BlickNet. So name resolution, address, and then you'll see the names are associated with it here. There's nothing that I can use to search for it in here. So I have to kind of do the address breakdown and then just go to, I guess, B, see if I can find BlickNet specifically. Okay, so this may have been kind of like a shortcut around this because I was having a hard time going through this endpoint menu here with all these IP addresses and trying to find them associated with BlickNet, whatever. So, I mean, we are hackers, so technically we should be doing things as quickly as possible. What I did was, and this is something that we covered in the last video, so I went to edit and I did find packet, which is also Control F. And then all I'm doing is looking in the packet details, which is the information that's in the bottom left right here. And then I'm searching for BlickNet, and I just made sure to capitalize the B, but I don't think I even needed to do that. And then of course it found the packet for me. It's packet number 6415, and it shows me the IP address as well as the the domain that's associated with it. So blick.net. And so if we go down here now, we can actually see the IPv4 version or the IPv4 address right here for BlickNet. And it's the destination of the IP address is the, where is it? 188.246.827. 188.246.827. So let's do that. 188.246.827. And oh, that's not the right answer. Okay, well, there we go. Oh, I did 247. It's 246. Whoops, 246. Okay, there you go. Okay, that was the right answer. My bad. That was the right answer. 188.246.827 was the right answer. All right, cool. Let's go to statistics, protocol details. All right, up until this point, almost all the options that we have has contained both versions of the IP addresses, which is IPv4 and IPv6. The menu has two options for narrowing these statistics down based on a specific IP version. So analysts can identify and list all events into a specific IP version in a single window and use it for the event of interest. So we can do statistics, IPv something statistics. So IPv4 or IPv6 statistics to be able to view this kind of information. So in this case, they did IPv4 statistics, and now we can see everything that has to do with IPv4. And then underneath this, so when you do IPv4, it opens a new menu. You can do all addresses, which is what we see right here. We can do destinations and ports, which is what we'll see over here at the bottom. And then we can do IP protocol types. So IP protocol types is this specific view. So this is all addresses. This is IP protocol types. And then this is what we see down here for destinations and ports right here, as well as source and destinations addresses right here. So it's like a very disorganized way of displaying this information to us, but okay, we can look at a bunch of things. And then we have the DNS view. So it breaks down all DNS packets from the capture file and helps analysts view the findings in a tree view based on packet encounters or packet counters and percentages of the DNS protocol. So we can use this overall usage, including R code, opcode, class, query type, service, and query stats, and use it for the event of interest. So statistics, DNS, and then we get a bunch of different options. This one's a little bit cleaner, thankfully. We have HTTP, which would be similar for finding anything that has to do with the HTTP protocol, right? So statistics, HTTP menu, and then we can see this one has a few different options. I don't know why they do it like this, where they break them down. Why not requests should be up here? Or I don't know, bro. Why would they do this? Like whoever did this is clearly ADD or something. So packet counter up here. Load distribution is right here. Requests are right here. So this actually shows us all the domain names. And then we have request sequences of what happens from this domain and then the various elements inside of that domain that were found. This seems to be pretty handy right here. That's really cool. Then we have the load distribution, which is the number of packets, I'm guessing, that went through each one of these different DNS. And then we have the total, right? The packet counter total right there. So, okay. All right. Let's zoom out and let's go and actually find our answers here. It says, what is the most used IPv4 destination address? So we're going to cancel this out to reset everything inside of our search to all of our packets. Very good. Statistics. We're going to go IPv4 statistics. And then we want destinations and ports, right? So it says the most used destination address. So we can also do source and destination addresses. So these are all the source addresses. And let's see if we can find all the destination addresses and find the most used destination address. So there we go. Destination addresses count. So if I do that one more time. So the most used destination address right here, 10.100.133. So 10.100.133. What is the max service request response time of the DNS packets? So we're going to close this out and we're going to go into DNS. So statistics, DNS, very good. And then it's asking for the max service request response time. So service request response time, the max service request response time. So this is what we see right here. Request response time, 85 seconds. Total average minimum value and maximum is 0.467897. So 0.467897. And what is the number of HTTP requests accomplished by radmsn.com? So then we're going to close this out. We're going to go back to statistics, HTTP, and then requests. And we're looking for, I think we can actually search for this one. Hopefully, can I search for it or no? Oh, it's still loading. So okay, very good. Now it's finished. So rad.msn.com. So we'll do rad.msn.com. Oh, that's the display filter. So what if I do what's the best way to search for this? That would be the key term here. I need to find the request count, right? Because it says the number of HTTP requests or number of HTTP requests so I need to go into HTTP, not DNS. So HTTP packet count. Oh, that's where I was. So packet counter, load distribution, request sequences. Maybe we can do load distribution. There we go. Okay, cool. And then we are looking for the, one more time, we're looking for rad.msn.com. All right, let me see where I find this thing. Okay, so it honestly wasn't that hard to find by just browsing. And I think it's 15 because we see it right there on the screen. So let's try if it's actually 15. And it is not 15. So make sure it follows What's the hint here? HTTP statistics. So this is where we went to, right? So statistics, HTTP, and this is where we went. So the specific one that we're looking for is the rad.msn. Now, to be able to find something that has to do with rad.msn, I want to say that it's the HTTP. Let's go back to these screenshots right here because I think this is also really handy. So the number of counts that we can see specifically has to do with load distribution. So load distribution is the only one that really shares that information for us with the number of counts that it has for a given domain name. So if I go to load distribution, the key piece right here is just trying to find a way to find that specific domain. So you can always either browse through them, right? So we can see these are the request response codes. So none of these are relevant to me. So I'm just going to close that. Now, request by server, these would actually show the names right here. So we have the rad.msn, and there's multiple versions of it. So there's actual rad.msn, b.rad.msn, a.rad.msn. So technically, that could be the full thing, where it's like, okay, so this one actually has 23 under it, and then this one has 14. So technically, that's 37. So maybe that's the answer that they're looking for is 37, like the total, and that's not the total. Okay, so I got to find exactly what it is. And oh, here's another one. So rad.msn. So I need to just find a way to be able to count all of these counts because it seems like I'm missing something here. So let's see. Maybe we can do ip.address equals 655515.244. And so there it is. And so let's see if we can get the full count here. So it says 24 on here and another 24 requests by HTTP host and by HTTP address. Both say 24, and I thought 24 was the right answer, but it's not the right answer. So there might be something that I'm missing here. Okay, here's the problem. So first of all, I found a place to find the answer, but the issue is it's actually, so it's inside of HTTP requests, but when you load it, you have this kind of a view where you don't see, and this happened in the last video too, you don't see that, you know, there's actually another column at the end. And again, in the last video, there was also a similar response where I was like, it's so much simpler than you think it is a lot of times. And this is one of those times where I'm like, okay, well, I need to find it. I can't find it. Let me do all these advanced search types or tactics, and none of it worked. So it finally got to the point where I'm like, okay, let me just look into this other field for requests. And lo and behold, there's actually a number of the count. I just need to just move the search thing right here so that it actually brings the count column. That's so annoying. But okay. All right, so we now know where to look, and now we need to look for rad.msn.com, which is really, really easy to find. So there's rad.msn.com. Good Lord, 39 is the count. And there it is. Lo and behold, that is the answer. My goodness. Okay. All right, moving on to packet filtering principles. Okay, packet filtering comes in a few different shapes and sizes. In the last video that we did, the basics video, we covered that packet filtering can be done without using queries. In this room, we're actually going to use queries to filter packets. And as mentioned earlier, we have two types of filters in WireShark. Both of them are similar in syntax, but they are used for different purposes. So we have the capture filters, which is the type of filter that's used to save only a specific part of the traffic. So the traffic that you are capturing. Think about it like that. You are capturing traffic and you want to filter what part of that traffic you're actually going to capture. And you set this before you capture the traffic, and it's not changeable during the capture. So once you set it, you are pretty much there until you stop the capture, and then you go back and you reset your filters. And then we have the display filters, which are used to investigate packets by reducing the number of visible packets, and that's what we've been using so far, are these display filters. And as the name implies, once you have all of the packets, what is displayed for you can be changed via these display filters. And these are changeable during the capture, and they're also changeable during your investigation, obviously. You can't use display filter expressions for capturing traffic and vice versa. So keep that in mind. They're actually very specific to each goal that you have. So capture filters can only be done to capture, and display filters can only be done to display. And the typical use case is to capture everything and then filter the packets according to the event of interest, which is basically what I've done for most of my experience with this. Only experienced professionals can use capture filters and sniff traffic because they already know what they're looking for. So think about it like that. If you already know where you want to look, where you want to capture traffic, then you can go ahead and do that. And especially if you have a really massive network that within 30 seconds you're going to capture, millions of packets. If that's the case, it's going to take much longer to filter through millions of packets. So if you know how to create capture filters to only get a segment of your network and only get those traffic items, then that would be the way to go, right? So I don't think it's difficult to do. It's just you need to know what you're looking for. That's kind of the key piece right there. You need to know where you want to look. This is why WireShark supports more protocol types in display filters, because it's usually that we're capturing everything and then displaying or filtering through the displays. So make sure you actually understand how to use these capture filters before using them in a live environment. It's very important because you can't capture the event of interest if your capture filter is not matching the specific traffic pattern you're looking for. Again, so kind of going back to, you need to know what you're looking for before you can use those captured filters. The capture filter syntax use byte offsets, hex values, and masks with Boolean operators. And it's not easy to understand, predict the filter's purpose at first glance. The base is like this. You have the scope, direction, protocol, and the sample filter that we can see right here. So the scope would be, do you want to capture a host? Do you want to capture a network? Do you want to capture a port on a host? Or do you want to capture port ranges? The direction would be the source of the traffic, the destination of the traffic, the source or destination as a Boolean. So this is this operator that you see right here. That's an operator. So source or destination is actually a choice all in itself. And then source and destination, that's another operator. Whereas like you can see this right here where it's like, oh, okay, I don't want just, if you can imagine, this would show you everything because you're using OR. This will show you a very specific set of traffic items because both source and destination have to match something. Then we have the Ethernet, WLAN, IP, IP6, address resolution protocol, remote address resolution protocol. I think that's what that is, or maybe routing address resolution protocol, TCP and UDP. And then the sample filter is that you want TCP port 80. So everything that would come through the HTTP port is what you're trying to capture. So you can read more about this on I'm assuming it's the WireShark. Yep, this is the WireShark documentation, and this is for the PCAP filter. This is the actual direct link to it. So docs/man-pages/pcap-filter.html. And we also have another one here, which would be the GitLab documentation, the wiki pages for WireShark. So this is actually nice, the fact that this one's still up. The other one we were trying to reference did not exist. This one is a little bit tougher to read through this, but you can kind of just screenshot it if you want to go directly to that specific link, and that will be our documentation. So here's just a view of this. So as you go through capture, when we click on the capture button in our toolbar, we actually can click on capture filters, and then we can choose any of these filters that are pre-existing for us. And as you can see, there's a good amount of them, and they serve a variety of different purposes. So you can just choose those. Then we have the display filters. So this is WireShark's most powerful feature, and this is what we've used by far so far. It supports 3,000 protocols and allows conducting packet level searches under the protocol breakdown. The official display filter reference. This is probably a really good cheat sheet right here. And this is directly from WireShark/docs/DFREF. Display filter reference is what that stands for. It has an index at the top right here, and you can just click through the index and try to find whatever it is that you're looking for. As you can imagine, this is a massive list of filters. There's a lot of stuff that can be done here. I'm actually going to save this because I think this is really clutch. This is like really, really, really good. So WireShark display filters. We'll do like that. That is actually really, really handy. And I've always wanted that list because there's been other investigations and I'm like, I know there's a list. And I forgot to save it the last time that I did this. So now I have saved it and I would highly recommend you save it too. Okay, so sample filters to capture port 80 traffic is tcp.port equals 80. Now, this is saying capture, but we're actually talking about displaying. I think it's supposed to say sample filter to display port 80 traffic, which is what that looks like. And so it has a built-in option, display filter expression, that stores all supported protocol structures. I think this is probably another one that I could have found inside. I knew that there was one inside of WireShark too. It helps you create display filters if you wanted to. We will cover the display filter expression menu later. Now let's understand the fundamentals of this. And you can go to Analyze Display Filters menu to look at the display filters. And it's quite similar to what we saw with the capture display filters or the capture filters. The comparison operators. Okay, this is actually really important. So comparison operators are the elements of your filters that you should be getting right in order to actually get the response that you're looking for, as well as obviously this key element. So if we can think about these as key value pairs, right? In coding, this is what we usually talk about, is that the IP source here is the key, the value would be this IP address, right? And then we have the actual operator. So in the English equivalent, it's equal, EQ would be the equivalent of this double equal sign, which is, I guess, similar to the C language, but it's also very similar to Python. So equal is the EQ version, the coding version is double equal signs, and then what it actually means is that it is equal. So IP source equals this, and then you would only see source IP addresses that are matching that value. Not equals would be NE, and then the equivalent in code is exclamation equal sign, which means it's not equal. So it will show you everything that does not equal the IP source of that value. Then we have GT, which stands for greater than, and this is the, I don't know what I call this, like the forward arrow, I guess I would call it that, but it's the greater than symbol basically. And so everything greater than 250. So IP time to live greater than 250. Less than would be IP time to live less than 10. So the less than symbol that you see right here. Greater than or equals to, and this is very similar to exactly what it looks like in Python and C and everything like that. So greater than, and then the equal sign after the fact, would end up being greater than or equals to. So if it's greater than or equals to 0xFA, then that would be the return that you would get. And then less than or equal to 0xA would be what you get right here. So these are the operators. These are actually really handy to use, and you should very much make sense of them. And they're pretty commonsensical, honestly. Like the English version, equal to, not equal to, greater than, less than, greater than or equals to, less than. Those things are pretty straightforward, and so is the code version. Honestly, these things, I feel like on the first glance, you can kind of memorize them real quick. WireShark supports decimal and hexadecimal values in filtering. You can use any format you want according to your search. And then we have the logical expressions. So it supports Boolean syntax, and you can create display filters based on this. So, and, right, that's the English. You can actually say and, or you can say double ampersands, which would equal to and then the logical and. So meaning IP source equals this, and IP source equals this. So now you're going to get all of the traffic that has IP sources being those two values. Or is the pipes. So there's two pipes, and these are the vertical pipes. So on my keyboard, it's right above my enter button, which is when I hold down shift and I do the backslash button. So if I do shift and backslash, then I'll get a pipe. So this is double pipes. So this is the logical or. So you can also type right here, this or that. And so you would obviously get anything that has either of these in it. And then not would be the exclamation mark or the word not. And it's basically the logical not. So you can, the way that this works is that you put the not or the exclamation before this thing right here. So it would say, technically it would say something like this. It would say this and not, you would put the exclamation right here. So this and then exclamation this, which would obviously only just show that and then exclude any of that. So typically it might be like, TCP port 80, not IP source this. So it's like everything on TCP port 80 with the exception of anything that has to do with this specific IP address. The usage would be exclamation equals value is deprecated. So this is not, we're using this. So it would be using the exclamation and then the value. So it's not exclamation equals value, it's exclamation and then the value, which is suggested for more consistent results. And finally, we have the filter toolbar, which we can actually see creator to apply our display filters. And it is actually really handy because if you put it correctly, it is green. If it's incorrect, it's red. And if it's warning, meaning it's not consistent or might not work, it's unreliable, then it'll come in yellow. So these things are actually really, really handy. And so this is the sample version of them right here. We can see that, IP.proto equals 6 was green, which means that's actually a good filter. You can use that. It may not give you results, so this is not to be confused that you're actually going to get results. It's just that the syntax is correct. And then this one, IP proto with 2 O's equals 6 is an incorrect filter, and that's not even going to work. So even if there were results, it won't show you anything. And then IP proto exclamation equals 6 is saying that it's not reliable. So it's not red, meaning that the syntax is correct, but it's not necessarily reliable. So it may or may not bring you results. And this is what we want to keep in mind. So the big thing that I always look for is green. So if it's green, then I'm like, all right, at least the syntax is good, and I can expect that I'll get some kind of results if the results are there. And if there are no results, then there are no results. So the syntax was good. Maybe I need to change the filter, look for something else, etc. So the filter toolbar features are shown below, so we can see this right here. So you can actually go to the bookmarks right here on the very left. So there's actually a bookmark button. You can go to the bookmarks and you can see everything that's available that you have bookmarked or has been bookmarked. If you just type in IP, then automatically the autocomplete portion pulls up, and you can kind of scroll through this with your mouse and see which one of these might be closest to what you're looking for. And then X would obviously clear the filter. And then the drop-down menu is the filter history. So you can actually look at your filter history to see what previously has been searched for before your current search query. And so this is basically, this was all read-only stuff. There's no questions that we have to answer here. It's just that we need to actually really be fully aware of what is available to us in these particular cases, because we are going to use them to answer the questions in the next section, which is actually the packet filtering protocol filters section. So let's get into it. Okay, so the protocol filters here. So we have a few different categories of these filters that we're going to review. The first one is going to be the IP filters. So this has to do with the traffic according to the IP level information, IP addresses basically. And this is based on the network layer of the OSI model. This is one of the most commonly used filters. So this is what we're going to look at. And you can find things like IP addresses, the version, time to live, type of service, flags, and checksums. So you would do IP dot, and then the rest of it would be, IP dot TTL or IP dot source, etc. So IP will show all IP packets. IP dot address equals this will show all packets containing this IP address, whether it's the source address or the destination address. IP address equals this, and then you see this end portion right here where there's a 0 on the last octet /24, which will then show us anything that has to do with this subnetwork right here. So as long as it starts with 10.10.10, the end part could be anything else. So it'll showing us everything that has to do with that subnet. IP source $sign equals 10.10.10. 111 is now showing us the IP source address. IP destination will show us the IP destination address. And then the IP dot address versus IP dot source / IP dot destination. So this is just an extra note where it says it filters all the traffic without considering the packet direction, which is this piece right here. And then the IP source or destination filters depending on the packet direction. Obviously. So, I mean, that's kind of redundant because we already talked about it over here. But that's the difference between the two. Okay. So I know that this is actually an animated GIF. So if we look at it, they're just going to put this filter right here. So he's doing IP dot address $sign equals, and then he fills in the value. And then once he fills in the value, we actually see that it then turns green. And then now they press enter or click the search button, and then now you can see that any destination or source that has that equivalent value right here, this piece right here, because he does IP.addr. So that ends up showing us anything that is the destination or source of that IP address. Then we have the TCP and UDP filters, which have to do with the specific protocols themselves. So the TCP or UDP protocols, they can look at information like the source and destination ports, sequence numbers, acknowledgement number, window size, timestamp, flags length, and protocol errors. So TCP.port equals 80 will show everything that has to do with TCP packets with the port 80. UDP.port equals 53 will show all UDP packets that has to do with port 53. TCP.source port is very, very similar. Like these things are, once you notice the patterns, you can pretty much predict what it might even be if you've never even used it, right? So TCP.source port is what you're looking for, is 1, 2, 3, 4. UDP.source port. TCP.destination port, right? DST. UDP.destination port. So again, these things are very, very commonsensical. They're like once you notice the patterns, you are pretty much good to go. So they're searching for TCP.port $sign equals 80, and so it's going to show anything that has to do with the port 80, and then you can see it right here, right? This is the destination port, source port, destination, and then source, destination, etc., etc. So you can see that it pulls up everything that has to do with port 80. And then we have the application level protocol filters. These are the ones that I think are actually really handy because the first set are very basic and easy to understand. So these end up being on the application level, the application layer of the OSI model. And you can look at things like payload and linked data or whatever might actually be in it. So I'm kind of, I think, too zoomed in. So I'm going to zoom out a little bit just so we can see the full thing. There we go. So HTTP here will show us all. So you literally just type HTTP, press enter, and it'll show you all of the HTTP packets. DNS will show you all the DNS packets. This is what's really handy. So http.response.code equals 200 will show you everything that has a 200 response code, which is a successful code, right? So there was a successful HTTP request that was done. DNS.flags.response equals 0 shows all DNS requests. And for these, you actually need to know what these things mean. So for example, if you don't know what a response code of 200 means, then it's kind of useless for you to even use this kind of filter. So you actually do need to know a little bit more detail about these different search values, or search keys, I should say, so that you can actually find the values too. So it's like the search key and then what their values could be, because the value is not a port number, or the value is not necessarily an IP address or anything like that, right? So HTTP request method equals get. So it shows all of the get requests. DNS flags response equals 1 shows all DNS responses. So response right here, so you can see that DNS flags response equals 0, and then DNS flags response equals 1. So 0 in this particular case means that there are DNS requests being made. 1 means there are DNS responses being sent. So HTTP request method post is showing all post requests. And so in the same manner, right? So a get request means that we are retrieving data from a destination, from a server. And then a post request means that we are sending data to that server. There are many other HTTP requests. These are just the key two pieces when you interact with a web page. And then we have the DNS query type equals 1, which shows all of the A records, so all of the IPv4 records. And we have our GIF right here. So if we go look at the GIF, they're searching for http.response, and then they click the autofill .code equals 200. So now they're just going to see all the successful 200, and you can see right here in the info, it's all the successful HTTP requests that have been made. So whether it's a GET request or a POST request or a PUT request or a DELETE request, whatever it is, as long as it was successful, that's what we end up seeing on that specific search. Display filter expressions. So we can now talk about this a little bit more. We mentioned it in the previous task. We can actually create display filters. So if you can't recall the one that you are looking for, if you want to, or if you're unsure about it or something like that, you can actually find a way to use the guide that they have or the list that they have. And very similar to the thing that I just saved when I went to this WireShark display list right here. It's very similar to this. I would say that this is probably much more in depth and comprehensive is the word I'm looking for. So under the Analyze Display Filter Expression menu, it's impossible to memorize all the display filters for each protocol. Each protocol can have different fields, etc. So display filter expressions shows all protocol fields, accepted value types, integer or string, predicted or predefined values, if any. And it will take time and require practice to master creating these things right here. So you can see display filter expressions. Then they come over here and then they can see the field name, right? And then all those. And you can actually create these. So this is what, when they say create them, they don't mean that you're going to write them from scratch. That means that you're going to go from, okay, I need to, most likely I'm looking for an IP protocol, okay, and then I want it to be equals to the value of a TCP port for, that would be 6 in this case, right? And then so at the very bottom of it, it actually creates it for you. And then when you click OK, it puts it inside of the search bar for you right there. So it's really handy. Display filter expressions is actually very, very handy if you don't know exactly what it is that you're looking for. And then you can browse through thousands of entries and then find the one that might be most relevant to what it is that you're looking for. And then that would be great. And then so we also talked about the coloring rules in the last video. So you can create display filters and events of interest and then add a color to it to assign colors to highlight your own display filter results and your own display filters as well, just to kind of create shorthand for yourself as you're doing your investigations. It's really handy, especially if you're doing this for work especially if you're doing it on a specific project inside of WireShark that you don't have to reset, or you're not going to be resetting, you're going to be referring back to it, etc. There are a lot of these things that actually can be very, very handy if you're going to go back to the same instance of WireShark and use the same investigation. All right, so now we're actually going to do our investigation inside of the virtual machine. So let's zoom back out here, and virtual machine adjusts. I had to restart this because I had to stop recording yesterday. So we're going to let that start up real quick just so we can have WireShark going and get our packet or PCAP file, I should say. So we have some questions here. What is the number of IP packets? What is the number of packets with a TTL value less than 10? Number of packets which uses port 4444. The number of GET requests sent to port 80. And the number of DNS queries, type A DNS queries. And we know exactly how to create all of those. So it should be really fun and easy to do. So let's go ahead and do the first one, which is basically saying IP. So if I just type in IP and press enter, it should show me all the stuff that has to do with IPs. And I mean, most of them have to do with IP. So it says 81,530 total, displayed 81,420. So 81,420, and that is the right answer. All right. What is the number of packets with a TTL value less than 10? So if we go back up here, we actually had something similar to that already made for us. So where was it? It was, I think it was in the previous one, in the TTL one that we actually discussed. So IP TTL right here. So IP TTL less than or greater than and something like that. So we're looking for an IP TTL of less than 10, right? That's what they said. Let's verify. IP TTL less than 10. So we're going to do that. So we're going to go here and we're going to do IP.TTL, and then we're going to do less than 10 and press enter. And let's see how many we get. So out of 81,530, we get 66 with less than 10. There we go. What is the number of packets which uses TCP port 4444? So it doesn't say destination or anything like that. So it just says TCP port equals 4444. So that's the filter that I used right there. And it adjusted it for me. And now it says out of the 81,530, we have 632, which are TCP port 4444. What is the number of HTTP GET requests sent to port 80? Okay, so that's good. That's actually really, really fun. So we can do this. I think this is going to be like one of those multiple filters right here. Let me see if I can do it without looking at hints. So we're going to do a parentheses, HTTP request, right? And I think it was request method. So request method equals get, like that, and the sent to port 80. So and what is it, TCP DST port equals 80, and that will be our filter. So it's request method get and then sent to port 80. So now we have, out of everything, we have 527. So let's see if that works. That would be awesome. Yes, that worked beautifully. And what is the number of type A DNS queries? I don't remember that one, but it's definitely in our last portion that we looked at in this section. So there was a section where we were looking at DNS queries, and it was, where is it? Let me see if I can find it real quick. It was actually in our current section. So DNS query type equals 1 is DNS A records, which is the answer that we are looking for, the type DNS, type A DNS. So it was, one more time, it was DNS query type equals 1. So we'll go here. I can actually just clear it out like that. And then we'll go back here and it will do DNS query type, right? DNS query, QRY type, like that, equals 1. And there we go. And the answer is 106. So we're going to go back down here. Oh, no, it's not 106. It's supposed to be 2 digits. So what does the hint say? Don't forget to filter out the LLMNR queries. Okay, what does that mean? Okay, so let's see. Oh, I see. So there's actually a protocol right here called LLMNR, and there's 4 of them. So we can just subtract 4, but we want to write a code for this. So let's go ahead and put this inside of parentheses. So we have that. And then we're going to say and not right there protocol. So what do I want to do? I want to do protocol. Is that what we do? Proto? No. Not. Okay, so that worked. I basically just did and not LLMNR, and then removed those LLMNR protocols. But we are still over 2 digits. We're at 102 now. So instead of being at 106, which is not the answer they're looking for. So this is the challenge here, is that I think there's some kind of a mismatch between the data that they're looking for and the data that I have here, and there seems to be a little bit of an issue. So let's see, if I go ahead and select all of them, how many is that? It's still 102. So okay, all right, let's see here. Let's see what we're missing. I might have to just Google the answer for this, because it seems to be that I have the right query and I'm only seeing DNS and there's no LLMNR. So I need to see what I may have done wrong, or if there was like an update on this or something like that. So let's see. Let's Google some things. Okay, so I got the answer and I Googled what needs to be done. And I will say that the question is misleading, because it says, what is the number of type A DNS queries? That's all it says, okay? And to get the answer, the first portion of everything that we did was right. So it was, DNS query type 1, which is type A, and then not LLMNR to remove all the LLMNR. But apparently there needs to be a flags response equaling 1, which I don't know why that would be the case, because it mentioned nothing about the responses. It mentioned nothing about whether it's a request or a response. It basically just said all of the query types. And so that's what we searched for. But based on other articles from other students, evidently we needed to also track it, or narrow it down by the response that we were getting, which the question is misleading. So we did it correctly. I just want you to know that if you thought that the answer was what we originally got, you were also correct based on the question that is being asked from us. Had they said that we were looking for just responses, then it would have, we would have just added the flags response portion of this as well. But they did not say that, but they were expecting us to do that, which again is kind of misleading. So no problems. We figured it out. Everything's all good. It was not a complicated thing to figure out, but the question was incorrect. I'm just saying, just for the record, the question was misleading. All right, so that is now that, and we're now in advanced filtering. As you can imagine, there is going to be a lot of advanced filtering stuff, and this is not all of it, just so you know, okay? So far we've learned the basics of packet filtering, but we're going to be looking at specific packet details for our event of interest. And a lot of these things that we covered in the previous sections and in the previous video that we did, there's advanced operators. So for example, the word contains. So you see, this is how it gets to like, I don't know exactly what I'm looking for, but I know inside of it, there is something like this. So the word contains is a comparison operator. And what we're looking for is we're looking inside of a packet for a specific value. It's case sensitive. It provides similar functionality to the find option by focusing on a specific field. So for example, you want to find all Apache servers. So it would list all the HTTP packets where the packet's server field contains the Apache keyword. So we're going to do http.server contains Apache. And again, it's case sensitive, right? So now it's not equals, right? Because you don't know if it exactly is equal to that or whatever, because it may not be exactly Apache. It could be like Apache 3.4, whatever, you know what I mean? So, but we know that it has the word Apache in it. And if I do it equals Apache, then it's going to look for exactly the word Apache without any numbers or anything after the fact. So when you do that, then you actually see the response where it'll find that one packet, in this case, where the server, or it's probably better to just do this, the server reads Apache, right? And then Apache /r/n, which are technically just like codes for creating a new line or something like that. But that's basically it, right? So that's all you get for that. So HTTP server contains Apache. So matches. Now matches is a little bit more precise, right? So this is another comparison operator, and it searches a pattern of regular expression. It's case insensitive, and complex queries have a margin of error. So this is the situation where we would actually need it. So finding all .php and .html pages. So you want to list all HTTP packets where the packet's host field matches the keywords .php or .html. So you would say HTTP host matches, and then we put it right here. Look at that. So this is very key. Let me see if I can go in a little bit. So we have the /. This is a regular expression pattern. So when you do a / in regular expressions, that means you're escaping the pattern portion and you're looking for a literal dot. So the reason why we do this is because the dot character is actually a wildcard in regular expressions. So if you put dot, it'll look for a variety of different alphanumeric type things, but we're looking for a literal dot. So when we're looking for a literal dot, then you'll do /. And then inside of our parentheses, we're going to do PHP or HTML, right? And that's it. So you do that, and then now it's going to search for anything that is .php or .html, where the HTTP host actually matches that. And so you can see this right here. Now, key piece right here, we saw that there's only one pipe, but then if we go over here, we'll see that there's actually two pipes inside of the query. So I think that is another key element of this. I don't know if when you do one pipe, it automatically fills in two pipes, or if it'll give us an error like a red box right here. But we can just keep that in mind. But now it found it, right? So it found anything that has a .html or a well, this is .ico, .txt, .php. Okay, these are fine. So that like you see a bunch of .phps, but I don't know why. Maybe it's because like at some point there was a .html in these files right here, but download.html clearly has an HTML in it. So in, right? So now this is the next one. So we did contains, we did matches, and now we're looking for in. And so this sets membership. So we're looking for something that is in something else, right? That's what you mean, is that this thing is a member of this other thing. That's what that means. So we're looking for a search of a value or field inside of a specific scope or range. So for example, finding all the packets that use ports 80443 or 8080. So you're looking to list all the TCP packets where the packet's port field have values of 80443 or 8080. So you would say TCP port in this range right here. And now again, very similar or different syntax to what we've done so far. Now we have I call this the squiggly bracket. I don't know if there's like a different name for this, but I call it the squiggly bracket. There's square brackets and then there's the squiggly bracket. And so squiggly bracket, and then you have 80 space 443 space 8080. You don't have to do pipes, you don't have to do or anything like that. So you're saying TCP port in this range, right? Or in this, not range, in this list, I should say. So TCP port in that list. And we can see right here, if we go here, TCP port in squiggly line 80443 8080 and squiggly line, and then now we can actually see that it pulled it up, and everything else would also show if it was valued there. So now upper. So this is a case sensitive kind of a thing. We're now dealing with case sensitivity. So we're looking, this is a function specifically, converts a string value to uppercase. So find all Apache servers and notice the uppercase, all caps lock, right? So it converts all HTTP packets server fields to uppercase and lists packets that contain the Apache keyword. So for example, upper right, HTTP server contains Apache. So what it's doing, we're not doing upper of this value right here. What we're doing is we're taking the value of the actual key. So the key here is http.server. We're taking whatever those values are, changing them to upper, and then saying, okay, as long as those things contain the word Apache, then we're solid, right? And then so you can see it brings up just one result. And now here's the key piece right here. This is what's really kind of interesting because it gives us the same exact value as the earlier contains query that we did. It gives us that one packet that has the word Apache in it, and the word Apache, watch, A, capital A, everything else is lowercase, right? So that is actually it feels super redundant in this case, but it's like, okay, well, maybe we don't know if the value of this thing has a capital A, or maybe we don't know if it has a lowercase a or whatever. So what we're going to say is that why don't you just turn that value into all caps lock and then look for this word as all caps lock inside of there. And then let me know if you find anything. Whoops, I scrolled when I shouldn't have. Let me know if you find anything, right? And so it does a search, and it finds a value because it's not looking for the precise value here to be caps lock. It's just looking for the uppercase value of that to match our uppercase value that we've entered over there. Hopefully that made sense. Same thing with lower. So it does essentially the same exact thing, and now we're doing the opposite of it, where we're turning the value of this key to lowercase and then making sure that it matches a lowercase Apache. So obviously it would return the same exact packet, but again, capital A at the beginning and then everything else is lowercase. So it's not looking for the value itself to be all lowercase. It's just saying that lowercase, turn the value of this thing, which is this thing right here. Turn this thing into all lowercase and then compare it to whether or not it actually matches this lowercase Apache, because those things are, again, literal case sensitive. Now we're looking for a string. So this is a function here. So you want to convert a non-string value to a string so that you can actually search through it, because some things, if they're not string values, you can't search through them. So you want to find all the frames with odd numbers. By nature, numbers are actually integers. And so you may not be able to search through integers. So you would have to turn them to strings first and then search for them. So we're converting all of the frame number fields to string values and then listing all the frames that end with odd values. So this is another new element here that we are looking at. So this piece should be familiar. We're going to do string and then we're going to do it to the key. So now it's taking the frame number, which is an integer, converting into a string so that we can actually search through it. And then now we're saying that we want it to match this thing right here. And now the $, this is again one of those things that's inside of regular expressions, right? So if we're using matches, we're looking at regular expressions. And so now this piece is just saying, okay, the numbers 1, 3, 5, 7, or 9. And then this $, says that it's the last value. So in regular expressions, the $, is implying that the last, literally this piece right here, that item, or anything that might come after the S, for example. So if it's matches 3, right? All one word, matches, and then the number 3 at the end. It's saying, okay, we are looking for the last item, the last character of whatever that phrase is. We're looking for that last character to be one of these numbers. I hope that made sense. If you have not had practice with regular expressions, I highly encourage you to actually go watch the regular expressions video on this channel. It's pretty comprehensive. I really like it. I made it because I wanted to get really good at regular expressions. So I made it just so I can have a cheat sheet for myself. But a lot of people have also found it useful, and I think you will find that useful as well. So string, right? So we're turning the frame number into a string, and we're saying that it matches this specific pattern, and then the $, represents the last number being, or the last character being one of these numbers. So if we go down here, we can see that frame 1 shows up, right? If you look at the list of the frames, you can see they all end with either a 1, 3, 5, 7, or 9. So 11, 13, 15, 17, 19, 21, 23, 25, 27, 29, 31, 33, 35, etc. So the frame number, right, has been turned into an it's been turned from an integer into a string, and now we're searching through it. So bookmarks and filtering buttons now. Bookmarks are also really handy. So we've covered different types of filtering. It's time to create filters and save them as bookmarks and buttons for later usage. As mentioned, the filter toolbar has a bookmark section to save user-created filters, which helps us reuse our favorite or complex filters with a couple of clicks. Similar to bookmarks, you can create filter buttons. So we'll create it, right? And then you just click the save this filter button, and then you get to save it. And now you actually have a new display filter saved as that right there. Look at that, right? So that is a key element of this to make your life a little bit easier. Because if you know you're going to be searching for a certain thing, or let's say you're going to be looking for this, right? But then this piece is going to change, where it's like, okay, well, I'm looking for all even numbers, so I'm going to change it from 13579 to 24680, right? So that might be it. So creating and using display filter buttons. So this is just kind of the piece for us here. So let me see if I can kind of zoom in on this. Okay, so step one, they have gone and done this plus button right here, this plus sign at the end of our toolbar. And now it says, okay, we are going to add a filter button. So this is similar to saving it as your bookmarks, but now you're just creating a button. So you're going to add a display filter button, and then the name of it is going to be, you know, odd frames. And then the comment is that it's going to find all frames with odd numbers. String, or the pattern itself, the actual filter itself is going to be there. It's going to be saved. And now we have a button on the right-hand side at the end of our toolbar that's called odd frames. And so if we click on that, it will then fill in the filter for us, and then it will load all odd frames, as you can see right there. So pretty handy. It's like a faster way of just having it right there instead of having to go through your list of stuff to find it. It now has this immediate button that you can click, and then you can use it like that. And finally, we have profiles. So you want to do things that, again, make things a little bit easier and faster. So there could be multiple preferences that need to be configured to analyze a specific event of interest. And it's cumbersome, annoying, right? It's cumbersome and, let's say, labor intensive, for lack of a better phrase, to rechange the configuration for each investigation, which requires a different set of coloring rules and filtering buttons. So this is where the profiles come into play. You can create multiple profiles for different investigation cases and use them accordingly. You can go to Edit Configuration Profiles menu or the lower right button of the status bar Profile section to create and modify the profile configuration. And so configuration profiles, and then you have all these profiles here. And then you can even go at the bottom where it says profile, click on that, and then switch to a variety of different profiles. This would not be done inside of a TryHackMe instance because every time that we reset the machine, all of these things are reset. So what you do this for is your own installation of WireShark, or the one that's installed at your job, right? This is where you would create those because you can save it, and then anytime you restart your computer, it's still there, right? These profiles still exist. And it makes it, again, really freaking handy. So just to keep that in mind. So you can see right here, there is the, there's the default that comes with it. Capture the flag that they have. It's a personal profile type. Network troubleshooting and threat hunting. These are all personal profile types. And then the global profile types of Bluetooth Classic and no reassembly are available here as well. And then, so they've created it, right? Configuration profiles. You can go and click on configuration profiles, choose one of these, click OK, or you can go to the bottom right of the window, where it says profile default, click on that, and then you can do switch to, which will switch to whatever is available, or you can do manage profiles, which will then open this window for you, and then you can start managing the profiles. So all of that is there. So now we get to actually use all of this advanced information and do an investigation. Very, very excited about it. So the first question here is find all Microsoft IIS servers. What is the number of packets that did not originate from port 80? So we're looking at two specific filters here. We're looking for all Microsoft IIS servers, and then the number of packets that did not originate from port 80. So everything that is not a source of port 80, and then it should contain, Microsoft IIS basically. So I think that's probably the phrase that we're going to look for. Microsoft IIS. So it contains Microsoft IIS, and then we're looking for anything other than a source port of 80. Okay, so we're looking for, I think it was the HTTP server is what we're looking for. So let's make sure that we have all the packets displayed right now. So we're going to look for a specific, we're going to look for a specific filter here. The first one is the HTTP.server. There we go. So HTTP.server, it should contain, right? So it contains something. And I'm going to start with IIS, just see if that is good enough for me. So I'm going to press enter on this just to see what we can get. Okay, cool. So we actually get it. And if we go to transfer protocol, and then if we look for the server value, let's see if we can find the server value that will actually show us the server. Yeah, we're good. Okay, cool. So it's Microsoft IIS. We can actually see this right here. So Microsoft IIS is in the server value. And okay, that worked. So great. So now we can customize this a little bit more. And we say we don't want, it's a source that did not originate. Yeah, so originating port. So the source port is what we're trying to avoid here. So we're looking for and TCP source port does not equal 80, right? That's basically what we're looking for. And so notice that it's giving us this yellow thing because it may not be reliable, right? So it may have unexpected results, whatever. So let's see what that does. So we'll do it. Let's see if it actually modifies it for us. It did. So it did modify it for us. So now we only have 21 packets displaying. So that should be solid. So let's see if that works. Okay, great. So that worked. So the filter was HTTP server, HTTP.server contains IIS, right? And then TCP source port does not equal 80. So that's that one. Next one is find all Microsoft IIS servers. What is the number of packets that have a version of 7.5? So this is something else that we're looking for. So, I mean, there's going to be the same portion at the beginning. So we'll do that part, or I'm going to leave the and because I still want the and in there. But now we're looking for, again, another element of the server. And in this case, we actually want it to contain, so it needs to match, right? And we're looking for, what is it? 7.5. So we want it to match 7.5. So there we go. So now that's green. So that should, it's a valid syntax, right? So we're going to look for that. And okay, it did work. And so if we go down here, let's see what's right here. So do we see the server? Where's the server version? Server Microsoft IIS. And then we can see that there's a 7.5 in there. So that is perfect. So the number of filters, or the number of packets, excuse me, is 71. So let's try 71. Okay, that worked as well. So the next one is, what is the total number of packets that uses ports 333, 444, or, so these are all or, okay? So we're looking for a range of ports, if you remember, right? So it's going to be the membership thing that we were looking for the other time, which basically means the word in is what we're looking for. So it's a TCP port, right? So we're looking for a TCP port, and it would be in, and then we need that list. So it's the squiggly, or no, that's the square bracket, squiggly. So shift and then the square bracket. And then it was 33, 44, 44, and then 99, 99, and then close the squiggly bracket. There we go. Nice. Okay, so what do we got? We got a total of 2235, which seems pretty high, but I mean, that makes sense because we're doing a range of all of these. We can say like it should be in all of them. So let's see if that works. Okay, cool, that worked. Okay, nice. What is the number of packets with even TTL numbers? Okay, so remember what we're looking for, right? So we're looking for, we have to turn it into a string first, because if it's a number, it's an integer. So we need to turn it into a string. and then the value was the IP TTL, right? TTL, IP TTL is what we're looking for, but it needs to be, what's going on? Okay, here we go. I thought my keyboard died for a second. I was like, don't do this to me. I'm almost done. Okay, so string is what we're going to do. We're going to turn it into a string value first. And then we're turning the IPTTL into a string value, the time to live. Okay, and we need to use a regular expression, right? So remember that, because we're looking for the last character. And so the word matches is a function. It's basically a function that allows us to search for regular expressions. So we're going to create our parentheses, or what am I saying? Our quote. Then we're going to have the squiggly, not the squiggly, square bracket. My dyslexia is super strong right now. And we're looking for it ending in even numbers, right? So it would be the 24680, right? That's all of the even numbers. And then we're going to do a square bracket, and then we're going to do a $, because that means that it's the last character. And then we're going to close the quote, and there you go. So we got a green, which means the syntax is solid. So here we go. Moment of truth, pressing enter. What do we got here? We got 77,289 packets that have a time to live that ends with a even number. So let's see if we can go and actually see that real quick, because that is very important. I mean, I want to say that it actually did work, but I want to actually see the TTL. No, it should be up here actually. So the frame time to live, where is it? Where's the TTL? I want to find the TTL so I can actually verify that this is exactly what it is that we're looking. Time to live 128. Okay, so there you go. Time to live 128. That actually worked. Okay, great. So the number is what? 77,289. That's a lot, man. So 77,289. That is the right answer. Awesome. Okay. So change the profile to checksum control. What is the number of bad TCP checksum packets? Okay. So we're going to go down here. This is where we can quickly change the profile. So we're going to click on that, and we're going to change it to checksum control real quick. And then we're looking for, let me also delete this filter to show it all. And so I'm looking for bad checksum control packets. I don't exactly know what that means really. So how do so I changed the profile to checksum control. What else am I looking for though? That's the piece that I'm kind of confused on. So let's see. I don't know how to create this kind of a filter. So here's what we're going to do. So we're going to find our display filters, which was on the analyze. There we go. Analyze display filter expression. Okay, so now we should get a menu. Okay, great. So from here, we need to find the checksum. So I'm going to search down here for checksum at the bottom right there and see what shows up for checksum. And I guess a bunch of stuff shows up for checksum. Checksum status. Can I check for checksum status? Will that show up? Okay, this is still a very, very large list. So what's the question asking again? What is the number of bad TCP? Okay, bad TCP check. Okay, that might help me. So TCP checksum. So let's go. We're going to go to the TCP portion of this. And thankfully, it's all alphabetical. So I'm just going to grab this and go all the way down to T. And let me find the TC. Okay, too much. So now we need to go to TCP, and okay, there's TCP. Okay, so TCP now. We're going to expand TCP, and oh my God, there's a bunch of stuff in here. So we're looking for checksum. So TCP, and this is all alphabetical too. So okay, TCP checksum. Nice. Okay, there we go. TCP checksum status. TCP checksum status is what I'm looking for. Okay, so there we go. Now I have this, and then there we go. Predefined value is bad. Okay, so that's cool. So now here's my filter. TCP.checksum.status equals to 0, which is bad. So we're going to click OK. It's going to add it here, and we're going to press enter, and it's going to filter everything for me. And I have 34,185 filters displayed. Okay, so let's see if this actually works. 34,185. Nice. Okay, cool. So change the profile to checksum control. What is the number of bad TCP checksum packets? and then you saw that we went to analyze display filter expression, and I literally had to just browse through it to find it. But the key here was that we're looking for TCP filter and then checksum, obviously. So TCP checksum, and it needs to be bad, not good, bad. And finally, we have the existing filtering button to filter the traffic. What is the number of displayed packets? What does that mean? So the existing filtering button. Oh, there's a button, existing filtering button. There we go. So this is the button right here. GIF JPEG with HTTP 200. So I'm just going to click that right there. And okay, there you go. It automatically pressed enter for me. So now I have 261 packets. And moment of truth. Wonderful. Amazing. Yes, we got it. Super excited about it. We're done. Oh my, that was cool. That was actually fun. I like that. Hopefully you were able to follow along and actually get those answers as well. Okay, so hopefully you were able to follow along with that and you actually got the responses that I got. And hopefully you understood what it is that we actually did. The key piece is that I want you to understand what it is that we did, and at the very least have some resources to go ahead and duplicate the same activities that we pulled through with other investigations. That's kind of like the key piece that I want you to be able to take away from this, because getting the answers is one thing. The other thing is knowing how we got the answer. That's like the most important part of this whole thing, because you need to be able to duplicate the mechanisms that we utilized so that you can actually duplicate the results that we got with different questions and different investigations. That's the key piece that I really want to give away from or give you and have you take away from it. One of the big pieces was the WireShark.org docs/DFREF, the display filter reference guide. This is very, 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 very handy, very useful. Over 328,000 fields in 3,000 protocols. Very, very massive list. As you can see, it's gigantic, and there's a lot of stuff that's available here. So this is the key piece that I think you should take away with you, because if you can't find anything, then you'll be able to find them here. And so, for example, if we do checksum search in here, we can now see distributed checksum clearing protocol, which actually is a part of the display reference guide. It's not the one that we found. The TCP dot. Oh, why isn't it in here? That's so interesting. Okay, so this is not the full list, because the stuff that we saw on the internal guide was actually very different. So the WireShark filter manual page, this is probably, nope, this is not an all-inclusive list either. So we may have to click around. This is a good one. I think this is a good one, but I don't think this is the full thing, because the one that we just used for the very end, the TCP checksum one, is not even on here. So this is one of those things that I am very curious about. So I would say this is a good resource. I don't think this is the full resource. So this is one of the key things that I just learned myself as I'm going through this. So there is the WireShark documentation page, which I think will give you a good deep dive on this. And then really, honestly, if all else fails, one of the greatest things that you can do is you can go to ChatGPT, Grok, Google Gemini, whatever your favorite AI, whoever your favorite AI is. And then from there, be like, this is what I'm looking for. And can you please help me establish a filter for WireShark? And then it'll do it magnificently, because those tools are really, really handy for us. Those AI tools are super handy in this kind of an instance. But other than that, we're officially done with today's exercise. So I hope you got some value out of it. If you did get value out of this video, and if you'd like to get more videos like this one, then I encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel. Of course, we're going to be continuing with SOC Level 1 for 2026, and then there's the pen test exercises for CompTIA Pen Test Plus. There's AI for cybersecurity. There's going to be the new Linux Plus series that's going to come out, because there's a new exam that was launched. We just finished the CySec Plus for 2026. And there's a handful of standalone videos that I have in mind that I want to create for you, because I know they're going to be super, super handy and useful. And I just want to make sure that you have access to those as well. So all of that is coming up. And if you want to make sure that you actually get those, then like, subscribe, and turn on the notification bell. If you have any questions about what we did today, drop it in the comments section below and I will address them as fast as I possibly can. I am extremely busy these days, so please be patient with me. It may take me a day or two to respond to the comments that come in, but I always respond to the comments that come in. At the very least, once a week, I go into the comments section and there are literally dozens of comments waiting for me. And I'm like, okay, I got to make sure. And I address all of them. And if you have in-depth questions, then I will address your questions. And if it's a really big question that requires a long response, I'll create a video in response to your question. So all of that is available. So drop your comments. If you just want to say hi, or if you actually have a question, drop it all in the comment section below. If you have success stories, this is another thing that I should probably ask. You know, I posted this a day or two ago. Ben Peters, 6808, just finished getting his Pentest Plus examination. Like, he just passed his Pentest Plus exam, and he gave us a shout out saying that, you know, your content and videos helped explain a lot of these things. And obviously when I get these things, I screenshot them immediately. I drop it in our community post because I want other people to see that we actually have students who are succeeding with our content. And there's a lot of them. There's a lot of these stories. So let's see, we have like a, you know, Wicked Aussie who also passed their Pentest exam. Another Pentest. I think there was a lot of like Pentest people who passed recently. But there's other exams, right? Pentest happens to be like the big one that's been happening recently, because I think that was like the bigger course that I put out. But then right after the Pentest Plus one, there was the CYSA Plus, and then there's going to be the new Linux Plus that's going to come out. So there's a bunch of courses, and we're working on getting accredited with CompTIA so that we can actually get you discounts on your exam certifications and the certification vouchers. So I'm really excited about that. There's a lot of good stuff in the works, and you want to be here. I'm telling you, you want to be here. So make sure that you like, subscribe, and turn on the notification bell so that you can get notified the next time that something happens on this channel. And if you have not done so already, make sure that you check out Hackaholics Anonymous. If you want access to my notes and exclusive downloads, and to get lifetime access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers. We have the supporter, the agent, the guardian, and the master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below, and you will be able to choose the tier for which you want to join. I really hope I see you in the Discord chats. If not, I hope I see you in the comment section. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease, and I will see you in the next video later. Today we're going to complete our WireShark series by learning how to find anomalies using WireShark. My name is Hank Hackerson, your trainer for today, and to get more videos like this one, make sure that you like, subscribe, and turn on the notification bell. We're going to be using the WireShark traffic analysis room that is inside of TryHackMe. This is a premium room, but again, as always, you can always just download WireShark onto your own computer, or you can get a free membership to TryHackMe and then use all of the free rooms that they have. They have literally hundreds of free rooms that you can leverage to get access to WireShark, and then you can use the tool in a very similar manner that I'm going to be using it today. And the only difference will be that you won't get access to the same packet capture files, the same PCAP files that I would get access to. But honestly, it's all pretty much the same. So you can find a bunch of PCAP files available through a variety of different resources for free. Just make sure that they are from legitimate resources and you don't download malware onto your computer. You can always use a antivirus tool or some kind of a scanner to just make sure that it is a legit file that you're downloading. So apart from that, the rest of it should be pretty straightforward and very similar to what I'm going to be doing today. So we have the introduction, then we have Nmap Scans, ARP poisoning, identifying hosts, tunneling traffic, Cleartext protocols, for FTP and HTTP, and then we have the encrypted protocols, and then there's the bonuses, and then we have the conclusion, and then we will wrap for today. All of the timestamps for these are going to be in the description below, so if you wanted to jump around, you could definitely do that, or if you wanted to repeat a specific section, you can do that. But that's pretty much it, pretty straightforward, and it should be a really good one because it is, as you saw, there's a variety of different tasks that we have. So I think this is going to be a longer video today, and we're going to be doing some pretty advanced stuff relative to everything else we've talked about so far with WireShark. Again, this is one of those industry standard tools that you really want to get good at. So if you haven't watched the previous 2 videos on WireShark, I highly encourage you to do that because we're going to be talking about some more intermediate / advanced type stuff today, and you want to have a strong foundation before you go into this specific content that we're going to be talking about. So quick little note from Hackaholics Anonymous, and we will dive into the introduction. If you want access to my notes and exclusive downloads and to get lifetime access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers. We have the supporter, the agent, the guardian, and the master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below, and you will be able to choose the tier for which you want to join. I really hope I see you in the Discord chats. If not, I hope I see you in the comment section. In the last 2 rooms, or in the last 2 videos, I should say, in this SOC Level 1 series that we're in, we covered how to use WireShark and do packet level searches. Now we're going to be investigating, correlating those information, that packet level information, to see the big picture in network traffic, for example, detecting anomalies and malicious activities. For a security analyst, this is a very important skill set. So this is a very vital stop to understand pieces of information spread in packets by applying the knowledge and tool functionality that's available through WireShark. So we're going to be talking about investigating packet level details by synthesizing the analyst knowledge and WireShark functionality for detecting anomalies and odd situations. Prerequisites are the last 2 videos. So the WireShark basics and the WireShark packet operations videos, literally the 2 episodes right before this specific episode inside of the SOC Level 1 2026 playlist. So if you haven't watched those, please go ahead and watch those. The setup is that we have a virtual machine that's assigned to us, and so I've already launched it, and it opened in split view. So if I go up here and I do show split view, we'll see this thing, but I'm super zoomed in, so I'm gonna kind of expand that in a new window. I'm gonna shrink this back down, and then I have to zoom out when we actually start using the machine, because even the machine itself is gonna be super zoomed in. So we just want to go ahead and make sure that we have all of that set up. And this would be the moment that if you haven't downloaded WireShark already, to go ahead and download it. If you want to download Kali Linux for free, it comes pre-installed with WireShark. So there are a bunch of different ways that you can access this specific tool. And I do encourage you to do that. So if you haven't done it already, pause the video, go ahead and set it up so that you can follow along with the rest of this exercise. You can always obviously just register for TryHackMe as well and get access to their WireShark rooms as well. Do not directly interact with any of the domains and IP addresses in this room. Keep that piece in mind because a lot of them are actually malicious domains and IP addresses, so you do not want to interact with them. This is meant to be done in a secure environment, which is also known as a sandbox environment, which is what it means to actually be inside of a virtual machine like this. Again, this is like super zoomed in, so this isn't what it's going to look like by the end of this when I actually zoom out. But yeah, that's pretty much it. So that's it for our introduction. So let's talk about Nmap scans, detecting and investigating Nmap scans. Okay, this is one of the longer sections. So if you are not familiar with Nmap, my recommendation would be to actually go and watch the Nmap videos from this series. I mean, I have dozens of videos on this channel that we use Nmap through, and I would really recommend that you do that because I'm not going to spend a lot of time explaining the granular details of Nmap in general. There are specific things that we need to know about Nmap to be able to detect these kinds of scans inside of WireShark. So for example, just in case you don't know, Nmap stands for Network Mapper, and it's an industry standard tool for mapping networks, identifying live hosts, discovering services within those hosts, and essentially scanning IP addresses or domain names, finding open ports and the services running on those open ports, so that we can use this information as reconnaissance, as intel gathering, to be able to develop exploits and hack into the system, right? So it helps us, it's used in multiple contexts. Mainly it's used for network discovery. So when somebody, as a network engineer, if somebody's trying to find out all the variable IP addresses or available IP addresses inside of a network and all the open ports and all of that, they would do that, right? But we can also use it for security and pen testing, because on a defensive side, if you find a bunch of open IPs or open ports that aren't being used, you want to shut those down, right? On the pen testing side, if you want to find something to hack, you want to look at all the different open IPs and open ports and see which one that would be the easiest one to hack into, so you can gain access to the network. So it's one of the most used network scanners, and a security analyst should identify the network patterns that are created with it, right? So from the perspective of security scanning, this is what we're looking for, are the network patterns. So the most common types of scans are the TCP connect scans, SYN scans, and UDP scans. And we need to understand how Nmap works to, how Nmap scans, so that we can spot any kind of activity on the network. It's impossible to understand this without actually using the correct filters, so these are the filters. So TCP flags in a nutshell, and this is a very kind of like a generic overview, okay? This is not meant to be all-inclusive, so my recommendation would be to study the Nmap videos at least, and if you really want to take it a step further, go study the Network Plus playlist. So as a global level, right, the kind of like the most basic, generic, foundational types of scans that are available inside of Nmap are the TCP scans and the UDP scans, okay? Without really having to do anything, if you just do Nmap and then you give it an IP address, it's going to try to do a full TCP connect scan. And the WireShark filters would be TCP and UDP. When you look at WireShark packets, you'll actually be able to see TCP, Transmission Control Protocol, or UDP, the User Datagram Protocol. So you'll be able to see that inside of the packet. If you only use the SYN flag inside of Nmap, right? If you do lowercase s, uppercase s with the IP address, what that means is that there's going to be tcp.flags equals 2 or tcp.flags.syn equals 1. That's what it would look like if you wanted to do a search for only SYN scans, or if you were looking at the flags that are on a packet inside of WireShark and then you see the flags set, then you would be like, okay, well, this was probably a SYN scan. If there was only an acknowledgement flag that was set, the ACK flag, the rest of the bits are not important. The rest of the bits most likely are not set. So that would be tcp.flags equals 16 or tcp.flags.ack equals 1. Only SYN and acknowledgement are set. So SYN and acknowledgement flags are set. The rest of them are unimportant. So tcp.flags equals 18. Or it would be tcp.flags.syn equals 1 and flags ACK equals 1. So I'm sure you can kind of start noticing the patterns with these things, right? It's a little bit less obvious to notice the patterns with the tcp.flags one, because there are specific values that are assigned to it. So that part is a little bit difficult. But if you're looking for a specific flag within those TCP options, then you would just do tcp.flags. Whatever that flag is, and then just do equal 1 so that it is set. And then only RST flag, and then again you can see right here TCP flags.reset equals 1. Only RST and ACK, so again similar pattern. These things are going to be very repetitive as you start noticing the patterns here. And then the fin flag is set, so you can see that tcp.flags.fin equals 1. So for example, if you wanted to see if the fin flag and the ACK flag and the RST flag was set, you would do tcp.flags.reset equals 1 and .ack equals 1 and .fin equals 1, right? So you would do 3 filters essentially, and it would scan, or it would look through the packets the way that you wanted it to. Now TCP connect scans, this is like the most generic scan that is done with Nmap. If you literally just do Nmap and then give it an IP address, by default it's going to do a TCP connect scan. So this relies on the three-way handshake, also known as the TCP handshake. but it's basically a connection handshake. And we need to understand what that really means and what the implications are. And then once you really understand it, you can actually see how powerful WireShark would be for these kinds of use cases. So it relies on the three-way handshake, which means that the handshake needs to actually finish in order for the connection to be established. It's usually conducted with Nmap -ST or just Nmap, just by itself, and then it will do a connection scan. Used by non-privileged users. So if you wanted to do a SYN scan, for example, just a SYN scan, like the one that we have right here, if you want to do that with Nmap, you actually have to have sudo privileges or root privileges. So non-privileged users can only do a connect scan. Usually has a window size larger than 1,000 bytes as the request expects some data due to the nature of the protocol. So here's what this means, okay? So we send a SYN packet first. So you'll see a line item inside of the WireShark traffic for the SYN packet. And then we will receive that synchronization has been acknowledged, and then we'll send an acknowledgement packet. And if the last packet is actually sent successfully, then the TCP connection is established. And if that has actually been done, then we can assume that that TCP port is open. This is another one, SYN acknowledgement, and then a reset acknowledgement at the end to destroy the connection, to disconnect from that port. But as long as this is done, then we can say that the TCP port is open. A closed TCP port would be that we send a SYN request, a synchronization request, and we get a reset and an acknowledgement. So it basically says, I acknowledge your request, but I want you to reset because I don't want to connect back to you. And so if that's the case, that means that the port is closed, right? So these are the data that we're looking for inside of WireShark packets to see whether or not a port is open or a port is closed. And of course, Nmap would just display it on our screen for us as we go ahead and do it. It would display it in the terminal. But if you're looking at WireShark traffic specifically, then you're looking for these flags inside of the packets. So here's what we can see right here. This is the open TCP port. So as you can see on the right-hand side inside of these packets, I'll zoom in as soon as my keyboard decides to reconnect here. Here we go. So we have the three sets of, or four. We have four packets, right? So this is the source port, and then destination port. And then so this, again, right here, we have the source IP, destination IP. Then the destination IP is right here now because it's responding to us. And then we are responding back to it, and then we'll respond to it again, right? So if we go look at the ports, we can see that our port is trying to connect to Secure Shell. Secure Shell responds, and then we respond back to Secure Shell on the last two lines. And then you can see the flags. Our port is saying, hey, I want to synchronize. Secure Shell says, okay, I acknowledge your synchronization. Then we say, all right, cool, I acknowledge your acknowledgement. And now I'm going to also just send the reset because I want to disconnect from you because I don't want to have a full connection established with this. And that's it. So when you see this, even if the last line wasn't available and we just saw these top three lines, that means that the port 22 is open. So we try to connect from this port to port 22, port 22 responds, and then we respond to it. And that final response, as long as that's actually delivered, then we have that TCP connection established. This is what we call a loud connection, right? So if it was only a SYN scan, right? If it was only a SYN packet that we sent, then it would just be this one line. The last three lines wouldn't be available. Now, that tends to be quieter, quote unquote, right? Because this right here, you can see a full connection established. We can detect this very easily because hey, there was a full connection established. That's very, very easy to detect. So it tends to be loud in the logs. So what happens though, as a result of this full connection, we can retrieve a lot of data from port 22. For example, the version of the Secure Shell that's running would most likely be very reliable because we actually were able to connect and we were able to establish a connection, If we just sent the SYN scan, it might respond and it might say, hey, yeah, there is this port open that's over here. And we think, right, Nmap would say, I think that this is the version of Secure Shell that's running on this port, but we can't really rely on it because you can kind of rely. It's just that it's not the most reliance the way that you would get from a TCP connect scan. So you would just get this one packet that's been sent. The port would most likely, if it's not automatically responding with a reset acknowledgement, then we're like, oh, okay, cool. So it's probably open and it's not behind a firewall. So we can guesstimate, we can speculate that it is an open port. It just so happens that we don't get all the detail that we want. So a SYN scan is faster, it's quieter, but it's not as reliable with the data that we retrieve. A TCP connect scan is louder, it's slower because we're waiting for all of these packets to also go traded back and forth. But then at the same time, the data that we receive is more reliable than a SYN scan. If we're looking at the type of activity that implies that the port is closed, so again, we're trying to connect to port FTP right here, and then we can see that we sent the SYN packet to it, and then it responded back to us with reset acknowledgement. So that implies that it's actually closed. This is in an isolated traffic environment, so it's not always easy to spot given patterns in big capture files, because there's going to be thousands of lines that you're going to be looking at, and to try to spot these in those thousands of lines, it's very, very difficult. So when they say that this is an isolated traffic, it's like there's only 4 lines that's been, and it doesn't even have a display filter, right? So there's no display filter here. After those 4 lines, that's all we got. So most likely what they did is that they just exported these specific lines and created one little PCAP file just to show that we have an open port, and then this one just to show we have a closed port. So when you're looking at a real capture file, you need to use a generic filter to view the initial anomaly patterns, and then it will be easier to focus on the traffic point, and then the scan patterns in a capture file will be easier. So this is the flags that we will be looking for to see if we actually have a specific connect scan. So TCP flag.syn equals 1, so the SYN flag is set. Acknowledgement equals 0, so that means that it's not set. And TCP window size is greater than 1024. So when you look at that, and this is the filter that we have now here, you can see that that's the filter that they input. And then from here, we have all these different things that are available. So you can see these are all just synchronization requests that have been made, because what? We have the SYN flag is set, acknowledgement flag is not set. So we're just looking for packets that only have the SYN flag. So you can see that it's coming from just these randomized ports, and it's going to very specific ports that are actually used in a lot of environments. These are like default ports that have been set for a lot of different things. 443 is HTTPS, this is Secure Shell, FTP, I think this is POP3, etc. I haven't memorized all of these ports, so I'm not even going to pretend to know that we know what they all are, but that's basically what that looks like. Now, the SYN scan, right? So it's done with the lowercase s, uppercase s. This does not rely on the 3-way handshake, so we don't need to complete the 3-way handshake. It's used by a privileged user because they need to have root privileges. And the size is typically less than or equal to 1024 bytes. And again, it's not finished. It's not expected to finish, nor is it expected to receive data. The estimation that Nmap makes when it actually gives us data on the screen that's exactly what it's an estimation. It's a guess. It's like a very educated guess that Nmap is giving us. So this is what it looks like. If you have an open TCP port, you send the SYN scan or you send the SYN packet, the system responds with a SYN acknowledgement, and then we respond with a reset. So we don't do the final acknowledgement because we don't want to establish that official connection. Or if we get a SYN sent out and an RST and acknowledgement is sent back, that means that the port is closed. So this is what we're looking at here, right? So again, the port is sending it, or our port is sending it to Secure Shell. Secure Shell says, okay, I acknowledge. And then we say, no, never mind. I don't want to establish the full connection. I just want to make sure that you acknowledge. And if it acknowledges, that means it's open. If it doesn't acknowledge, if it just sends reset, then we know that it's closed, right? As far as the filters that you can use to display this, it would be the flag SYN equals 1. So flag SYN is set, acknowledgement is not set. But now the key element here is that the TCP window size is less than or equal to 1024, whereas the previous one was greater than 1024. So if we go over here, we can now see that we have, again, all the SYN. These are all the SYN packets, synchronization packets that have been sent. The window size is 1024, and then I didn't pay attention to that when we were up here, but if we were to look at that, you can see that the window size is actually much larger than 1024, right? And the TCP window size is exactly the flag that we're trying to filter down just to see what that looks like. UDP scans, in a nutshell, these do not require a handshake process because UDP ports are typically the ports that are used for things like streaming. With streaming, and a lot of times you might even be watching this video right now, and towards the beginning maybe it was pixelated, or at certain times it could be pixelated. That means that you're not receiving all of the visual data for the video, and that's one of the key elements of UDP. UDP doesn't require the establishment of that connection because it's just going to be streaming a lot of data to you, and that needs speed. It needs speed more than it does the full connection and the slowness of that connection. So you would have a full connection to YouTube, but the video would be presented to you via UDP protocol because that data needs to be sent faster. And so you'll have a full TCP connection to YouTube itself, the YouTube servers, but then you're going to be receiving the data via a UDP port. There's no prompt available for open ports. ICMP error messages are typically what we can expect to get closed ports, and it's done with the SU option inside of Nmap. So open UDP port, there's literally a UDP packet that's sent and we don't get any kind of a response. If there's a closed UDP port, then we'll send a UDP packet, but then you get an ICMP type 3, code message 3, saying that the destination port is unreachable, and that's how we can determine that the port itself is closed. So closed port 69 and open port 68 is what we can see right here. So 69, we sent the request to it, and we got an ICMP response saying it's not reachable, so that means that that port is actually closed. And then we just sent a request to port 68. We didn't get any kind of a response. So just based on that, we can determine that the port is open. The closed ports return ICMP packets. No further information is provided. So can the analyst decide where this error message belongs? The ICMP error message uses the original request as encapsulated data to show the source reason of the packet. Once you expand the section in the packet, you'll see the encapsulated data and the original request as shown here. So they clicked on the ICMP packet, and then we went down here and we looked at the actual packet details, and then we can see if we go and actually click on this user datagram protocol portion, then we can probably pull more information about it. This specific filter shows the UDP scans in a capture file. So ICMP.type equals 3 and .code equals 3. These are all the destination unreachable responses that we got. And we can't see the ports really, so we can just say that based on these specific responses, there were UDP ports that were closed, but you can always just click on the packet individually itself, and then you can see, okay, well, the destination port on this one, port 69, is the one that responded with being closed. So if I click on one of these and go look at the packet details, we can see which destination port it was that responded unreachable. Detecting suspicious activities in chunked files is easy and a great way to focus on details. So now we're going to use the exercise PCAP file to put our skills into practice against a single capture file and answer these questions below. So wonderful. We get to now officially use the information. So I'm going to zoom out here and we're going to go and look at our, very good, our computer or our virtual machine. I'm just going to open up WireShark, and then in this folder right here would be the exercise PCAP files. So let's move WireShark to the side here, and okay, so instead of doing that, I'm just going to go to file, I'm going to go to open, and then from here this is not the bonus exercise that I'm interested in. I want to find the specific file that has, there we go, desktop, and then exercise PCAPs. Where is it? Oh, exercise PCAP, there you go. And then from here, we want the exercise. Where's the exercise file? It told me there was an exercise file. Am I missing it? Let me see. Desktop, exercise PCAPs, Nmap, exercise PCAP. Okay, there we go. So Nmap, there we go. Exercise PCAP, got it. Perfect, there it is. All right, so this is the one that we're going to be using to do our investigation to answer these questions. So the first question is, what is the total number of TCP Connect scans? So TCP Connect scans, if we just go up here, we can go ahead and determine the type of filter that we can use for it, right? So for TCP Connect, we are looking for the SYN, SYN acknowledgement, and acknowledgement to be available to us, and we can just go ahead and find them with the various filters. I want to say the easiest way actually to do this would be to just search for TCP in the filter up here and just press enter. It'll show anything that has to do with the TCP protocol here. And so if I go down here, the displayed number out of 6544 packets, we have 4006 packets that are available for TCP Connect scans. So we're just going to try 4006. Let's see if that's actually right. And it's not. Okay, so TCP Connect is what we're looking for. So I was trying to see if that was the easy way to get the answer, but it's not, clearly. So let's go ahead and find it. Okay, so the hint was, or well, really not a hint, but we actually did get it in our exercise here where it says the given filter shows the TCP Connect scan patterns. So really all we're looking for is the TCP flag scan, flag SYN is set, acknowledgement is not, and a window size is just greater than 1024. So that's basically the element that we're looking for here. So we're just going to go over here, and I want to see if I can just paste it. I can't. Can I paste it? I don't think I can. And it just froze on me. So what's going on? The screen is just losing its mind right now. All right, I think I have to manually type it in here. So TCP, TCP, I already forgot. Flags SYN, that's what I'm looking for. TCP flags SYN equals 1, and TCP flags ACK equals 0, and then we have the TCP window size, right? TCP window, window size is with a thing, and it's going to be greater than 1024. There we go. The number of packets displayed are 1000. Perfect. That seems to be a little bit more useful. Excellent. Nice. Which scan type is used to scan the TCP port 80? And so I guess we're doing Nmap specifically. Is that what they're asking? So if I do ST and then I do port equals 80. No, okay. What is it asking me then? That's weird. It's kind of like a weird way to question it. So which scan type is used to scan the TCP port 80? Oh, dude. Oh my God. Wow. It's a lot of times it's so much simpler than I think it is. How many UDP close port messages are there? So we're looking for the one where it says destination unreachable. So we're doing ICMP type equals 3 and ICMP code equals 3. So we're going to go over here, going to delete that to reset everything. And then so we're looking for ICMP like this. Is it typing? There we go. ICMP.type equals 3 and ICMP.code equals 3. And we press enter. There we go. All the destination unreachables. And the display is 1083. So 1083 ports are there. Okay. And which UDP port in the 55 to 70 port range is open? Okay. So we're looking for an UDP port, which would be the open port. Do we have it? I don't think we do. So the one that we're looking for is basically the ICMP type is not 3, right? Hold on. Okay, so this question is actually something that we covered in the last episode, which is how to find a range of ports. So there's like basically the searching of the squiggly, or like the squiggly whatever, the squiggly bracket. So we're looking for UDP port, right? And then we're looking for, if my computer decides to cooperate, we're looking for UDP port in, and then we're going to do the squiggly right here. And it's 55.70. So that's basically saying I'm searching for a UDP port in that range, which will then give us all of those right here. Okay, cool. So the question is now asking what? which UDP port is open in that range. So if we go over here, this one was unreachable, right? Destination unreachable. So if we were to look at it, we can see the port itself. So if I click on the unreachable one and then look at the destination ports, so let's go ahead and expand this. Destination port is 67, so that's not open. So 67, that one came back. 69 is also probably not open, right? 69, there we go. We see that right here. So the only one that didn't have a bad response was port 68, because you can see that the UDP data was sent to it and it didn't respond with the unreachable. So it has to be port 68. Cool, very good, nicely done. So now we can move on to the ARP poisoning and man in the middle. All right, for a man in the middle attack to work, one of two things basically needs to happen. Either an IP address needs to be inserted in the middle of a traffic transaction, or a MAC address would be inserted in the middle of a traffic transaction. And basically that MAC address or IP address would be the person, the man in the middle that is intercepting, potentially poisoning our traffic. So address resolution protocol, also known as the ARP protocol, is the technology that would be allowing devices to identify themselves, and they do it through a MAC address. Okay, so IP to MAC address table is what you would see if you're analyzing a network table, or an address table, we should say, where it says, okay, you know, this MAC address belonging to this specific laptop belongs to this IP address, or vice versa, right? This IP address belongs to that MAC address, and then that MAC address represents a laptop, and then this other MAC address represents the server, this MAC address represents a cell phone, so on and so forth. And then when those devices, when their physical addresses, their physical identifiers being their MAC addresses, when those physical identifiers connect to a network, they get an IP address. So what happens is when there is a man-in-the-middle attack or an ARP spoofing attack, this involves a network jamming or manipulating by sending malicious ARP packets to the default gateway. The default gateway is your internet router. So in your house, you have a router. It connects you to your internet service provider, AT&T, Cox, whatever, right? So your default gateway connects you to the internet. Think about it like that, right? It's the gateway of you entering the internet. That default gateway is what assigns the IP addresses, or I should say it like this. The subnet, the address of your default gateway is the same subnet that is the address of your all the devices in your network. I think the easiest way would be to show you like this. So let me see if I can kind of pull this up real quick. Okay, cool. So this is what it looks like. So first and foremost, the subnet that I have chosen is the basic subnet that would be inside of any home, which is this version, what you see right here. So the first three numbers right here represent the first three octets, meaning they each have 8 bits. So 3 times 8 would be 24. So in this subnet, we're saying that we want 24 bits to be accounted for, and then the last one is left at 0. That's the one that we're going to start with, right? That's the one that we're going to, or that's the one that we're going to fill in. So if we go up here, then you'll see like this, and I chose this version, but technically it would actually be 2, because the very first one, that's with the number 1 at the very end of it, that would be the gateway address that's assigned to your router. And then the very last one, or again, not the last one itself, but 255 right here is typically the broadcast address. So the network address in this particular case would be 0. It could be 1 as well. I've seen it usually be 1, but the network address is the gateway address. And then the broadcast address is the 255 that you see right here. That means that's what's broadcasting data. So data that's leaving, it's going to be leaving from that address. And then the usable range would be anything from 1 to 254. So you get a 254 amount of devices, right? So 254 potential hosts can connect to your specific network at a given time, or they could be 254 addresses issued at a given time. Total number would be 256, but there's only 254 that is usable. If you were to look at it in a binary, this is 8 bits, right? So 8 ones, 8 ones, 8 ones, and then 8 zeros, leaving off that last set that we could actually fill in. So this is what it looks like, right? This is a basic network inside of a home. This is what it looks like. So connecting it back to this, the default gateway is the one, that very first one right here, right? So what happens here is that there's an attack that involves some kind of packets that are sent to your default gateway, and they typically would have a fake address resolution protocol address, so a fake MAC address. So the ultimate aim is to manipulate the IP to MAC address table and sniff the traffic of the target host. That's basically the goal here for whoever is going to be capturing the traffic. I went into way too much of an explanation in this first paragraph, because there's going to be more information that we can use for this. So there are a variety of tools to conduct ARP attacks. A lot of these things are pre-coded, pre-written, and ready for you to use, and a lot of them are free. And the mindset of the attack is static, so it's easy to detect such an attack by knowing the ARP protocol and the WireShark skills that would be necessary. So ARP analysis in a nutshell: it works on your local network. It enables communication between MAC addresses. It's not a secure protocol. It's not a routable protocol. It doesn't have an authentication function, and common patterns are request and response, announcement, and gratuitous packets. Before investigating, we can look at some legitimate and suspicious ARP packets so we can kind of see the difference. The legit requests should be similar to each other. Broadcast request that asks if anybody's available and the host and IP address, and a reply from the host that says the particular IP address is actually used. So, the host will say, like my computer will say, hey, who has this IP address? And then it goes and refers to this table, this IP address table right here. And then it says, oh, this MAC address hosts this IP address. And then it'll respond back to me. That's basically what it is. So the global search would be ARP, and then the options that we have here. So opcode 1 is the ARP request. Opcode 2 is the response, as you can see right here. And then hunt, ARP scanning, possible ARP poisoning detection. So what you can see right here, so we have the destination MAC right here. That's what it could be. Usually that's not what it looks like. It's like a variety of alphanumeric characters, but that's what it kind of, the format looks like that. ARP duplicate address detected, or ARP duplicate address frame, and then the possible ARP flooding. So you're looking for ARP and the ARP code 1, and the ARP source MAC address would be the target MAC address. So you would use that as a full query. So just to kind of demonstrate this a little bit easier. So ARP protocol, right? So we see this on the right hand side. So it says the source MAC address, this thing right here. The destination, if it's like this, that means we don't know who the destination MAC address is. So it's sending it to every device in the network, and it's saying, hey, who has this IP address? Tell this IP address. And so the 125 at the end right here belongs to the source. So it's saying who has this, tell that IP. And so the response would be, yeah, 192.168 is at that IP, at that MAC address. And then now we can see that that MAC address is now filled in. So the destination here that's blank is now filled in. And now the response is, yeah, this belongs to that specific MAC address. So that's what that looks like. And then you can always look at that in the address resolution protocol details down here as well. So the sender MAC address is this, sender IP address is that, target MAC address is blank because we don't know what the MAC address is yet, and the target IP address is that IP. So we're just saying, hey, what device is connected to that IP address? The reply would then say, yeah, this is me. So this is the sender's MAC address now, because this was the one that was blank, and it belongs to the IP address that we targeted. And so it's saying, hey, that's me, that's my MAC address, right? Or that's my IP address, right? The MAC address is saying, yeah, that's my IP address. So the machine is basically saying, yeah, that's me, that's the IP address assigned to me. So the suspicious situation means that there are two different ARP responses. So there's a conflict for a particular IP address. In that case, WireShark Expert Info tab warns the analyst. However, it only shows the second occurrence of the duplicate value to highlight the conflict. Therefore, identifying the malicious packet from the legitimate one is the analyst's challenge. A possible IP spoofing could look like this. So same thing, right? So we went and said, hey, who has this IP address? Tell me. And then there's two responses from the IP, and they have two different MAC addresses. So there are two machines raising its hand and saying, yeah, that's me. That's my IP address. And now it's up to you to be like, well, that's kind of impossible. It can't be possible for the same IP address to be on two different MAC addresses. So one of you is an imposter. So knowing the network architecture and inspecting the traffic for a specific time can help the anomaly. You should take notes of the findings before going further. This will help you organize and make it easier to correlate further findings. So look at the given picture. There's a conflict. The MAC address ends, crafted an ARP request saying that that's me. That this is it, the one ending in B4 says that, yeah, I'm the one with the IP of 1.1. So possible IP address match, one matched from one specific MAC address, this one right here. That seems to be the legitimate one. The spoofing is saying that MAC 1 and MAC 2 are both saying, yeah, that's me. And it's like, well, that's not possible. So the ARP flooding attempt could potentially be this guy right here, the second one, saying that, yeah, I think that's me. Or that this is me. And now it's up to us to be like, okay, well, we have to determine which one of these guys is actually correct, which is essentially the challenge that is presented to us. So now we need to inspect the traffic to spot any other anomalies. So we can see right here where we have the source MAC address, right? The one ending in B4, the one that we think is malicious, is replying to a bunch of empty ones, as it seems. And the question that it's asking is, who has that IP address tell 125? I think that's the legitimate one, right? So the B4 is the legitimate one. Yeah, the B4 is the legitimate one. So the B4 is the one that's communicating with the rest of the network saying who has this, who has this, who has this, and tell the IP that's ending in 125, right? And then in the first response immediately, there was the IP address 1.1 saying that I'm at this MAC address at F4, and it's responding, and then the rest of them are being sent to all these other IP addresses on the network to try to connect and try to figure it out. So there needs to be, it's really not helping us much in this particular case, because it's saying that the case is split into multiple capture files to make the investigation easier. So I think that's probably what they're saying for our exercise. So it's evident that there's an anomaly. Security analysts can't ignore a flood of ARP requests, which is what you see right here. All these ARP requests coming in, you can't ignore that. This could be malicious activity, scan, or network problems. There's a new anomaly. The MAC address that ends with B4 crafted multiple ARP requests with the 125 IP address. So let's focus on the source. So possible IP address 1 announced from a MAC address, which is the B24, which I thought was the legit, but it might be bad, I guess. It might be like a bad address. And so, let's go and let's make sure that we renew our machine so it doesn't kick us out, because that is really annoying if it does. So let me go up here and add an hour. I stepped away from my computer for a bit, so the timer kind of tripped out on me. And so let's go back here. So where were we? We were over here. No, we were over here. So possible IP address saying, the IP address announced from a MAC address from, 1.25 is saying that it's from B4 MAC. Possible ARP spoofing. 2 MAC addresses claim the same IP address of 1.1 at the end. And these were the 2 MAC addresses, B4 and F4. So MAC address 2, B4, is actually this one. So it's literally the same one that's also claiming to be at 1.25. It's also claiming to be at 1.1. And then MAC address 1 replying is the one with F4. So the MAC address that ends with B4 claims to have a different and new IP address. So now it's saying that I'm at 1.1, when originally it was the one saying that it's at 1.25. And the MAC address that ends with B4 crafted multiple ARP requests against a range of IP addresses, which what we saw was that possible ARP flooding attempt. So it's evident that the MAC address that ends with B4 owns the 125 IP and crafted suspicious ARP requests against a range of IPs. It's also claiming to have possible gateway addresses as well, so we can look at other protocols to spot the reflection of this. So we'll go right here and look at the HTTP protocol. So it's that 1.25 is not even in this list. So it's saying, what is it saying? It's saying, the 1.12 going to this IP address is making a request to get the login page. And then that IP address is now responding with a continuation. And so 1.12 is now saying get style and get images and all those things as well. And then the 493 is responding with continuation. So this traffic, everything looks normal. So there's no linked information with the previous findings. So let's add the MAC address in the column. So if we go over here now, and if we look at the 112, and then going and looking at these, and so the F4 IP address or the F4 MAC address is the one that we saw previously. And then this one, look at this, the MAC address is all going to the B4. Even though the destination is two different IP addresses, technically, the destination on this is the same MAC address. And so it's saying, or it's getting as a response, all of the stuff from the website. So the MAC address that ends with B4 is the destination of all the HTTP packets. It's evident that there's a man in the middle. So all of these packets, no matter what is the interaction between the IP addresses, all of those packets are being sent to this, and this person is intercepting all of those things. So all the traffic that's linked to 1.12 is forwarded to the malicious host. So let's summarize our findings. So IP to MAC matches. So 3 IP addresses are matching to this one MAC address, it seems, or I should say 3 IP to MAC address matches. So there's three different ones. My apologies. So we have B4 ending in 1.25. F4 is ending in 1.1. And then A8 is ending in 1.12. The attacker created the noise with the ARP packets. So the B4 MAC address is connecting to 1.25. That's the one that did all of the ARP attempts, the ARP address requests. And then the router and the gateway, our MAC address, which is F4 in this case, responding and saying that it's 1.1, because remember we looked at the calculator, and typically, I know in this particular case it says 0, but typically this was my mistake because I actually went over here and I said that it was 1.1. So if I went and did 5, for example, in this particular case, the network address, it's still at 0, but really, if you actually go and do ifconfig or if you do ipconfig on your computer, you should get a response of, the one that ends with .1 should be your gateway address. It should be your router's address. The attacker sniffed all the traffic of our victim, which happens to be in this particular case 1.12 and F4 being the router. So the router itself was the one that was sending all of these requests out to get those HTML, for the HTTP protocols to get website information, because somebody was using it, right? Some other IP address was interacting with a website and trying to get a login page, and from that login page the style sheet was brought and then images and the logo and everything was brought. So the login page was loading, but all of that was actually being sent to this specific MAC address right here, which is the one that is intercepting all of the traffic. So it seems like these are the sources that are actually requesting it, and that would be the case where it's like, well, these are the sources that should also be the ones that are receiving all of the data from this website. But when we look at the source MAC addresses and the destination MAC addresses, they don't line up. So this is where the requests are being made, but all of them are being sent to that intercepting MAC address. So detecting these bits and bits of information in big capture files is challenging. So in real life cases, you won't have tailored data ready for investigation. You need to have the analyst mindset, and we need to obviously use a variety of different tactics to filter traffic down. There are always alternative solutions. The solution type and approach depend on the analyst's knowledge and skill level. Detecting suspicious activities is what we're going to be doing. So we're going to go into the ARP folder now and pull the exercise file to be able to answer these questions. So let me go ahead and zoom back out here, and let's go into our computer. We are now in this location, so we can just kind of, I guess I can open, I don't know if it's going to open multiple instances, so I'm just going to close it, and I'm going to open the PCAP location. We're going to go into ARP, and then we're going to open up the exercise PCAP file. So we'll do it like that. So right now we have a total of 2,866 packets. So let's look at question number 1. It says, what is the number of ARP requests crafted by the attacker? So to be able to get ARP requests, we need to go ahead and pull up a specific filter. Since we're only interested in the ARP requests that are crafted by the attacker, we basically need to find all of the packets that are from this specific MAC address. And so if we open this file right here, we can see, so I'm going to remove this filter real quick. Basically what it looks like when you load the file in general is you'll have, why isn't this loading? So you'll have this, what it looks like at the very, very top. So we have SSDP protocol and an ARP resolution protocol. And then we have all these requests, right? Who has this, who has this, who has this. So we can see that the MAC address here doesn't look exactly like what we saw in the screenshots. But what we can do is we can right click on this specific portion and then apply it as a filter. And then it actually creates this port for us. So it says ethernet.source equals that specific MAC address. And so then once we do this, we can actually just see all of the requests being made by this specific MAC address. And there's a lot of them. So it says 1450 are displayed. These seem to be all of the requests made, but we have a 3-digit answer by this specific person, or I should say, for that specific question, we have a 3-digit answer. So that doesn't seem to be the response that we're looking for. Okay, so here's the glitch right here. So when I just do that Ethernet source, if I scroll all the way down, all of a sudden we see that there's a bunch of TCP packets, and there's a lot of different protocols that are presented to this that are not ARP protocols. So we're specifically looking for ARP protocols. So another way that we can filter this down a little bit would be to just say and ARP, to just make sure that the protocol itself is only ARP. Now in this case, if I scroll down, I should only see ARP protocols, and then we can see that they're sent to a variety of different MAC addresses, but it's all from that source. So what we're also trying to do is we need to go ahead and figure out it says the ARP request crafted by the attacker. It could technically be all of them, but there's also all these other ones that are sent to a variety of different addresses. So this can be the fact after the requests have already been done, and now it's actually communicating with a variety of different machines. So we can go ahead and apply the broadcast as a filter, which would end up being Ethernet destination equals the Fs. So if I do Ethernet dot source equals, so actually let's see if I can do it like this. This might be easier. So I'm going to cut this piece right here, and hopefully this will work better. So if I cut that, can I cut that? I don't think I can cut that. There you go, I cut it. Okay, perfect. So if I do this, if I go ahead and use this as a filter, and then we can say and ethernet.dst equals the Fs right there. So the Fs right there, and we'll do ARP. So if we do that, we should get a shorter response. So we can see a bunch of these things right here. So it says displayed of 256. If I get rid of this, let's see what's there. It's also 256. Okay, let's try 256. Let's see if that's the answer. It is not the answer. Okay, so I think we're getting closer though. At least it's down to 3 digits. So let me see what else could be potentially the filter. So I went through this whole thing, and apparently the screen wasn't even recording, and I found out until I got to the end of the next section. So the end of this section is when I found out that the screen wasn't recording. So we're gonna go back and find all of these answers for you one more time, and then I'm gonna record the next section one more time. Unbelievable. Okay, so the answer for this is actually 284. Now, the way that we find that, I'm losing my mind right now. Okay, so the way that we find that is that we need to use a filter that was previously given to us at the very, very top right here to be able to find those addresses. So it's right here. So we're looking for this. Instead of doing the Ethernet destination or Ethernet source, we're actually looking for this version of the filter, which is that ARP DST HWMAC version. So we're going to go ahead and use that as the filter. And so hopefully I can paste it, which it seems like I can't. And let me just make sure that this is still recording, because now I'm super paranoid here. So it's basically ARP, right? DST.HWMAC. That's the one that we're looking for the zeros. So it'll be 0 like this, right? So that's that one. And then we're going to combine it with the other one. There we go. So now we have the actual packet that we're looking for, because it's basically the source is going to be the attacker, and then the destination is the network router that he's trying to communicate with. And then so now we get with 284 as the result that we have, which is our answer for that first question, right? So you're using the ARP.DST.HWMAC filter instead of the Ethernet.destination and source. And then it says, what is the number of packets received by the attacker? So in this case, we're looking at HTTP packets, right? So the destination now in this case, so now we can go and use the other filter, right? So let me see if I can actually do cut and paste in this version right here, at least. Hopefully we can do that. So in this case, the Ethernet destination, right, is going to be our attacker's MAC address, and we just want the HTTP protocol to show up just so we can see the number of packets for that. And so we can see down here that the number of packets that were received by that person are 90. So that's going to be answer number 2 right here, which is the number of packets received by the attacker. So making some decent progress here. Next question is, what is the number of sniffed username and password entries? And this one was actually a little bit tricky. So thankfully, I've already gone through it, so I can kind of guide you through that. So basically what we're looking for is, number 1, we want to actually see from all of these packets, right? So from all of these packets, we want to kind of see what potential page would give us some information. So if we scroll up here, there's a specific page called the userinfo.php page. And if we go to the packet details and look at the URL encoded portion of the packet, we'll see that there are 2 fields here. We have the uname and the password. So the username and the password. And so the uname is a key. The value would be the username or the password, right? So what we're looking for specifically is something called URL encoding. So one of the things that we want to do is we want to keep this specific filter here. So we actually want this to stay. So we're just going to put this inside of parentheses. And then we're going to add a specific element to it, which basically says and URL. And then you can see the autofill helps us here. So it's URL encoded form. And then if I do dot, I'll either get key or value. So I'm looking for a key, and the key needs to be the one that includes pass in it. So I'm looking for the one that actually has pass in it, because the uname is going to show up in a lot of different cases. So that narrows it down to just 6 packets, as we can see right here displayed. So now we have 6 packets, which ends up being the answer to this question. So now we just need to go through those 6 packets to find client 986's password. So I think it was this one. So there you go. So client 986, the password is client not here. So super simple and straightforward so far. And then the last question, this one took me longer than it should have. And it was basically because I was trying to find the comments of the entire packets, which can be done technically. There was a way that I knew that we could do it. But basically, there are 2 ways to look at comments in general, right? So you want to go to, I think it was statistics, or no, analyze. It was analyze, and then you're looking at expert information. And in here, there's usually comments somewhere. Like there's something that you can pull from the comments. And if I go and do client, for example, that's where it should be, but technically it's not there. So that's definitely not what we're looking for. So the way that I found it is I just went to edit and I did Control F or find. And then I'm looking for the packet details. Inside of the packet details, I'm just looking for client 354. That's basically the one that I want. So I'm going to click on find, and then it's going to find the packet for me. It's packet 2320. And if we go to the data in the packet details, we can see that client name client 3454 has a comment of nice work in it. So that way we were able to find the comment, and there we go. And that's the comment for that packet. So that's how we found all of those answers. Now I'm gonna redo the entire lecture portion of this next section. Okay, this should also be a little bit quicker and easier because I've already done the lecture, so I can kind of summarize most of this stuff for you. So identifying hosts is a very important skill set, and as you can kind of tell, we went from looking at the protocols, we looked at MAC addresses, IP addresses, all those things. So one of the key things that we want to do now is we want to actually find the host inside of an environment. So what's really cool about this, it's kind of like a pro and a con kind of a thing. It's a two sides to the coin, or like the edge of the sword, like double-edged sword, one of those things. So in an environment, in the enterprise environment, what happens is that companies usually will have some kind of a pattern, right? So it'll be something like, I don't know, NSB dash Hank Ackerson, something along those lines, where it's like there's a pattern, right? So it can make it easier to follow the inventory, but it can also make it a little bit difficult for us as analysts, because the attacker can now clone that pattern and then live in our network, because now they know what our patterns for usernames look like, for host names look like. So we need to be able to obviously avoid that, but we need to also be able to identify actual usernames by a variety of different protocols. So the first one is the DHCP protocol, Dynamic Host Configuration Protocol. Then we have Network Basic Input Output System, and then we have Kerberos. And all of these are used for host and user identification. So first, DHCP. DHCP is the protocol that allows IP addresses to dynamically be issued to the devices in your network. So instead of somebody sitting there and assigning IP addresses one by one to every computer that comes in, or every cell phone that comes in, imagine if you had to do that for everybody that tries to connect to the Wi-Fi in your house, right? So there's a protocol that automatically assigns IP addresses to the devices that connect to the router, to our network. DHCP or BootP would be the global search inside of WireShark. And then we have a few different ways that we can track these things down. So there are DHCP requests, acknowledgements, and NAC. And I want to say it's like not acknowledgement, or like maybe an error is what NAC would be. So DHCP option DHCP equals 3 is the option for request, and option 5 is for acknowledgements, and NAC, which is all the errors, would be option 6. Option 53 is the only one that actually has predefined static values. So we would, for all of our investigations, we would filter the packet type first, and then you filter the rest of it by applying a column and then using something like contains or matches, which we did a lot of in the last video, in the last episode. So for this, for example, so let's say DHCP request, right? So option 12 is the host name, 50 would be the requested IP, 51 would be the requested IP lease time, and then 61 would be the client MAC address. So if I wanted to do host name, for example, I can do host name contains, and then whatever the name of the keyword is that I think it would contain. For acknowledgement, similar, right? So option 15 is domain, 51 is assigned IP lease time. So option domain name contains keyword. And for non-acknowledgement, because it's error messages and there are really no like patterns, usually there are no patterns in error messages. So what we're really just going to look for is we're going to filter just for the denied, or for the errors, which in this case would be option 6. So DHCP option 6 would end up giving us all of the NAC packets, and then from there we can kind of read through or filter through the messages to try to find what we're looking for. So just as an example of what we're kind of trying to find is, if we go inside of if we search for DHCP protocol, as you can see right here, and then click on any of the packets, and we go to the packet details, we can see now the host name option, right? So DHCP message type, client identifier, and then option 12 right here has the host name, and then we can actually see the host name in there. So that's one way of identifying the hosts. The next one would be the Network Basic Input Output System, which is for allowing applications on different computers to communicate with each other. NBNS would be the global filter, and then we're looking for something like nbns.name contains the keyword, for example, and then we'll be able to find it. So NBNS, again, as the global filter, we click on any of these guys, and then we go down here, and then now we can see that the name for this Xerox machine right here is the conv_Xerox, for example. So if we're looking for, you know, NBNS name contains Xerox, we should hopefully be able to find, I guess, all the printers, maybe. That's probably what it would be. And then we have Kerberos analysis. So Kerberos is unique and native to Microsoft Windows, and it allows for service requests. I'm not going to go into the details of it. We've covered this a lot in different videos. So if you don't know it, it's basically to grant tickets for identification and then to grant tickets for access. That's what Kerberos is. It's like a ticket granting system. So we can search for Kerberos packets specifically by searching for Kerberos globally, and then looking at things like, you know, the CNAME string contains a keyword, or the CNAME string contains something, but I don't want it to contain a $sign because the $sign would be the host name, and I want to find usernames. So this is what we talked about in the last video as well. If you put a exclamation mark in front of your query right here, you're saying not this. So it's like, I want this, but I don't want these, is what that query is essentially saying. And Kerberos has a lot of different extensions to it. So if you just type Kerberos and then do a dot, which is what we did with the URL encoded thing, the autofill will help you out a lot with that. So for grabbing low-hanging fruit, we can do the protocol version, the domain name for the generated ticket, service and domain name for the generated ticket, addresses, things like that. So Kerberos.pvno equals 5, Kerberos.realm contains .org in it, Kerberos sname string contains KRBTG, something like that. So the addresses information is only available in request packets. Just keep that in mind. This piece right here, it's only available in request packets. So you would need to combine this with Kerberos requests, right? That's the piece that we would need to kind of hone in on if we're looking for that. This is an example. So if we do Kerberos as the global search, click on any of the packets, look at the details, we can see the CNAME, the name of the device in this case is, or the user, I think, in this case would be KRB5NT principal. So that's how we can filter those down. So now we can go ahead. Let me make sure I'm still recording. Okay, great. We're still recording. So now we can go ahead and zoom out and go ahead and launch our machine and use our exercise files. So in this case, we're looking for the NetBIOS Kerberos folder, and we're going to use DHCP NetBIOS for the questions 1 to 3, and then Kerberos PCAP we're going to use for questions 4 and 5. So let's go and find DHCP NetBIOS. Let me tell you, man, I was pretty upset that it was not recording, and I had to do that whole thing all over again. It wasn't as bad as what it was in my mind, but I was pretty pissed, let me tell you. All right, okay, so what is the MAC address of the host Galaxy A30? So we're looking for the host Galaxy A30, and it could be anything. So we could be looking for any type of protocol to search for that host name. So I'm going to do the cheat real quick. I'm looking for Galaxy A30. So I'm gonna just go here. I'm gonna do edit, and I'm gonna find a packet. And then let's see if the string contains Galaxy A30 in it. Let's see if we can find one specific to that and see if we can find the MAC address for it, because that would be pretty handy if we could actually do that. Okay, so there was nothing for that, so that shortcut didn't work. So we can use any of the filters that we had previously, right? So you can pretty much go through anything that you want from the list of filters that we got over here. So if we start from the top, if we're looking for a host name, for example, right? So DHCP request, the option is dhcp.option.hostname contains something like that. So if I go over there and I'm looking for a MAC address of Galaxy A30, I can do exactly that. I can do DHCP. Let me zoom in here just so you can kind of see what's going on, because this is also really, really handy if you do this, right? So if you actually do DHCP and then do dot, right? Now there's a bunch of stuff. And so we're going to do option, right? Dot H, and then boom, host name is right there. And then we're going to say it contains Galaxy A30. And let's see what we can find with this now. And let's see if that actually gives us something. Hopefully it does. Okay, so Galaxy A30 doesn't give me anything. So what if we do just Galaxy? So let's go do that. Contains Galaxy. Let's see if that gives me... Oh, wonderful. Look at that. So we got a couple right here. All right, fancy. So we are looking for, what is it? We're looking for the MAC address, right? The host that has Galaxy A30. So we can just go one by one to these guys. And I mean, the source for this one is the network router, and the destination seems to be the broadcast IP address. So that one's fine. So the third one might have some interesting info for us. So if we go over here and see if we can find option name, host name, wonderful. And host name is Anthony S Galaxy A30S. Okay, that's very detailed. So let's see if I can just type, oh, MAC address. MAC address is what I'm looking for. What am I doing, buddy? Okay, so client MAC address is what we're looking for here, which is the 9A81. So let's see if we can copy the MAC address. Let's see. Sweet. Okay, so it did copy the MAC address. I just wasn't sure. I usually just paste it into my browser just to make sure it actually worked. And so it did in this particular case. Wonderful. Okay, great. So question 2, it says, how many NetBIOS registration requests does the Livel JM workstation have? So we're looking for NetBIOS registration requests. So if we go to the NetBIOS filters, it basically has just one. So NBNS name. So we're looking for that. So we're going to go ahead and delete all of those right there, and we're going to do nbns.name contains livaljm, livaljm. Okay, so there we go. So we have this, and we're looking for a request, I guess. So let me see. What was the option for that? Is there an option for requests? Okay, after a quick little Google, we see right here nbns.opcode equals 5 is filtering for the NetBIOS registration request. So that's what I am most interested in. So I'm going to go ahead and do one of these things right here. So we're going to do a, what is it? Close parentheses, and then we're going to do an open parentheses at the beginning of it. And then we're going to go right here. And I got to keep double checking that the recording is going, because that really just, and okay, nbns dot, and if we could also do this as well, but I wouldn't know what to look for. So we have to do nbns dot opcode. Isn't that what it was? nbns dot opcode. What is it? nbns dot opcode. Yeah, nbns dot opcode equals 5. I thought that would, or maybe nbns. I see. Okay, so there we go. nbns flags.opcode equals 5. Also, so if you know, when you do research like this, it doesn't actually help you. So what you can do is you can go to, I want to say statistics, analyze display filter expression. So display filter expression will open up this window for you, okay? And then inside of this window, you can start looking for a number of different things. So for example, if I want to search for NBNS, then it will bring up NBNS for me on the list of filters. I can expand it, and now I have a bunch of stuff that's in here. And then so I could be looking for the flags opcode, right? So opcode is what I'm looking for specifically. So I could do that. I could type opcode, and then it'll bring up a bunch of things, because opcode is probably a variety of different things. So then you can go right here, right? So I selected opcode, and then it says is present, so it does equal, and then we're going right here. We're looking for request, I guess, registry, registration, wait for acknowledgement, refresh, etc. So it doesn't show me actually what the, I guess registration request would be the one that we're asking for. So it's not looking for request. We're looking for registration specifically. So anyways, we're looking for opcode 5 just to kind of speed that up. So opcode 5, and then we have livaljm also included in it. So the answer seems to be that there are 16 packets. Let's make sure we're still recording. Okay, great, we're still recording. So the answer is 16. Yes, excellent. So which host requested the IP address of 172 yada yada yada? So I'm gonna try to see if I can copy this. It never works when I try to do the copy. For whatever reason, I can't copy from here and paste it into WireShark, but whatever. Okay. So the question is what host requested the IP address? So we are looking for host requesting IP address would most likely be DHCP, so Dynamic Host Configuration Protocol. So DHCP option, and then what are we doing? Option request, right? Requested IP address. There we go. So option requested IP address. Excellent. And then we're going to do equals and moment of truth. Let's see if we can paste. We can't paste. Okay, so I will open this up. So 172.116.13.85. Okay, so there we go. So that's what it was, right? So it says which host requested that. And okay, we only have one. We have one packet that was filtered. So we can just go down here and try to find the host name to see what we can actually find for this here. And it's right there. So it's the host name option. Galaxy A12 would be the answer. Galaxy-A12. Perfect. And next one is what is the IP address of the user U5? Enter the address in defanged format. It doesn't really give us much to be able to find U5 IP address or U5 user. Wow. Okay, so I mean, there's a bunch of things we could do here. What's down here that we can try to find a username? So CNAME string contains the username. Okay, so let's try this one. Let's try this filter. Kerberos.CNAME string contains U5. That is so generic. It's 2 letters, man. Kerberos.CNAME string. There we go. And then it contains U5. Good Lord. There has to be like a bunch of them. It can't be a few. I can't imagine that it only has a few. And we're literally searching through 180,000 packets. That's the other thing that's kind of just like driving me insane. It's not working though. Nothing is loading. So this is an issue for us. So Kerberos CNAME string contains U5 isn't loading anything for me. Oh, it's because I'm looking in the wrong packet. Oh my gosh. Okay, so I need to go and load the other packet capture file because we're officially on question 4. Yeah. Oh my God. I would have spent so much time not realizing that I'm in the wrong thing. So let's close this out and let's go into the Kerberos one. Okay, so since we're in the Kerberos one, we definitely need to use Kerberos. So Kerberos.CNAME string, there we go. It's right there. Give it to me. CNAME string right there. That's the last one that I used. Contains U5. There we go. I was like, why isn't it loading anything for me? There's only 82 packets in this one for us to use too, so that should be pretty nice. Okay, so it says which one, what? It says which one, what is the IP address of the user with U5? So IP address of the user with U5. So let's see. Okay, really, there's only 2 IP addresses that are here for us to look at. Or yeah, 2 or 3. There are like 2 or 3 IP addresses for us to look at. The one that stands out the most is the one that ends in 1, because that is the one, in my opinion, that would be the router, the gateway. And so I believe that would be the one that would most likely be kind of requesting usernames, maybe. I think it's not, I don't know if it's the best logic, right? So anyways, we can see what we can find over here, because all of these things contain U5. That's the other issue, is that like all of their, most likely all of their usernames would contain U5, I would assume. So let's see what I can find here, because request body, there we go, and then the name would be Denny DC. Okay, no, actually, interestingly enough, it is not the case. Okay, so really the packet details, as far as I'm seeing, doesn't include anything that can actually help us with this. And instead of trying to guess, the only other way that I can think of is if we look at the hexadecimal point right here. So this is the binary, we have hexadecimal. We can see that U5 is in here. So among all of the gibberish, it seems to be that U5 is in there. So it would be, in my guess, 10.5.3.1. So let's go defang it real quick. So CyberChef, oh, I already have CyberChef saved on my toolbar. You should also be saving it. So we are going to defang something. So we're defanging IP address, and it's 10.531 basically. So 10.531. That's it. And the defanged version would be this. That's basically what that means. So we're going to copy that, and we're going to go over here. I'm going to paste it. Let's see if that's the answer. Why is it doing this? What the heck is this? Enter the defanged format. Literally, that's exactly what I did. I don't understand why you're doing this to me. Oh, yay, I found it. My God. Okay, so this is actually from 10.1.12.2. That's actually the one that has U5 in the CNAME value. And it's literally U5. There's nothing else attached to it. And it's Denny DC. So I think I was on the right path. It's just that I was looking at it instead of looking at the destination, I was looking at the source for this one. And it's actually supposed to be the destination. So 10.1.12.2, I think, is the IP address. I apologize for not having like more solid responses for you on these things, but I feel like that's the right one. Yeah, okay, great. All right, what is the host name of the available host in the Kerberos packets? So we are now looking for the last one right here. So the available host in the Kerberos packets. There should be a few different ways that we can do this. So essentially what we're looking for is this value. So where is it? It's this thing right here, this piece. We're looking for that specific value, this CNAME string, because that's the one that actually has the usernames in it. So what we can do technically, I think, because there's a way that we can apply these things as columns. So if I click on that, and if I apply as there you go, apply as column. And there we go. Now we have a uname string. So now we have the CNAME string, excuse me. So the CNAME string is now there. So if we get rid of our filters, and if we see which one actually has a value, so DSXP1 $, that seems to be the only one that actually has like a real value, because the rest of them are just BS really. So what was it? It was XP1 $. So XP1 $. Host name, especially because it has a $sign in it, right? So host name, there we go. Yeah, host name has a $sign in it. So we could have technically even done this, right? We could have even done this piece right here, where we could have gone right here where it says it doesn't include the $sign. We could have actually gone and just done that, because that actually says literally to avoid the $sign value that ends is a host name. So we're looking for a host name. So we could have just gone over here and we could have done the Kerberos, right? .cname, all of that. So that thing. Now, instead of it saying U5, we're just looking for the one that actually has a $sign in it. There you go. And that's the only one. That's the only one that actually has a $sign in it. Solid. Okay, excellent. Progress has been made. And let's make sure we're still recording. We are still recording. Fantastic. All right. Moving on to tunneling traffic, DNS, and ICMP. Okay, traffic tunneling is also known as port forwarding. So where you forward the traffic from one port to another, and you then create a digital tunnel when you do that. So it transfers the data and the resources in a secure method to network segments and zones, and it can be used for internet to private networks, So internet to private networks and private networks to internet. So this is the flow of the data. So either it's coming from the internet to our private network, or it's leaving our private network to go to the internet. There's an encapsulation process that hides the data, so the transfer data appears natural for the case, but it contains private data packets and transfers them to the final destination securely. This provides anonymity, it provides traffic security. Therefore, it is highly used by enterprise networks. However, as it gives a significant level of encryption, attackers use tunneling to bypass security perimeters using the standard and trusted protocols that are used every day, like ICMP or DNS. So for us to be able to have the ability to spot these types of anomalies is very important. So ICMP analysis, ICMP is Internet Control Message Protocol. It's designed for diagnosing and reporting network communication issues. It's used in error reporting and testing. It's a trusted network layer protocol because it's used a lot for regular network administration or network engineering. So sometimes it's actually used for DOS attacks, denial of service attacks. So adversaries also use it in data exfiltration and C2 tunneling activities. So this is one of those things that there's something called LOL binaries. It's separate from this, but it's similar in like the same spirit. So LOL binaries stands for living off the land binaries. And when somebody hacks into a machine, instead of downloading their exploits onto the machine or instead of coding something new, they use the binaries that already exist on that machine to do their work, to do their malicious activities. And because those binaries already exist on the machine, it's easy to kind of get them past the first layer of security or inexperienced eyes, like the eyes of somebody who doesn't have a lot of experience. So this is a similar concept where we're using a port or a protocol that's used regularly, and then it's going to be used for malicious activities. And this is what we're trying to keep an eye out for and really investigate. So in a nutshell, the tunneling, ICMP tunneling attacks are anomalies appearing or starting after a malware execution or vulnerability exploitation. So somebody uses the LOL binaries, executes an exploit, and then immediately after on the timeline, you see that, okay, there's now a amount of traffic that's leaving our network and there's data that's leaving the network. So as the ICMP packets can transfer an additional data payload, adversaries use this section to exfiltrate data and establish a C2 connection. It could be TCP, HTTP, SSH. As the protocol provides a great opportunity to carry extra data, it also has disadvantages, and most networks block custom packets or require admin privileges to create custom ICMP packets. A large amount of this type of traffic are indicators of ICMP tunneling, so the adversaries could create custom packets that match the regular packets, which is 64 bytes. So it's still cumbersome to detect these tunneling activities. However, a security analyst should know the normal and abnormal to spot anomaly and escalate for further analysis. So here are our filters. We have the global search for ICMP. You just put that into WireShark. Then the options for grabbing low-hanging fruit, it's the packet length, the destination address, and encapsulated protocol sign. So for example, data.len for length greater than 64 and ICMP as the global variable. So this is what you see right here when somebody actually uses that. And then so we can see the protocol is ICMP, the length is greater than 64. And then, it's basically replies and requests, because a lot of times it is just a ping that is gone through ICMP. But then when we kind of look at it a little bit further, we can see where it's going. So the destination address as to where it's going is crucial, right? So the one that is, I want to say the one that is making the request is the one that we need to worry about, because that's the remote location that's making the request, and then ours is sending the reply to him, or to them, I should say. So that is, this is the filter to be able to detect ICMP anomalies potentially, right? Then we have DNS analysis. So the domain name system is designed to translate or convert IP domain addresses to actual IP addresses. So this is another one of those things, right? So the domain name system, DNS, is used very regularly. It's known as the phone book of the internet. Your computer has it whenever you go to a website, and it's a very long process, so I'm not going to explain the whole thing, but let's say you're requesting to go to a website in your browser that you've never visited before. So the DNS system is responsible for going, sending out a query saying, hey, what's the IP address that is associated with this name? And then once it collects that, it keeps it in its cache, in its host file. And so what happens after that is, instead of it loading slower every single time you try to go to that website, it loads it immediately quickly, or not immediately quickly, that sounds redundant. It loads it quicker. It loads it quicker because now it's in its internal hosts file, right? It's in its internal address book, you can say. So this is the essential part of web services. It's commonly used and trusted and therefore often ignored. Due to that, adversaries use it in data exfiltration and C2 activities. So similar to the ICMP stuff, the anomalies appearing or starting after malware execution or exploitation, adversary creates or already has a domain address and configures it as a C2 channel. The malware or the commands that are executed after exploitation send DNS queries to that server. However, these queries are longer than the default DNS queries and crafted for subdomain addresses. These subdomain addresses are not actually addresses. They are encoded commands as shown below. So encodedcommands.maliciousdomain.com is typically what it looks like. And this portion right here is the very long element of it. So if we actually go to CyberChef real quick and do something like encoding. So if I do the base 64, so 2 base 64 is what I'm trying to do, right? So if I do that, now you can see this very short IP address is now turned into this very long thing. So if I do any kind of command right here, where we just are exporting files, right? We're exporting something out of our domain to somebody else's domain, out of our host into somebody else's domain. Whenever you do that, it actually sends the data. So I don't know, something like, touch file.txt, and then we'll do and echo etc hosts to file.txt, something like that, right? So let's say I create this file and then I echo the contents of the host file into the file.txt. Let's say that's what I want to do. You see now this is this long command, right? It's encoded. So to the naked eye, you have no idea what that is. And then from there, they put that at the beginning of this portion. So they put that right here, and then you just have the domain.com. And that's how they get their commands across. When this is routed to the server sends the actual malicious commands to the host, and the DNS queries are a natural part of networking activity, so these packets have the chance of not being detected, as we already talked about. So you should know how to investigate this. So the global search would be DNS. Options for low-hanging fruit would be the length of the query, anomalous and non-regular names in DNS addresses, long DNS addresses with encoded subdomains, known patterns like DNSCat and DNS2TCP, statistical analysis like the anomalous volume of DNS requests for a particular target. So not MDNS disables local link device queries, so that's something else to keep in mind. So if we look at this, right, DNS, which is the protocol, right, the global search here, contains DNSCat, right, because we know that DNSCat is one of these specific protocols or tools that is used to export data. DNS.query.name.length is greater than 15 and not MDNS, right? So disable the local link, the local devices, and then look for a query name that is greater than 15. And so now you can look at all of these long subdomain addresses, right? These long DNS names to see if there's anything that we can find. So DNS contains DNSCat is the search here. And if we go right here, you can see DNSCat dot, and then there's some kind of encoded element that's connected to it. So that is a dead giveaway, right? So just knowing about something like DNSCat or DNS2TCP can help you with investigations like this, but then you can obviously use any of these other patterns, these other low-hanging fruits as well. So detecting these things in chunked files is easy, but we need to use our exercise files to actually do some proper investigation. So we will be using the DNS ICMP and ICMP tunnel PCAP for question 1, and then using the DNS PCAP for question 2. And there's just 2 questions. And so I am doing this in day 2. So I had to stop recording yesterday. So I had to launch our instance one more time. And it is here. So we will now go ahead and find the first question here, which says use the PCAP file, investigate the anomalous packets. Which protocol is used in ICMP tunneling? So the first thing we got to do is load the file, and there it is. I loaded it. So this is the ICMP tunnel PCAP file. And so they're asking for the protocol that would be used in ICMP tunneling, right? It says, so which protocol is used in ICMP tunneling? And we can go up here and kind of just look at it a little bit. So it would be data length greater than 64 and ICMP, I guess, and try to figure out which protocol it would be. That might be kind of like a good starting point. Packet length, ICMP destination address, encapsulated protocol signs in the ICMP payload. So let's see what we can find and what query we can use to find it. Okay, so I did the same exact query, okay? And after sifting and sorting through some of these, when we get to, I think it's number 39, yeah, like around number 39 is when we start seeing the payload change. So I'm gonna kind of zoom in here just so you can see what's going on. So this is the payload, right? This is the typically the payload that we can try to sift and sort through, and most of it a lot of times is jargon, but then you can start seeing things that are recognizable. For example, SSH 2.0 open SSH, right? And if we keep going, there's another one, and then it starts actually getting longer, and then you can actually see more commands, and again SSH SHA-1. So there's definitely it seems to be that there is definitely requests being made for the connection itself. And usually when you establish a connection via SSH, it actually gives you the SHA-1 key for that, or the SHA-1 encrypted hash for that connection. And then you just keep going in and you see the rest of the stuff. So the protocol for these ICMP packets, and then I'm just going to keep clicking through the rest of them just to see if there's anything else that stands out. But for sure, the protocol for that would be, for that tunnel, would be the encrypted protocol of secure shell. So, but if you ever wanted to kind of see what is inside of these things, with the exception of the actual packets themselves. So if we go up here, let me see if I can go back to those SSH ones, because I think I clicked too many times. So if once I find it, so here we go. So this is one of the SSH ones. So if we go over there and try to see the contents of it, you'll see that you won't really be able to, like the data right here, that's basically it. Like this is all that's available inside of the data. If I go ahead and copy the value of this data and take it to CyberChef, right? We paste that right there. You can see that over there. And so now we would want from base 64 and then get rid of the to base 64 one. So if I close that, you can kind of see that there's maybe potentially something here, but it's still not really reading. So it's probably not base 64 encoded. So that's not going to work. And let's see if there is any other version of this that we can look into that might potentially be useful for us. Because it, at the very least, I think that value could potentially be something that's useful for us. But unfortunately, I don't know what kind of encoding was used to decode it. So it's not really helping much. But if you can, if you get lucky, or if you've seen this kind of encoding before, you might be able to see what potentially can happen. It actually doesn't look like base 64. I think it might be like maybe hexadecimal or something. But anyways, so if you can't notice it, right? If you can't figure it out, there we go. This seems a little bit more, yep, it is hexadecimal. So it's from hex is what we're trying to figure out. And then from here, you can actually see OpenSSH clearly, right? So this is the piece of it that we would need to go ahead and decrypt or decode to make sense of whatever the data is. So to take that piece and then to go over here and see the already decoded version of it, that's the hexadecimal decoded version of it, those are the ways that you can try to find some information. But that's basically what you would have to do, because for every single one of these, I would have to go and pull this data out of here, copy it, go to CyberChef, see if I can make any sense of it. So instead of doing that, I can just look at this little area and then see if there's anything already available for me that I can potentially kind of make sense of and decipher. So anyways, long story short of it, that is what we're looking for, and we're going to do SSH as the answer. For the next question, we're going to open up the DNS PCAP file, and then we're going to use that PCAP file to answer that question. And it says, investigate the anomalous packets. What is the suspicious main domain address that receives anomalous DNS queries? Enter the address in defanged format. So if I zoom out of this, look at the hint, it says, why does it go away so quickly? After filtering the packets, focus on the payload data in the packet byte section. You might need to use the tool. Same thing, I think, for this one, right? Filter anomalous packets, investigate packet decay. Security analyst should filter the packets, investigate it. Okay, fine. All right. Full screen mode, view full screen the VM. Look at the data bytes in the payload section is what they're telling us. Okay. So we are going to try to find that specific answer here, and let's see what we can come up with. Okay, so I mean, it makes it a little bit easier because I used the strategy that we did in the previous one of the previous questions. So literally on the very, very top right here, I just typed DNS. I didn't even do anything else. I just typed DNS, and then I went and opened the domain name system portion, went down to queries and opened these, and I right clicked on this portion and I did apply as column, right? So I could actually see all of the domain names for every single one of these packets. And so at first glance, based on what we know, right, we can see that this one right here, and I haven't even scrolled down, this one right here is this super long kind of query that's in here. So if we scroll down, we can see there's other ones right there. And if we scroll down to the side, we can see that, okay, why is this happening like this? It was showing me a little bit. There we go. I'll just kind of drag the bar down here. So if we scroll down, we can see that, you know, after that long portion, there's dataexfil.com. And then we come down here, and then it's also right here, dataexfil.com. And then if we just keep going, we'll see that it's dataexfil.com. So we see this, and they seem to be coming in sets of 2, and then they seem to be coming very consistently. So dataexfil.com, that's the only one that I can see that is even remotely relevant to what we're looking for. And so I will go ahead and defang that, and it feels like that would be the answer, because data exfiltration is like a really big hint just by itself. It's like data exfiltration. So dataexfil.com. And then, so that's the defanged version. I could have probably just done this real quickly, just typing out those square brackets. But so there we go, dataexfil.com. And there's the answer. So it doesn't, for me, it didn't require much of a complicated filter. So I just added the DNS global portion, and then I made sure that I could see all of the domains in the columns so that I could actually look at the domains. And first glance, it was like the very first one. I was like, oh, look at this. There's like a super long subdomain that's attached to this thing. I wonder what's at the end of it. And then there's the hint, big hint, dataexfil.com. So I was like, okay, that's probably the answer to the question. So if I was a much better analyst, well, or you could argue that I'm a really good analyst, that I thought of doing it that quickly. But if I was better at creating filters and all those things, maybe I would go ahead and find a bunch of stuff and do a bunch of different filtering things right here. DNS contains that and the length name or the length and all of those things. But I didn't need to. So that's basically what we got. I think probably one of the ones that would have been like really handy for us to use would have been this one, the query name length greater than 15. I think that could have been really useful, because then it could have given us like all of the longer domains and it would have gotten rid of most of the shorter domains. So that could have been kind of handy, and it would have given us these like super long ones. So let's just try that just for shits and giggles, you know what I mean? So query name length is greater than 15. Let me see what shows up here. Okay, so there you go. So that's also like a really good sign. But again, it's like you're kind of looking for these. So greater than 15 brings us the connectivity check Ubuntu and all these other guys. So maybe not greater than 15. What if we do greater than 20? See, there you go. That's a little bit better. So greater than 20 gives us very obvious data right here. So dataexfo.com, very obviously what it is that we're trying to look for. And then we can also do something like, if I do this and get rid of, so put that inside of parentheses and then do and then do an exclamation where it says not, and then we can say, what is it? The name does not contain. So DNS contains, and then I'll do things like, let's say, I think the wildcard character should work. So in address.arpa. Let's get rid of that, right? So if I can also get rid of all the elements that include that in address ARPA, let's see, it doesn't look like it would be working. Oh, hold on, let me put this closing. There we go, closing. Well, it still showed it. It still shows all the in address ARPAs. So maybe not, maybe that's not the one, but close enough, you know what I mean? At the very least, we can kind of get some decent responses using the length version of it, which is one of the filters that they told us to use anyways. So anyways, that's our answer. We can now move on to the Cleartext protocol analysis. Okay, so Cleartext protocols come in various shapes and sizes. The one that we're going to be looking at is FTP in this particular section, but there are a lot of different Cleartext protocols. So for example, Telnet is another one. HTTP without the S at the end, that's another one. And I think that's actually one of the ones that we're probably going to look at. Yeah, HTTP is the next one. So when you're looking at these Cleartext protocols, the goal is really if any of these ports are even open, if any of these protocols are even open, it's actually a really handy resource for us to investigate, because everything is in actual clear text. It's not encrypted, so you don't have to decrypt it. So when you look at the requests and the responses and all of that stuff, you're getting to see exactly the data that's being passed through without any encoding, any encryption or anything like that. So it actually can be very handy if the protocols are even open. So FTP is the file transfer protocol, and it's used for transferring files and sending commands back and forth, and the encrypted version of it is on port 22, which is secure shell. So that ends up being kind of like a really the updated version of everything. So for us, it's important to create statistics and results from the investigation process, and to be able to have the required network knowledge and tools and skills to accomplish this. So investigation for FTP would look something like this. We can probably find man-in-the-middle attacks. We can see credential stealing and unauthorized access. We can see phishing, malware planting, data exfiltration. All of those things can be done via the FTP protocol, because it is the file transfer protocol. You can transfer files very easily, so it's more focused on simplicity instead of security, which is why it's clear text and nothing is encrypted. So if you just want to find the FTP stuff, you can just type in FTP and you'll see everything for it. There's a lot of different options that are going to be available here. So the X1X series for information request responses, X2X is for connection messages, X3X would be authentication messages. 200 as a response code means that the command was successful, so we'll be looking for things like that. There's no value inside of this, so it literally just says that you can look for these types of hanging fruit. This one for the X1X series, oh, there we go. I think they break it down like this. So they give us all the options. I don't know why they did this, but they could have just done it easily over here. But so the X1X series for low hanging fruit, 211, 212, and 213 are the status codes, right? So the response code 211 will give us a successful status code. So anything in the range of 200s means that it was successful. It's just that what type of request was being made and the data that was being requested, right? So in this case, 211 is the success code for the system status being retrieved. On the X2X series, 220 would end up being the service ready. 27 would be passive mode, long passive mode, extended passive mode. And so if we're looking for entering passive mode, we would look for 227. The X3X, and the way that they're saying it is that this is the first X, that's the second X. So we're looking for the 3 series, right? And that's basically kind of it right here. And this is the pattern that we're noticing. So for this, 230 is the user login, user log out. 331 would be valid username. 430 would be invalid username. 530 would be no login, invalid password. So in this particular case, our success messages are these. And then this one would say that you have a valid username, but I guess the password is invalid, or there was no password entered. 430 would be invalid username or password, and 530 would be no login. So if we got a 230, if we're searching for a 230, we're just searching for somebody who successfully logged in. And the commands themselves, the user, password, current working directory, and then listing things. These are common commands that would be used inside of the FTP connection once you've actually established your FTP connection. So if you type in user after you've connected it, you would be typing in your username after that. So you would type in user in all caps and then provide the username. You would type in pass and then provide the password. And then that's where the connection would be established. And then after you've connected, you can do current working directory to try to find something, right? So in the request commands, you can look for these. In the request arguments, you can look for password. And then advanced usage examples here. So brute force signal, listing the field or failed login attempts, listing target usernames, listing targets for a static password. So response code 530, and the argument contains username. Request command of pass and the argument contains password. These are just usage examples for potentially finding brute force attempts or password spray attempts. That could be the case. So if we look for FTP, as we can see right here, and we'll get all these responses here, all these packets. And if we look at the packet details, you can see the response code. So 530 login incorrect, not logged in, login incorrect, right? That's the one that they're on. But I mean, in the info section, you can also see it. That'll give us the response codes here. So if we wanted to, if you see a bunch of login incorrect taking place, and then if we were to look at the IP address that's requesting it, so 10.121.70.151 is the one that's trying to make these connections take place. And he's trying to connect to the same exact IP address at the end as well, but there's just a bunch of login incorrect that's being done. So that is an issue. And then finally, we get the response 220 FTP service. So that seems to be that they finally got the connection. And you can see that they're using, password Merlin, password Mercury, password Mets, and then finally password manager is actually available, or it's accepted, and they are connected. So this is a clear sign of somebody trying to brute force their way into the FTP server. So we're going to now use the information that we've learned to do an investigation of FTP. And so we have, how many? We have 4 questions on this. So it should be fun to do. Let's zoom out and go ahead and load our FTP PCAP file and begin our investigation. Okay, so here is the FTP investigation. There are 20,000 packets in here. So it says how many incorrect login attempts are there. So we know that if we want to do the incorrect login attempt. So we would be looking for something like invalid username or password, right? That would be an incorrect login attempt. So we can look for that, or we could look for the 530 response code as well, which is no login, invalid password. So we can do either of those, and really dealer's choice, as they say. So response code equals, which one was it? So we have 430 and we have 530. So let's try 430, and 430 gives us nothing. Okay, so let's try 530. Cool. Okay, so 530 we actually got something, and then we have 737. Good Lord, 737 failed login attempts for that. So let's see if that is the right answer. That is the right answer. Okay. Next one is, what is the size of the file accessed by the FTP account? So now what we need to do is we need to get a successful login, right? So that's the key piece. So after all the failed logins, we want to go find somebody, or the attempt that they finally got a successful login, which would be 230. So we'll go here and we'll switch it to 230 and get, okay, there's one successful login. Okay, so there we go. So now we need to just find the access, or the file that was accessed. So let's see. I want to say that what is the stream, or there was a way that we could actually go ahead and get the information from the actual interaction that this packet kind of marks. So it was conversation streamed. There we go, TCP stream, there it is. Okay, so if you just right click on the packet and then go follow TCP stream, it'll give you this stream of the requests that were made, right? So user FTP, password FTP, access granted, they got system, feature, etc., and then print working directory, entering extended passive mode, listing what's available here, and then so file list, and then type I, so type I, size resume.doc, okay, and let's see, extended passive mode, and now we're just trying to find the size of the packet, or the size of the file that was transferred. It has to be the resume.doc. So which one, what is the file, or the file size, I should say? Oh, you know what? Size resume.doc. There we go. So what is that? I think this, right? So that's it, because this is the response code. So that would be at 39424. That is what we're looking for. So let's see, 39424. Okay, great. So the way that we did this was we just looked for the successful login, and once we got the successful login, we went ahead, and so let me just do that one more time for you. So TCP response code, or I'm sorry, not TCP, excuse me, FTP response code response, if I could just type to save my life, 230, FTP response code 230 for the successful login. It brings just one packet. That was the successful login. We right click on that, we do follow TCP stream, and then it brings up all the connections and the requests and responses and everything that was made from that. And then from there, we were just looking for a file. So clearly a file right here. And then the command itself is size. So just trying to find the size of that file, and there it is. So cool. Now, the adversary uploaded a document to the FTP server. What is the file name? Okay, so from our connection here, so if we try to make sense of the commands that are being made, print working directory, they're in the root directory, entering extended passive mode, opening ASCII mode, data connection for file list, type is set to I, and then the resume doc size, entering extended passive mode, opening binary data for resume collection, transfer complete, and then excuse me, current working, and then uploads is the current directory that they're in, entering extended passive mode, opening binary mode, transfer complete, test file exists, upload test directory successful created. So I want to say that resume permission denied, transfer complete. So they did what is it? They transferred the resume doc in here, I think, because it says file exists too. So that make test directory, so make directory, test directory, and then I think, okay, so we'll try resume.doc. And then the next question is, what is the permission? Oh, right here, 777 is the permission to the resume.doc. So, okay, so first let's try resume.doc. Okay, that is the one. And then, so now it says try to change the permission. What is the command used? It's chmod 777. There we go. So that one I recognize right away. And then the resume.doc is really the only one that is even a reference as far as a file is concerned. So that was kind of like, it was a guess, but at the same time, the making of the directory and then directory existing, it was like, okay, well, why are they doing that part? So that was the only way that I made the connection of the file that was being transferred to the FTP server, not necessarily being downloaded by the FTP server. The first one right here where it says, what's the size of the file accessed by the FTP account? That was kind of like misleading. So I thought that they were downloading it, but evidently they were not downloading it. They were uploading it. Okay, so cool. So now we can move on to the next one, which is going to be Cleartext Protocol HTTP. HTTP is the Cleartext version of HTTPS. There is, we have a pretty decent technical explanation for it here, but it's basically the protocol that is used to roam around on the internet. So usually when you do Nmap scanning, you'll see that HTTP port 80 will be open in conjunction with HTTPS port 443. And a lot of times, HTTPS will be open without HTTP being open because port 80 is, again, clear text, right? So you can actually see somebody entering their username and password if they're trying to log into a website, which is also one of the reasons why if you actually visit a website that does not have an SSL certificate or a TLS certificate and it's unencrypted, your browser will be like, danger, don't enter this website. Are you sure you want to enter this website, right? So the HTTP is the clear text request response and client server protocol. So your client, your computer, your phone connecting to a server, right? It's the standard type of network activity to request web pages, and by default, it's not blocked by any network perimeter. As a result of being unencrypted in the backbone of web traffic, it's one of the must-to-know protocols in traffic analysis. We can try to find phishing pages, web attacks, data exfiltration, command and control traffic, etc. So you can look for either HTTP or HTTP2, which is the revision of the original for better performance and security, but HTTP2 is also unencrypted, right? It's not encrypted. It supports binary data transfer and request response multiplexing. So the request methods would be get, post, and really there's put, there's delete, there's a lot of different HTTP requests that can be sent, but the most common are get to retrieve data and post to send data. So when you're sending your username and password, when you're entering your username and password, it's an HTTP post request, okay? Listing all the requests can help you. So if you do http.request, it'll list all the requests. But so request method post, request method get, response status codes. So we talked about these already a little bit. 200 is that there was a successful get or post request, right? 301 is that moved permanently. So whatever you're trying to access has been moved permanently to a different path. Moved temporarily is moved to a different URL path temporarily. 400 bad request means that the server didn't understand the request that you made, so maybe you misspelled something. Unauthorized is that the URL needs authorization, for example, a login. 403 forbidden is that there is no access provided to that requested URL. 404 is that it wasn't found. 405 is that the method that you're using is not allowed or it's blocked. 408 is that there's a timeout request, so the server kind of just lagged out. 500 internal server error is that the request wasn't completed. There was an unexpected error on the server side. And service unavailable is that the server is down, right? Server or service is down. So this is basically a response code, and then you give it the response code that you're looking for. and that's how you can find the types of requests that are being made. Then we have the parameters. So the user agent parameter is typically a browser and the operating system that is using that web server or trying to access that server, right? So the browser and the operating system identification. The request URI is the requested resource from the server. So this will be like the URL specifically, the path to the image, let's say, or the path to the video that you're trying to access. The full URI is the complete URI information, which may include anything that was left out in the request. So when you request something, the actual response or the resource that's being accessed would probably sit on a completed URI, the Uniform Resource Identifier. So it will display in its response. So you request something from the server, and in the response, it'll say, okay, granted access to such and such, and it'll give you the full URI. And a lot of times it's just the longer version of what you requested. So looking for the user agent containing Nmap because somebody's trying to scan your web server, or requested URI containing admin because somebody's trying to access the admin login page. The full URI containing admin, same thing. The parameters for accessing things, so server, host, connection, line-based data, HTML form URL encoded. This is very good for trying to find login information. So if somebody's trying to actually access a login page and entering login information, that's what we would be looking for. So the server name, the host name of the server, connection status, Cleartext data provided by the actual server, and of course the web form. So HTTP server contains Apache server name. HTTP host contains whatever you think it might be. HTTP host equals whatever you think it might be. HTTP connection equals keep alive, right? That means that the connection should be still going, right? Or we're looking for something that instead of the connection being closed automatically because of some kind of error, the connection was keep alive. And so that means that the connection was established, or at least they did something correctly that they didn't get kicked out. The text lines, including the keyword, is something that you can also look for. And then there was the URL encoded something that we had to look for in an earlier task, that we can also look for that specific parameter as well. The analysis of the user agent is very important. So I'm just going to kind of skim through this a little bit. So the adversaries will use advanced techniques, right? Sophisticated techniques to try to leave traces that are similar to natural traffic. For us, it's important to spot the anomaly signs and bits and pieces of those packets. User agent is one of those resources for spotting anomalies. And adversaries successfully modify the user agent, which could look supernatural. A security analyst, and it doesn't say supernatural as one word, it's saying it as it looks really natural. That's basically what they're trying to say. So the security analyst can't rely only on the user agent. They never whitelist the user agent, even if it looks natural. The user agent anomaly and threat detection hunting is an additional data source to check, and it's useful when you know that there is an obvious anomaly. If you're unsure about it, you can always look through the web and try to find the default or some samples on it. So we have the database here. What is my browser for developers? And so we can look for user agents and all these things. This is actually another one of those great resources. I need to start organizing my resources right here, but I'm going to save this as well. And it's going to be what is my browser is what I'm going to save it as. And then ultimately I have to kind of start arranging these because I don't have any folders for them. But this is another really good source for trying to find that. So user agent analysis. The global search would be http.user_agent, and for a low-hanging fruit. So different user agent information from the same host in a short time. Non-standard and custom user agent. Subtle spelling differences. So Mozilla is not the same as Mozlila or Mozlila, like that, right? Audit tools like Nmap, Nikto, WFuzz, and SQLmap in the user agent field. This is a really big one because these things actually show up under the user agent field. And so if you're looking, if somebody's running Nikto against your server, or if they're running SQLmap against your server, it's very likely that they're trying to do malicious reconnaissance against you, right? And if the IP address that's running it is one of your internal IP addresses, okay, maybe it's not that big of a red flag, but they should not be running NICTO. They should be running Nmap. NICTO is like a web server kind of a reconnaissance, enumeration, brute forcing kind of a thing. It looks for vulnerabilities on a web page or a web server. So payload data in the user agent field is another one of those issues. So if we look for example, the HTTP user agent containing SQL map, or HTTP user agent containing Nmap, or it contains WFuzz, or it contains NICTO, this is all one long query, right? You're trying to look for anything that might have any of these potentially in there, because all of these are signs that somebody's trying to do something that they shouldn't be doing. So we have right here, HTTP user agent is what's being searched. And so if we look at the user agent window, or the user agent column, I should say, so you have, Mozilla, Windows, okay, great. Mozilla, Nmap scripting, okay, that's not that good. And then WFuzz, and it's like, okay, well, that's definitely not good. But notice how the Nmap scripting engine actually shows up with Mozilla at the entrance of it. So Windows, NT, and all of that, that's great, but Nmap scripting engine being inside of that is definitely a red flag. And so, of course, WFuzz is also a big concern. So we can find that in the user agent field on packet details. Or if we were to look at the binary data, or not the binary, excuse me, the hexadecimal data, the granular details of it, we can also see it under the payload where the user agent was WFuzz. Then we have log4j, which is technically a campaign name. It was kind of like an attack that was done before, I guess, what is it? It says before launching WireShark. So I guess this is what we might be trying to investigate. That's kind of what it feels like. But this is a campaign that was previously done successfully. So if we're trying to investigate the log4j vulnerability, for example, so the attack starts with a post request, and there are known cleartext patterns like the JNDI LDAP and exploit.class. So these are key elements that we could look for. So we would look for HTTP request post, and IP contains JNDI, or IP contains exploit. Frame contains JNDI, or frame contains exploit. User agent contains $, because that would imply that it is maybe a host name, or user agent contains the double equals, which implies that it probably has a base 64 encoded, because base 64 encoding more often than not ends with the double $. And I'll just show you kind of what that looks like right here. So if we actually go to base, and then if we go to base 64, so we're converting it to base 64, and then that's the domain, right? But then the base 64 encoded is including the $2 at the end. So if we're looking for that, the hint, the idea is that we're trying to find something that is actually base 64 encoded. So in this case, this is what they search for. The user agent contains JNDI, or user agent contains exploit. And then we see right here that right here, JNDI is contained in there. There's no one that says exploit, but JNDI was definitely in there. And then so we see that the very first one was the post request. And then if we go down to the details of that packet, and then we can see that the user agent has JNDI in it. So there we go, we found it. And if we go and look at the actual payload, we can also see JNDI in the payload as well. So these are clear signs, right, that somebody is trying to do the log4j, or they're trying to exploit the log4j vulnerability. So now we are going to use two PCAP files, the user agent PCAP and the HTTP PCAP, to answer these questions. The first two questions will be user agent, and then the questions 3 and 4 will end up being the HTTP. And that is it for this one. So let's go ahead and zoom out of this and go to our instance right here and open up the first HTTP PCAP file, which would be inside of this. So we're going to do, is it user agent first or HTTP first? It's user agent first. Okay, cool. All right. This has 54 packets in it. Okay, so not that bad. So the question says, investigate the user agents. What is the number of anomalous user agent types? So let's see if we can find anything that would be anomalous. We can probably like count them because there aren't that many packets, but let's see if we can find anything, potentially anomalous. So in order to actually figure that out, we need to have a little column, right, that shows us the what is this name one? Can I delete this one? Can I remove this column? Remove this column. Okay, so now we have all of our columns here. So we're going to look for the user agent as a column. So I'm going to click on user agent, apply it as a column, and there we go. Now we have the user agent as a column. Kind of shrink it down a little bit just to be able to see the rest of our stuff over here as well. So we're looking for the, what is it? It says the anomalous user agent types. So let's see, we can find how many here. And let's see what the hint was real quick. Answer is not the number of packets, it's the number of anomalous user agent types. You need to filter the user agent as column and conduct a manual investigation of the packet details to spot the anomalies. In addition to the obvious non-standard modified user agent types, does Windows NT 6.4 exist? Okay. All right. So the answer is not the number of packets. It's the number of the types, right? So, okay. So we have a total of 54 packets. So Windows NT 6.4. Does Windows NT 6.4 exist? That's a good question. Windows NT 6.4 exist. Yes, Windows NT 6.4 existed, but only as an internal development of that, referred to as threshold. But while it was intended to follow, it decided to skip it for the final release to assign context. Early technical views identified themselves as 6.4. Okay, these builds were essentially intended to be follow-up. I mean, it says yes, but the phrasing of the hint is saying that it's not, or it's kind of implying that it doesn't exist, right? And technically, I guess it doesn't, because it was meant to replace something, or it was meant to be, but then something else replaced it. So there shouldn't be Windows NT 6.4 running at all, right? So if we say that that is malicious, right? So this is kind of a malicious thing. So Windows NT 6.4, that's one. And then we have Nmap, that's 2. WFuzz is 3. What else do we have here? SQL map is 4. Mozilla Linux, that seems to be fine. Google Chrome, okay. My Windows, Google Chrome, JNDI, there we go, that's 5. Apple WebKit Linux, Mozilla, Ubuntu Linux, Gecko. Okay, what is that, 5? Is that right? What's the answer? The malicious 5. It's not the answer, okay. Ooh, there's one right here. It's Mozilla. So that would add another one to it. That's so tough to notice. Wow, man. Okay, so 6 it would be the answer. Yes, okay. Wow, I totally missed that. Like at first glance, you don't notice it at all, but you really got to pay attention to it. Okay, so 6. What is the packet number with a subtle spelling difference of the use? That's the one right here. And so that would be packet number 52. Wow. Wow. Okay, cool. All right, so now we're going to go to the next PCAP, which is the HTTP PCAP file, which is this one right here. So it says locate the log4j attack starting phase. What is the packet number? And so to be able to find the starting phase, what did they do over here? They looked for this full query, right? The user agent contains JNDI and all of that. So we're looking for a request method of post, because we know that that's the starting, right? So the attack starts with a post request. And then inside of the frame, I guess, we're going to be trying to find JNDI or exploit. So we're going to try to look for all of those things, right? So we'll do something along the lines of HTTP, dot request method equals post, and frame contains JNDI, like that, right? Or frame like this contains exploit, like that. So I guess I think I need to do this. I need to put this also inside of parentheses to make it right. And an exploit, oh, it's missing a quote. Okay, so all right, so let's see. Let's do this. Okay, I think that's it. That's a post, right? It's a post request. Yep. Okay, cool. So what is the question asking? Look at that. What is the packet number? I want to say it's packet 444. Nice. Okay, like the Jay-Z album. All right, so now locate the log4j attack starting phase and decode the base64 command. What is the IP address contacted by the adversary? And of course, in defanged format, and exclude the squiggly brackets. So we found the thing right here, and then we're looking for the base64 command. So the base64 command, you can actually see it right here. It's like this full thing. So if I can, maybe, can I copy the value? No. Okay, so let's go down here. Let's go to user agent. We're going to copy the value of the user agent down here. And we can go into CyberChef and we can kind of type the whole thing, right? So that's the whole thing. So I'm going to delete that. And then I'm going to delete the last squiggly, which will leave me with the base64. And then we're going to do from base64, right? So from base64, and then we're going to turn that off. And so there we go. So there's the IP address, okay? And this is the full command here. So we're going to take this IP address and we're going to copy that, and we're going to paste it here. And now we need to go ahead and do a defang of IP address. And there we go. So that's the defanged version of the IP address. Fingers crossed. Let's see if this works. Excellent. Amazing. Okay, cool. So we got all of these guys. So now we're going to do the encrypted protocol analysis for decrypting HTTPS, because HTTPS is the encrypted version of HTTP. So as we already established that HTTPS is the encrypted version of HTTP, and so what we can do now is, or what we can assume with this case, is that there is no longer going to be anything in plain text anymore, and everything, all of the data inside of these specific packets are going to look like gibberish, right? Because it's all going to be encrypted. It can use SSL or TLS protocol to encrypt communications. So it's impossible to decrypt these things if you don't have the actual keys, right? So there's key pairs that are included. So because of this specific level, or because of this specific feature of it, this is actually one of the most secure versions of communication when it comes down to web traffic, which is why TLS certificates are used by Google and YouTube and Facebook and XAI and all of these different services, because it is the most secure way to do internet communication. So security analysts should know how to use key files, right, to decrypt encrypted traffic. And really, like, you would be either provided key files, or you would have to find ways to retrieve those key files. Otherwise, without those key files, you won't be able to decrypt and analyze HTTPS traffic. So protocol info fails, like the addresses and all these things from the server, will not be visible. The first image will show them encrypted with the TLS protocol, and then we'll see if we can also decrypt it using our key pairs. So the parameters themselves, right? So the request, TLS, the client request, server response, local, simple service directory protocol, or simple service discovery protocol. And so we have the HTTP request, TLS handshake type 1 and 2, and then SSDP. SSDP is the network protocol that provides advertisement and discovery of network services. So we can see right here. So if we go over here, and you can see TCP, right? And that's the port trying to connect to port 443, which is the encrypted port, right? And then we have a TLS response that it says, hello, client, etc. and then we try to connect to it, and then, or excuse me, there's the client hello. So it's the same thing. So it's actually both of these are coming from the same IP. So the first two are from the requesting IP, and then the second two are from the responding, right? I think, because yes, client hello, and these first two lines are from us requesting, and then the second one is it's responding to us, and then we have that. Once the connection has been established, we can see the cipher change. There it goes. That makes sense. Okay, that makes much more sense. So this basically is just the handshake. I'm so sorry for like the confusion of that. I was thinking out loud. But basically what's happening is that this is the handshake of us connecting to the TLS encrypted server. And then finally, at the very end, the server replies and says hello, and we're changing the cipher because now it's going to encrypt the communication. So that's what we got. So my apologies for not being able to kind of understand that. But so this is the one right here. So it says the HTTP packets encrypted with the TLS protocol. That's what we're looking at right here. So similar to the three-way handshake, the TLS protocol has its handshake. The first two steps contain client hello, server hello, and then the filter shows the initial hello packets with the capture file, and they're helpful to show which client address are involved. So client hello, this is what we're looking for, and then server hello, this is what we're looking for. So TLS handshake type 1 is the client hello, and then type 2 would be the server hello. And so we can see that right here. And we're going to do not SSDP right there, because again, SSDP is a network protocol that provides advertisement and discovery of services. So we don't want that. We want everything that does not include that specific protocol. So then we get it, right? So now we get to see that the request or TLS handshake type equals 1. So this is the actual request itself. So all the client hellos to Google APIs and safe browsing, client services, Google Ads, DoubleClick, gstatic, all these things, right? And then so if we go into it, we can also see the details, and then we can also see inside of the payload the data that would be relevant, right? So there's that. And then so if we do the server hello, which is the type 2, the handshake type 2, we'll get all of these server hello responses. And then inside of that, you'll see change cipher spec, right? So these are the ones that are saying that everything is now going to be encrypted, right? So everything is now going to, from this moment on, the server is going to encrypt all the communications. And then you won't see much after that. As far as Cleartext is concerned, you won't be able to see anything. So now the encryption key log file is the text file that contains unique key pairs to decrypt encrypted traffic. These key pairs are automatically created per session when a connection is established, and these are processes that are all accomplished in the browser. So you need to figure out your system that uses a suitable browser, for example, Chrome and Firefox, to save these values as inside of a key log file. So to do this, you'll need to set up an environment variable and create the SSL key log file. And the browser will dump the keys to this file as you browse the web. So this is something that you can do on your own computer or your work computer if you're trying to get this kind of data, right? The SSL TLS key pairs are created per session at the connection time. So it's important to dump the keys during the traffic capture. Otherwise, it's not possible to create or generate a suitable key log file to decrypt that. So it's very unique to a session. So just keep that in mind, right? These key log files or key pairs are very unique to each individual session. You can right-click, menu, edit preferences, protocols, TLS to add or remove key log files. And so once you do that, you should be able to actually see the data. So in this particular case, let's see what this says. So it says adding key log files with the right-click menu. I don't know. I don't see anything here. So adding it with edit preferences, or maybe this is supposed to be, I think this is like one of those animated GIFs. So let's see if we can see. Yeah, it is an animated GIF. So they click on the packet, then they click on transport layer security, and then they'll do protocol preferences, master key log file name, and then the key log file name path, I guess. This is where we would put, right? And is that it? I think that's it. So that's what that is. And so this was the version where we do the right click menu, and then this is the version where we do edit preferences, protocols, and TLS. So if we look at this image now, they go to edit, they will go to preferences, they will go to protocols, and then they will go to TLS. So let's go ahead and watch them do this. I'm talking much faster than the person's actually doing it. And they're scrolling. This is insane. There are so many protocols. That's pretty crazy. So we got to T finally. Okay, go ahead and click TLS, bro, for the love of God. There we go. Okay, great. And then the debug file is what we're looking for. And then I guess we would put the debug file in there. We would browse and put the file in there. That was way too long. Viewing the traffic with or without the keylog file. So this is what it looks like, I guess, without the keylog file. And then so now they're going to go ahead and do protocol preferences, and they will do master keylog file name. And then they will go ahead and enter or browse the keylog file. So keylog file txt, there we go. Open it, and let's see. Click OK, and it should show us there we go. So there's the decrypted version of it, which we'll be able to see the hypertransfer protocol. If we clicks on that, he'll be able to see the data, and I guess there it is. Okay, cool. All right, so fair enough, easy enough. Traffic details are visible after using keylog file. Note that the packet details by bytes pane provides the data in different formats. Decompressed header of the info and the HTTP packet details are available for decrypting. Depending on the packet details, you can also have the following data formats: frame, decrypted TLS, header, etc., etc. So detecting suspicious activities is in our exercise PCAP file for HTTPS, and we have 1, 2, 3, 4 questions for this. So let's go ahead and load the file. Excuse me. And let's go ahead and have some fun here. So let me make sure that our virtual machine is still good and up and running. And you know what, while we're here, let's just go ahead and add some time to our virtual machine so it doesn't just die out on me. Okay, great. So we are going to now open the HTTPS file. There we go. There's the keylog file, so it's already there. So we're going to open up the PCAP, and right here, so we need to decrypt it with the keylog, right? So that's basically what it says right here. So let's see. It says, what is the name of the client hello message sent to accounts.google, or what is the frame number of the client hello message sent to accounts.google.com? So that one we can actually find, I think, without decrypting it. So let's go ahead and find that specific frame. So let's see. So we're looking for the http.request and, right, or excuse me, or, and then it says the TLS handshake type equals 1. So that's what we're looking for the client hello. And then we're going to say also not SSDP, like that, and let's see what we get. So here's what we got. So user agent, I'm going to remove the user agent column. So client hello, and we're looking for the one sent to Google, but I guess I would have to do the key first, because that it should show it, right? It should show me the actual communication that I would have with Google. So for whatever reason, handshake hello and the cipher, etc. Let's see. Yeah, it's not actually showing me. So I'm going to just do the keylog file right now just to see what is going on with this. So we're going to go to preferences. We're going to go to protocols, and inside of protocols, we're looking for TLS. So we're just going to go all the way down to T real quick. And then from here, we're going to do TLS. Then we're going to browse, and we're going to attach our keylog file, which is going to be inside of HTTPS. And there's the file. Save it. Already exists. You want to replace it. Oh, really? So it's already there? So why isn't it loading everything for me? That's annoying. Okay, so maybe there's something that I'm missing that I can't see the actual domain, because you can see it right here, right? Like, I'm not losing my mind. You could see under info, we can see client hello. So I should also be able to see client hello. So maybe there's some kind of an issue with the actual data itself. So let me see if there's a column that I'm missing or something. Okay, perfect. So there we go. So it's actually not the way that I thought it was going to be named. So it's under the handshake protocol portion, and we go down to the server name and then server name indication. So once we expand these, we can see now server name is right here, client services.google APIs. And then I just added that. I right clicked on it and I added it as a column. And so now we actually have the server name. So we're looking for specifically the client hello that goes to accounts.google.com, and so there is accounts.google.com, and it is number 16. So it's packet number 16. Okay, so very good. So it says decrypt the traffic with the keylog file. What is the number of HTTP2 packets? And the hint, let's see what the hint says. Import the key file to decrypt the traffic. I already did that. So we're looking for HTTP2 packets, and there was a filter up here that kind of showed us the type of HTTP2, right? Or no, actually, I think it was in this one for HTTP2 right here. So let's see if we just type in HTTP2, if it'll just kind of work just like that for us. Okay, so it's definitely not that. So let me see. I think there needs to be like a specific filter that I'm gonna create to find the HTTP2 packets. Okay, so I crashed the machine, I restarted the machine, I restarted WireShark, and essentially I went on transport layer security, right clicked on it, protocol preferences, master keylog file name, and then down here is where I put the keylog file name. This one up here I didn't change, I put it down here. And then clicked OK, and then everything worked. And then right here, I went and just typed HTTP2, and it actually brought up the HTTP2 packets. So that the filter itself, the display filter, is HTTP2. It's just for whatever reason it wasn't actually loading, and so I had to restart everything. So 115 is the number of packets that we have here. Now it says go to frame 322. What is the authority header of the HTTP2 packet? Enter it in defanged format. So we're going to go to frame 322 right here, right? 322 or 332? 322. Okay, so now we want to go look for the header in this location here. Header for the authority. So if we go down here, we have the authority header, and it says safe browsing. So we're just going to right click and we're going to copy the value of that. Go to CyberChef, enter it here, and we're going to do defang URL. And so there is that. So we're just going to copy that and come back to our question here. And there is that. So investigate the decrypted packets and find the flag. What is the flag? So what's the hint? It says you can export objects after decrypting the traffic. Okay, so we can go to File, Export Objects, and we're going to export HTTP objects. And we have a couple here. There's the favicon, and then there's this one right here that has this like really long name. That is a very long name for a file. So I'm guessing that's the file. It can't be the favicon. Well, we're going to save it, and we'll save it to the HTTPS folder just to be consistent, you know. Okay, so we saved the file. So we're going to minimize this, and there's the file. So let's see if we can open this. And there we go. So the flag is THM packet master. So we're going to copy that bad boy or bad girl, whatever. And there we go. So there is the flag. So now let's go look at the bonus here. The first bonus is to hunt Cleartext credentials. So as mentioned, WireShark is not an IDS, but there are some use cases for expert info. Sometimes anomalies replicate, detection becomes harder. So for example, Cleartext credential hunting is not easy to spot multiple credential inputs and decide if it's a brute force or just a standard user who forgot their password. Everything is presented at the packet level and it's hard to spot multiple username password entries. The detection time will decrease when an analyst can view credential entries as a list. And so WireShark has a feature to help us do this. Some WireShark dissectors would be FTP, HTTP, IMAP, POP, SMTP. They're programmed to extract Cleartext passwords from the capture file. You can view these using the Tools Credentials menu. It works only after specific versions of WireShark, and since the feature works only with particular protocols, it's suggested to have manual checks and not entirely rely on this feature to decide if there's a Cleartext credential. Once you use the feature, it will open a new window and provide detected credentials. Shows the packet number, protocol username, additional information. It's clickable. Clicking on the packet number will select the packet containing the password, and clicking on the username will select the packet containing the username. So that's what it looks like. Tools credentials gives us a list, and then username admin, and then that's pretty cool. I mean, it's really handy. So it says use the desktop exercise bonus exercise PCAP file. What is the packet with the credential using HTTP basic auth, and then the packet number where the empty password was submitted. So, whoops, we need to zoom back out again. Go over here. We can close this guy out now. Go to exercise PCAPs. Let me also just close this just so the machine doesn't lose itself, really. Bonus exercise PCAP. Okay. Let's see here. Let's see what we can find. So the question again is packet number of the credential using HTTP basic auth. And the hint says tools credentials. Okay, fine. So we're looking for HTTP basic auth. So we're going to go to tools, credentials. And there we go. Protocol right there. HTTP basic auth is right there. And then AFIISKC. So packet number actually is 237. So 237 is that one. And what is the packet number where the entry password with the empty password was submitted? So we can go find the usernames, and I'm gonna just go to this one for now just to see if there was an empty password submitted here. Let's see if we can actually find that. So get method is get. We need to find a post method actually. So that's the key element. We need to find post method. How many do we have? So we have 243. So if I do HTTP request method equals post, because that would imply, and there is no post method. Okay, so never mind. Because I was gonna say that would imply that they sent the password, but the one username and pass and things like that, those are the key things that usually are sent via a post request. But for whatever reason, I think maybe that was the issue, is that the protocol was the HTTP, so the maybe FTP protocols don't have the post request. So okay, so we'll just look at it, and so all of them actually have this right down here nicely. So let's see, argument moose. So that one has a password. That has a password. I'm going to click through all of these to see which one has a empty password. Okay, it's packet 170 that does not have a password so far, and the rest of them have passwords. So packet 170 does not have a password. Very good. All right, so now we're going to go to our next bonus here. Actionable results is the name of this one, and specifically we're going to be talking about creating firewall rules. So WireShark is not all about packet details. It can actually help us create firewall rules, and we can go tools, firewall, ACL rules menu, and once you choose this, it'll open a new window, provide combination of rules for different purposes. These are generated for implementation on an outside firewall interface. It can create rules for net filter, Cisco, IP filter, IP firewall, packet filter, and Windows firewall. Very cool. So we would go tools, firewall rules, and then boom, we have a bunch of stuff. And then we can do create rules for a specific thing. So IP tables, for example, is the net filter, which is typically on Linux. And so inbound deny, for example, could be the rule. IPv4 source address. So it's actually really handy. This is actually very, very cool. So we're going to use the same PCAP file, select the packet number 99, create a rule for IP firewall. What is the rule for denying source IPv4 address? So let's zoom back out here. So same thing. So we don't need to change our stuff right here. So we're going to do firewall ACL rules, and we need to actually, so okay, let me go to what it says, packet 99. So we're going to go to packet 99 first real quick, and then for packet 99, so we'll click on that one, tools, firewall ACL rules, and it needs to be for the IP firewall. So we're going to go down here, we're going to click IP firewall, and we want to do what? Denying source IPv4 address. So IPv4 source address right here. Can I click on it? What's going on? It's not letting me click on anything. I feel like I should be able to click on stuff. So it's add deny IP. I'm going to type it out in a different window real quick, just so I can copy paste it. So it says add deny IP from IPv4. Yeah, so 10, 121.70, and 151 to any in. I believe that is the rule. So we're going to copy that now, paste that. There you go. Okay, so that's what it is. I guess it's not something that I can copy. So select packet number 231, IP firewall rule. What is the rule for allowing destination MAC address? So we're going to, oh, I could have, well, I can't copy anything because I can't, oh, there we go. Maybe that's what it is, maybe. Okay, close. So we're going to packet 231, and on packet 231, we're going to go to tools, firewall rules. We're going to do the IP firewall, allowing destination MAC address. So change this to IP firewall, and we're looking for allowing destination MAC address. Let's see where that is. MAC address source, and we want source address allow. Where is it? Why can't I find inbound deny? So let me take that and take off inbound as well. So I'm going to take off deny and take off inbound. So now we're looking for things to be allowed, right? So destination MAC address, add allow MAC. There we go. To any out. I got to be able to copy this because I'm not going to type that out, man. That's insane. So we're going to copy that. Let's see if that actually copied. It did not copy. Or did it? Hold on. It did. Okay, wonderful. All right, so there we go. So now we can go here and paste that here. Wonderful. Sounds amazing. We are officially done, my dear friend. This was cool. This was a long one. It took me a couple of days and let's say like 4 hours in total to record this thing, because there were some challenges, and then I had to re-record a specific section because my freaking OBS stopped recording. I was losing my mind when I found that out. Thankfully, I didn't go through the whole thing and then realize that I wasn't recording, and because I would really go insane. It's like very disheartening when something like that happens. Okay, so we covered WireShark, and we went into some pretty advanced stuff and really handy stuff. There are now WireShark challenge rooms like Carnage Warzones 1 and 2, and it's really handy to know this tool. This is like the industry standard tool when it comes down to granular packet analysis. Again, it's not an IDS, right? It's not something that is going to detect things for us. But if you know what you're looking for, this is a very, very good tool to help you do some deep dives into stuff. These will also be other rooms that we can use. For example, NetworkMiner, Snort, Zeek. And I think all of these are in the SOC Level 1 pathway that we're on. So I think we're probably going to retouch on these again, because I've already done all of these rooms probably over a year ago. But ever since then, there have been updates to the data and the information, as well as just my skill set. So I think I can probably teach better when it comes down to these specific rooms. So we'll be covering those again. And I'm just very excited to go through the rest of it. And this was one of the rooms that, like, when I saw the length of the room, and each one of these things is like super in depth, and it's like a really long lecture portion. I was like, okay, well, this is kind of intimidating, but we got it done. So at the very least, we got it done. And if you've made it to the end, and if you're here now, then drop a comment saying that you made it to the end and you watched everything, just so I can give you some kudos and some recognition in the comment section. But I hope you actually got some value out of it, and you actually learned, and you were able to find the answers, and you learned how to find the answers. More than getting the answer, I hope you actually learned how to find the answer. All right, that's it. If you found value in this video and if you'd like to get more videos like this one, then I encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel, especially as we dig deeper into SOC Level 1, as we go and wrap up the CompTIA Pentest Plus labs, as we go ahead and get further into AI for cybersecurity and API integration. And then there's going to be CompTIA Linux Plus, the new 2026 version that's going to come out. There's a lot of stuff. Every time I do a video, I add more videos to my pipeline of videos that I'm supposed to create. So it's not going to stop anytime soon. And there's going to be a lot of other stuff that's going to come out. So if you have not done so already, make sure that you drop that subscribe. And if you have any questions about what we talked about today, or comments or anything like that, please drop it in the comment section below, just so I can get to your question and help you kind of work through any challenges you might be having. And that's pretty much it. There's a bunch of content that's available on our channel. There's a bunch of playlists, there's courses, a bunch of great stuff. And I'm working on becoming accredited with CompTIA so that I can get you discounts on your exam vouchers, which will end up being another massive benefit that I think will save our students money and help you get your certifications faster and easier if that's something that you are really interested in doing. So if you have not done so already, make sure that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel. If you want access to my notes and exclusive downloads and to get lifetime access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers. We have the supporter, the agent, the guardian, and the master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below and you will be able to choose the tier for which you want to join. I really hope I see you in the Discord chats. If not, I hope I see you in the comment section. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease. And I'll see you in the next video later. Okay, today we're going to wrap up the network traffic analysis module by using NetworkMiner, which is actually on the forensics side of security analysis. My name is Hank Hackerson, your trainer for today, and to get more videos like this one, make sure that you like, subscribe, and turn on the notification bell. This is the last room inside of the network traffic analysis module inside of the SOC Level 1 pathway of TryHackMe, and this is all for 2026, the updated version of the path. And so we're going to be using this tool that helps us analyze recorded network traffic and practice network forensic activity. So this is typically after incident response takes place. So incident response and digital forensics are in the same breath typically. And so when something is happening in a live incident, that's when you need incident response activities and skill sets. And then after the incident has been handled, now you want to do forensics. You want to do investigations as to what happened, how can we prevent it from taking place, who was involved, etc., etc. So this is one of the tools that we would be using in that kind of an environment, and that is NetworkMiner. So there's the introduction, NetworkMiner in Forensics, what it actually is, the overviews 1 and 2, and then version differences, a couple of exercises that we got at the very end, and the conclusion, and then we'll wrap up, and then you will be dismissed for the day. All the timestamps for these things are going to be in the description below if you want to kind of jump around or if you want to review a certain section more than once. And that is pretty much it. So a quick little note from Hackaholics Anonymous, and we'll get into the introduction. If you want access to my notes and exclusive downloads and to get lifetime access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers. We have the supporter, the agent, the guardian, and the master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below and you will be able to choose the tier for which you want to join. I really hope I see you in the Discord chats. If not, I hope I see you in the comment section. All right, so NetworkMiner is actually another open source tool that's available to us. It's a traffic sniffer, very similar to WireShark. It is a PCAP handler, very similar to WireShark, and a protocol analyzer, same. So it's developed and maintained by NetResec. And the official description, if you wanted to actually go to their page and read more about it, the website itself is netresec.com. And so NetworkMiner, obviously, right here, voila. And then you can go and do all of your independent reading should you choose to. But real quick, it's open source, network forensic analysis tool for Windows, but also works in Linux, macOS, and FreeBSD. It can be used as passive network sniffer packet capturing tool to detect OS, sessions, host names, open ports, without putting any traffic on the actual network. And it can also parse PCAP files for offline analysis to regenerate or reassemble transmitted files and certificates. NetworkMiner has since, in the very first release of 2007, it has become a popular tool among incident response teams as well as law enforcement. So it is actually a tool that is widely used. And if you want to go into digital forensics, this might be one of those tools, in addition to, the forensic toolkit and all of these other tools that are used for network or digital forensics, I should say. So we aim to provide a general network forensics overview with this specific video. We are not going to be doing a lot of deep dives into the various concepts of it, especially anything that would be outside of NetworkMiner. As you know, if you've seen any of my videos in the past, I do go down certain rabbit holes and I kind of go on tangents. So most likely we'll be talking about some other things that are not exactly in this video itself. But for the most part, the goal is to talk about NetworkMiner in the conjunction or in the context of digital forensics. Our objectives are to discover what it actually is, the basics of the tool, and explore different information tabs and extract information efficiently. The prerequisites would be network fundamentals. If you don't know the network fundamentals, you gotta go through network fundamentals. It's like a very, very basic room. It is something that we have actually done, so if you want to look up these topics, you can actually look them up inside of the channel search bar, and then you'll find videos about these specific topics, and you can learn more about them. You can also go into the Linux Network Plus playlist that I have, and from there you can learn even deeper information about networking in general and just get a really, really good set of instructions for networking. That specific playlist has been used in detail and in preparation for a lot of exams that people have taken and actually used it to pass their Network Plus certification with CompTIA. So I'm pretty confident in that playlist. For our use case, we're going to be using the same virtual machine for the walkthrough and the exercises. It's an Ubuntu machine. NetworkMiner is already installed. You can always just download NetworkMiner yourself on your own computer and just go through the flows that I will be going through and do some packet capture and then investigate inside of your package capture from your own computer. So there's a lot of different ways that you can actually use this and just kind of make your life easier if you don't have access to TryHackMe or the pro membership of TryHackMe, I should say. I've already started the virtual machine and I can click split view, but I'm super zoomed in onto the screen right here. But if you're using TryHackMe, your view shouldn't look like this because I'm literally at 300% view. So once we're ready to actually look at the tool itself, I'll zoom out and then we'll go ahead and start using the actual tool for the investigation. So the way that we load it, basically we load the virtual machine, we click on the NetworkMiner folder here and then do the NetworkMiner exe, and then voila, it opens up and that's it. We got it and we're ready to go. So that's it for this introduction. Let's talk about NetworkMiner and its role in forensics. So in the description for this task, it says that the ultimate goal of network forensics is to provide sufficient information to detect malicious activities, security breaches, etc. My view on it is that if you're in the forensics phase, you're no longer in detection, really, you're more in investigation mode. Detection is done when somebody is in security analysis and in incident response teams. When you're in forensics, you're in the investigation, you're in the post-incident phase. So NetworkMiner is a great tool to help as it provides quick and useful hints on where to start from, specifically the context of captured hosts like their IP and MAC addresses, host names, or operating system information. list of potential attack indicators or anomalies like traffic spikes or port scans, tools or toolkits used to perform the potential attacks, for example, Nmap. The supported data types would be live traffic, traffic captures, and log files, and is capable of processing and handling both packet pictures, which is PCAP, or also known as packet capture files, and live traffic. Therefore, we'll focus on live and captured traffic in this specific video. And that's pretty much it. That's the introduction of NetworkMiner and its role in forensics. So let's actually talk about what it is. Okay, here's the first set. So this is actually a longer section. Thankfully, we actually get some detailed information. So NetworkMiner has several capabilities. First one would be traffic sniffing. So it can intercept traffic, sniff it, collect and log packets that pass through your network. It can parse PCAP files. So if you already have sniffed traffic through a different tool or somebody gave you the packet capture file, whatever, it can parse that file and show the content of that in details. It can analyze various protocols. So the protocols that might be used inside of that PCAP file, for example, FTP, HTTP, Secure Shell, TLS, whatever. OS fingerprinting. It can identify the used operating system by reading the actual file. This feature strongly relies on Satori and POF. So if we kind of open these up just to do some independent reading real quick, Satori is available through a GitHub repository by XNIH, also known as ERIC, and it's an open source tool that you can download and install. It's more likely we can say that it's a Python rewrite of a passive OS fingerprinting tool, and it can support these various protocols specifically. There's a lot more information should you choose to read up on it. Then we have POF. The most recent version is 3.09b, and it's a tool that utilizes an array of sophisticated, purely passive traffic fingerprinting mechanisms to identify the players behind any incidental TCP/IP communications. This is a very, very long introduction. This whole thing is one sentence, by the way, so I'm not going to read that whole thing for you, but it's basically a tool that utilizes things to identify players behind any kind of TCP/IP communications. And that's basically it. We'll just leave that right there. So that's POF. So what we can then conclude is that NetworkMiner uses those two different frameworks for its OS fingerprinting abilities. It can also extract images, HTML files, and emails. It can grab credentials, extract credentials from the PCAP file, and it can even get text, clear text keywords and strings from the parsed PCAP file. So we'll be using the free version of NetworkMiner, but there's a professional edition that has many more features, and you can obviously go ahead and go to the NetResec website and look at the versions of it for even the paid version. So you can see right here, so this is what the free version, let's see if we can kind of zoom in here. This is what the free version does, and then this is what the professional version does. And then the cost is $1,300 USD for the professional version. What's nice about that is that it seems to be a one-time price that you would pay. So you pay $1,300 and then you get access to the full professional version of it, and I would presume all future updates as well. So it can be very handy, and we're going to use it just so you can see just how handy it can be. And if you're working for a company that actually has a decent budget, or if you have some deep pockets, you can go ahead and get that for yourself as well. So the operating modes. Sniffer mode, it has a sniffing feature, but it's not used as a sniffer, or the intention is not to be used as a sniffer. The sniffing feature is not as reliable as other features, therefore we suggest not using it primarily as a sniffer. Even in the actual description of it, it says that it's a network analysis forensics tool, but it can be used as a sniffer. So again, it's not meant to be a sniffer. It's mostly meant to be a packet parsing and processing tool. It can parse traffic captures to have a quick overview information on the investigated capture and extract files and everything that we just talked about in these little sections right here. The pros and cons would be that it can do OS fingerprinting, easy file extraction, credential grabbing, clear text, keyword parsing, overall overview. The cons is that it's not useful in active sniffing, not useful for large PCAP investigation, limited filtering, and not built for manual traffic investigation. And it doesn't say whether or not the pros and cons are limited to the free version or the full priced version as well. So we can kind of just assume that they're talking about NetworkMiner as a whole, whether or not it's free or if it's not free. Now we can actually compare it to its kind of cohort, which is WireShark. And in this case, so, purpose, quick overview, traffic mapping, data extraction, WireShark, in-depth analysis. They both have a graphic user interface. They both can sniff. They both can handle PCAPs. WireShark cannot do operating system fingerprinting. Parameter keyword discovery is manual in WireShark, and it seems to be automated on NetworkMiner. Credential discovery on both sides, file extraction on both sides. Filtering options are limited. Packet decoding are limited with NetworkMiner. On WireShark, it is very, very in-depth. Protocol analysis is not even included inside of NetworkMiner. Neither is payload or statistical analysis. All of those are available inside of WireShark. Cross-platform support is on both sides. Host categorization is not available on WireShark, but it is available on NetworkMiner. And ease of management is done for both of them. So, there's a lot of overlap, right? There's a lot of stuff that they both can do, and I personally use WireShark more than I use NetworkMiner, mainly because the fact that it is much more detailed, and if you get good at using something that is that detailed, then using a tool like NetworkMiner will be just a piece of cake for you. And more often than not, companies will request that you know how to use WireShark more than they would want you to use NetworkMiner. So those are my reasons for preferring WireShark, but it's always good to have more than one tool available. And of course, there's just the case that a company might prefer NetworkMiner. It's not that it doesn't exist, it's just that more often than not, they require that there is WireShark. So yeah, that's just my 2 cents, right? It's always good to know more than one tool. It's always good to have a big, utility belt kind of a thing, or an arsenal of tools available to you, just in case you're limited to an environment where there's only one and then the other one is not available. So let's now go into the overview of the tool itself. All right, so we're going to do the overview with the screenshots, and then at the very end of this section, there's going to be a set of questions that will be presented to us that we will then use the information that we've learned to actually do the investigation with the tool itself. So the landing page, this is just what it looks like when you actually land on the tool, when you open the tool. The file menu, as every other tool literally has something similar to this. You click on file, and then you can do open of a PCAP file. And in this case, there's the option to receive a PCAP over IP and then exit. The tools menu will clear the GUI, everything that you have for you, delete the captured data. The help menu, check for updates and learn more about the tool. The case panel, this is where the list of the investigated PCAP files will actually be shown. We can reload or refresh, view metadata details, and remove loaded files from this panel. Viewing the metadata of loaded files. So on the case panel, we'll click on a file, right? I think they're right-clicked on here. So we would right-click on the file, click on show metadata, and then it'll open up a new window for us where we can actually look at the metadata of the file. The hosts menu shows the identified hosts. This provides information on IP addresses, MAC addresses, OS type, open ports, sent, received packets, incoming, outgoing sessions, details. And OS fingerprinting uses the Satori GitHub repository and POF, as we already discussed. And the MAC address database uses the MAC ages GitHub repo. And we can sort the identified host by using the sort menu. We can change the color. Some of the features like OSINT, which is open source intelligence lookup, are available only in premium mode, but you can always just go ahead and do your own OSINT and start Googling and finding more information. So you can just right click on something and it'll help you copy and paste the selected value. So in this particular case, we are on the hosts tab right here, and then IP address ascending, and so we'll see all the IP addresses, and then we can right click on any of these things right here and look for more information. Oh, this is actually the drop down that you see right here. So the drop down right there can help you sort things, and then if we right click on any of these, it can actually give you more information like expand all, collapse all, copy text, set the host color, and even more. So there's a lot of good stuff over there. The sessions menu shows detected sessions in the PCAP file. It's the frame number, client server address, source destination port, protocol, start time, and all of these are literally, again, you just go to the top right here and you just pick and choose. So they are now on these sessions, right? Originally it was on hosts, and then they're on sessions, and then we can see there's files, images, messages, credentials, DNS, parameters, keywords, anomalies. All those things are available. As long as we just click on one of the PCAP files, we'll be able to see all of the information for that PCAP file. And then you can just kind of sort through it. In that regard, in that sense, it's actually, I would say, more user-friendly than WireShark is, because it already just extracts this information for you and categorizes it for you. So you can kind of just click around and find the things that you're looking for. WireShark is very detailed and you can find more information, but you really need to know where you're looking and how to search for things. You can search for keywords inside of the frames with the help of the filtering bar. It's possible to filter specific columns of the session menu as well. And it accepts 4 types of inputs: the exact phrase, all words, any word, or regular expressions. The DNS menu shows the DNS query. So frame number, timestamp, client server, source and destination port, IP time to live, DNS time, transaction ID and type, DNS query and answer, and the Alexa top 1 million ranking. That's actually a really interesting piece right there. It's kind of funny that they actually have that over there. I don't know how relevant that is anymore, but it will show you if that website is in the top 1 million websites across the world, or that DNS, I should say. Some of the features, like the Alexa top 1 million, are available only in premium mode. There you go, so we don't even need to know it. And then so this is now what the DNS tab looks like. So you see the timestamp, the client itself, the port, server, etc., etc. And so in this case, the client would be the source, the server would be the destination, right? Credentials. So it shows extracted credentials and password hashes from investigated PCAPs. You can use Hashcat from GitHub and John the Ripper to decrypt exacted credentials or the extracted credentials. I have pretty in-depth videos using those 2 tools, Hashcat and John the Ripper. I personally love John the Ripper, but Hashcat is also really good. So either of those can actually be used to crack passwords, and it can extract credentials using Kerberos hashes, NTLM, RDP, HTTP, cookies, and requests. IMAP, what happened right here? IMAP, FTP, SMTP, and MySQL or MSSQL. The right-click menu is helpful in this part as well. You can easily copy the username and password values just by right-clicking on a line and then doing copying username or password. Very, very useful. So that's pretty much all we got for the first section here. So now we're going to actually use the MX3 PCAP file to answer the following questions. So let's go back here and zoom out here. We'll do show split view. We'll open it up in full screen mode, and then we'll close this thing right here. And so, all right, so we're gonna open up first the, what is it, MX3, right? MX3 PCAP. So I'm gonna go ahead and open that real quick. And then once it loads, we'll look at the questions. Okay, so here's what it looks like when we actually load our file. So I loaded NetworkMiner, I clicked on File, Open, and it's inside of the exercise files on the desktop. So MX3 PCAP is what we are looking at right now. So the first question is, what is the total number of frames? So we need to just go to this guy, right click on it, and do show metadata, and here's what loads for us. So if we zoom in here, and let's kind of just expand on this value, so frames and then the value. So there are 460 frames, so we'll just do that, and that'll be our answer. How many IP addresses use the same MAC address with host 145.253 ... Okay, so let me kind of do this here. So we'll look at the IP address. So we have it ends in 2203, 145.253. It ends in 2.203. Okay, so we want the how many, what is it? How many IP addresses use the same MAC address with host that. Okay, so we'll go to host, and we're already here. So let's expand on the host for 145, okay. And then how many IPs use the MAC address for this, right? I think that's what we're looking for. So the MAC address for this would technically be Is that the question? I'm trying to kind of understand what the question. How many IP addresses use the same MAC address with hosts? Yeah, so we want to find the MAC address for that host and then find how many IP addresses are communicating with that MAC address. I would presume that's kind of the thing. So this is the host and then this is the MAC address. And so same MAC address 2, I guess. So in addition to that, there would be 2 IP addresses that have that same MAC address. There we go. How many packets were sent from host 65 ... So 228, 223 is the last 6 digits. And so we want to see how many packets were sent from that host. That host would be this one at the very top right here. So if we expand on that and see the number of packets, so sent 72, received 64. So what is it asking? It says sent from, so that would be 72. What is the name of the web server banner under that host? So if we go over here and the name of the web server banner under that host, let's see what we can find. Host details probably. Web server banner TCP80 Apache is the name. We're making some decent progress here. And now we're going to load the MX, wow, this super zoomed in, MX4 PCAP file. So we can technically just go file and open the next PCAP, which is this one. And that one was also pretty quick. It seems to be like very, very quickly done. So I'm going to click on MX4 right here just to make sure. Does it change? I want to say it should, right? So if I show metadata on this one, I don't know if it's loading on the screen for me because it doesn't really tell me. So what if I double click on MX4? Does it load MX4? Because it kind of looks like it's loading the same one. It's loading like MX3. So what if I delete MX3? So remove selected files from case. Okay, so if we do that, does that do anything? It feels like it's not really changing the data. We'll see if that's the case. Okay, so what is the extracted username for the 2694 Win10 host? So extracted username. So we will go to the credentials, and for that host, I think it's B administrator, but to be clear, so where's the host itself, if we can get some more information on that. So it's actually right at the beginning. It's next to the IP address. It gives us the host name. So, hashtag B / administrator is the name. So we'll just do that like this. And now what is the extracted password for the user logged into that host? Enter the full NTLM hash. So if we go here, so the extracted password right here, we can see there's the NTLM challenge. So if I copy password, and let's go into CyberChef real quick and just use that as kind of our text editor here. If we paste it, I wonder if it pastes the whole thing. So NTLM challenge, NTLM response, that might not be it. So if we go back here and right click on this one and copy the password for this one and paste that, that might be it. Not exactly sure. I feel like that would be it. Let's see what the hint says, because there was a hint right here. It says which tab lists login information. Okay, well that's useless. So I'm gonna copy this whole thing. Let's see if that is the answer they're looking for. It might be, because it seems to be a really long answer. So let's see if that's the one. Okay, that is the one. So it's the second one. It's the one that starts with $net NTLM v2 yada yada yada. So that seems to be the answer that we're looking for. So with that, we have answered all of the questions for the overview 1. So let's now go into overview 2. Okay, so you can also find files inside of NetworkMiner under the Files tab. So, I mean, I'm super zoomed in now, but you can literally see files right here, right? So you can find files under the Files tab. It gives you the frame number, file name, extension, size, source destination address, and port, protocol timestamp, reconstructed path, and the details. The hash lookup are available only in premium mode. Search bar is available here as well. Right click menu is helpful as well. You can easily open files and folders and view the file details in depth. For example, right click on it, open the file, or open its containing folder, look at the file details, and it opens the file for you. which is an image in this case that says BBC on it. Images right here. So the file menu shows extracted images from investigated PCAPs. The right-click menu is helpful in this part as well. You can open files and zoom in out easily. So right-click on the actual file itself. So where are we? We're on images actually. So it'll show image previews, and then we can right-click on it and open the image. And again, it'll just open the image. Once you hover over it, it shows the file's detailed information like the source destination address and the file path. And then we can look at parameters, which is yet another thing that we have here. So it's right there. It's kind of a little bit cut out. Parameters will give us the parameter name. So extracted parameters from the investigated PCAP. Parameter name, value, frame number, source destination, host, and port, timestamp, and of course details. And of course we can just right click on something and copy the name or the value of that parameter. And keywords, so frame number, timestamp, keyword itself, context, source destination, host, and port. And then how to filter them, we can either add keywords or reload the case file. So you can filter multiple keywords in this section. However, you must reload the case file after updating the search keywords. And the search investigates all possible data in the processed PCAPs. So we can actually, on the keywords tab, we can go and add a keyword, for example, .html. And it says, please add keywords before loading a PCAP file or press reload case files. So when we do that, we would actually have to press the reload. I think that's what I should have done in the last one. Instead of deleting the PCAP, I should have just done reload. And then it'll go ahead and pull up everything that has that HTML keyword in it. It's kind of blurry. I don't know if you can see that, but it'll pull up everything that has that HTML keyword in it, and then you'll be able to, do your filtering and investigation accordingly. The messages shows extracted emails, chats, and messages from investigated PCAPs. So something like the frame number, source destination host, protocol, sender, receiver, timestamp, and size. And once you filter it, you'll discover additional details like attachments and attributes. Note that the search bar is also available, right-click menu is also available, and you can use the built-in viewer to investigate overall information and open the file option to explore the attachments. So if we click on anything, we'll get the view on the right side that gives us some details about it, like from, subject to, message ID, etc. And we can look down here and see if there are any attachments, and then we can right-click on it, open the file or the folder, and be able to get more information about that. And finally, we have anomalies, which shows the detected anomalies in the PCAP. And it's not designed as an intrusion detection system, but developers have added some detections for Eternal Blue, which is a very famous exploit, and some spoofing attempts as well. So it's not fully functional as an IDS or anything like that, but it has some capabilities to detect anomalies. And so under the anomalies tab, we can potentially see any of those things that might exist. For example, spoofing, like different source MAC addresses, or eternal exploit eternal exploit attempt, excuse me. So that's all we got for that. So now we're going to use the MX7 PCAP file to answer the following questions. So let's zoom out a little bit. And MX7 is going to be used for this one, and then MX9 is going to be used for the last two. So let's go ahead and load MX7. When I zoom out, the machine has to kind of like reconnect to itself because it loses itself. There we go. Now it's lost itself. So now we have to go through this again and do show split view. And did it? No, it didn't die on me, did it? It did die on me. All right. So we're going to restart the machine because it freaking died. All right. I'll be back. Okay, so this one is actually a bigger file, and it's actually giving me a status bar while it's loading. So we're gonna give it a quick minute for it to finish loading, and then we will begin our investigation. The first question is, what is the name of the Linux distro mentioned in the file associated with frame 63075? So we're gonna go to the files and find that frame number, and then get the Linux distro. So, once it loads, we'll do that. Okay, we have loaded, and this is actually a very, very large file. So let's look at the metadata real quick just to see how many frames we're looking at, because this seems like a pretty large file, honestly. So frames, we have 82,718 frames. It's a pretty big file. Okay, so we're going to go to files, and inside of the files, we're going to be filtering for the frame number, really. Or I could just kind of click on the frame number and have it go in descending order. I think that's probably a way that we can do it. I don't know if it'll do it. No. So it does not do it. So what we can do is, let me see if I can actually type this number. So let's see if that'll actually pull up the file 63075. Let's see if that actually searches. Let's see. Oh, it does. Okay, perfect. So it actually pulled up 63,075. File name is yada yada yada. And so we're looking for the distribution of Linux, and says destination is Linux. Source host is CentOS.org. Distribution is Linux. Timestamp reconstruction. Okay, so let's go and see what we can actually find from this file, because we can probably pull some good details about it. It is a TXT file, and we even have the file name. So in the actual details like this, I can't really find anything. So I'm going to just open the file and see what kind of file it is, because it is a text file. And we can hopefully try to sift and sort through the text file to see if we can pull any information. If not, we might have to look at like the details of the file and see if there's anything that we can pull out that way. I don't know if it's loading or not. Let's see, right click, open the file. Let me see if it works. Okay, so actually I double clicked on it and it opened the file. So this seems to be a little bit better. CentOS, I believe, is actually an operating system. I think it's like a distribution of Linux, and we see it a lot. So we see, you know, CentOS 7.0, 1406, etc. So Linux distributions, CentOS again. So we see all of that over here. I do know that for a fact. So if the answer is just to be CentOS, I think we're good. Yeah, it is. Okay, so what is the header of the page associated with frame 75942? So we're just going to copy that now, and we'll go over here and we'll paste 75 right there, apply. And all right, so we can just open this up like this. And so we want, what do we want? We want the header. Oh, there we go. So this is now an HTML page that we can see here. It says pwned, so head. So anything that you see inside of this head right here is the header. So, and then we can, if we see a closed, so it's like that sign and then / head, that would be the closed of the header. So the title would be inside of the header. And in this particular case, it also starts the body right here. So I would say probably this would be the header right here, because now we can see the body tag opening up. And then do we have a closed body tag? Let's see. Let me expand on this a little bit. It's very, actually, like reading HTML is kind of pretty simple. So this is, I don't like these things to try to expand this menu. Can you, come on, for the love of God. There you go. That's what it is. Okay, cool. So if we go here, Ned Flanders is a person you can rely. That's kind of it. That's all we got. The image right here is Ned Flanders, I'm guessing. The paragraph is your trusted source for secure passwords. And then we have the H1. So the H1 tag is a header tag, like it's a bold header tag. So it would say password Ned. That's kind of what the headline is, we should say. The header is this piece right here, pwned.se password nedab. Is that the whole thing that we want? So it says, what's the header? Okay, I want to say, what is that? Pwned.se password. Let me see if that's the thing. I don't think it is. I think that's like too much. Nope. So password, right? Like that? Password, no. What is it? Password -nedab. Okay, that could be it actually. Password -nedab. That's what it is. All right, cool. What is the source address of the image? ads dot da 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 da. Okay, so we are now going to go to images, and we're going to try to find this specific image. Let me see if I can copy this right here. And so we're going to find the source address of that. So we'll go to images right here. And let's see if we have a search bar. Oh, we don't have a search bar for this. Okay, so we're looking for ADS BMP. Oh my God. All right, let me see if I can find this. Bruh, it was the last image. I went through all of these freaking images and it's the last image. I'm so pissed. Oh my God. Okay, it's a blank image, so that's kind of useless. So what we're looking for is what, like the details, right? So if I go over this, it says source, right? And that's what it's asking for, is the source address. So if we hover over it, it says 80, 239, 178, 187. My God. Here we go. 80, 239, 178, 187. I am so... Oh my God, I spent so much time sifting and sorting. This is kind of annoying. Like, there's nothing to use to search through these images, so you have to one by one look at all of the image files, and there's no Control F that works. There's no sort or anything that works. That was annoying, let me tell you. Okay, moving on. Great, fantastic. What is the frame number of the possible TLS anomaly? Anomalies page, we have how many? We have 2. Wonderful. Beautiful. Frame number, possible TLS anomaly. There are 2 of them. They both say the same exact thing. So 36, 255, or 77, 73, or 73. What is it? 36, 255. Let's try that. So we'll try one at a time. 36, 255. Okay, that's the one. Excellent. Moving on. Fantastic. I want to get rid of this file. I cannot stand this file right here at all. Cannot stand it. So we're going to just delete this. Fantastic. Get the hell out of my face. Reload case files. Should be empty. Fantastic. We're going to open the file. Do the MX9. Oh, this is also going to take a time. Okay, fine. Let's let it load. All right, we got the file loaded. Wonderful. So look at the messages. Which platform sent an email with the subject, "You have more"? So we're going to go to messages. Wonderful. And we're looking for the one that says "You have more" in the subject. Where's the subject? Actually, I think I should be looking at each one of them. So we go right here. Subject, no new vulnerabilities. Subject, where is it? Show me the subject. You have more friends than Facebook. So this is the one. Facebook. So Facebook. Whoops. Okay, I gotta learn how to type. Wonderful. What is the email address of Branson Matheson? And it is branson@sandsite.org. So oh my God, I can't spell to save my life. @sandsite.org. Oh, bruh. Okay, cool. All right, let's talk about version differences. Okay, so just like anything else, there are updates that would be applied to NetworkMiner, and as you saw with the professional version, you pay that $1,300 one time, or this is what my speculation is, that you pay that $1,300 one time and you get to kind of upgrade, or I guess downgrade at any time you would like, because it says features can represent implementing new features and updating existing features. In this particular case, it could be tricky, as they say. So we can go to the change log for NetworkMiner, and from here we can see where are the change logs right here. So we have the change logs, and so based on this, you can see the improvements that have been made to the newer version, or whichever version it is that you would want to use, I guess. So based on your use cases. Since there are significant differences between the versions, the given VM has both of the major versions, 1.6 and 2.7. The program version increases. It's expected to increase feature, increase, and scope. And the differences between 1.6 and 2.7 are as such. So MAC address processing. After version 2, it can process MAC address specific correlation as shown in the picture below. It'll help you identify if there's a MAC address conflict. This feature is not available before version 2. So if there's a MAC address conflict, which is basically what we actually saw earlier in this video when we saw the same IP address attached to a given MAC address, so that was there. Same thing for the host right here. It can actually say whether or not the MAC address is known or unknown. Versions up to 1.6, or I guess actually, so this one is 1.6. So this one right here that says the MAC address is unknown, that's 1.6. The one that actually says the MAC address and which host it's attached to, that was the above 2 version, or above version 2. Versions up to 1.6 can handle packets in much detail. They will investigate sent received packets, and the feature is not available after 1.6. So this is so weird. I don't know why they would do that, where it's like 1.6 can do something that versions after it can't do. Like, why the hell would you do that? So 2.7 says that, you know, sent packets, received packets. 1.6 gives us way more details on those sent and received packets. That just seems ridiculous. Frame processing. NetworkMiner versions up to 1.6 can handle frames. I'm guessing after 1.6 it's not available. Again, very stupid. So we see this right here, and then under 1.6 it actually has the frames tab. Again, this feels really stupid. I don't know why they did it this way. I don't like this part. Parameter processing. Versions after 2 can handle parameters in more extensive form. Versions 1.6 catch fewer parameters. This makes sense, right? If it's the higher version, it should be doing better than the lower version. So, 2.7 has 41 parameters, 1.6 has 21 parameters. Versions up to 1.6 can handle clear text data. This option provides all extracted clear text data in a single tab. It's beneficial to investigate this. However, this feature is not available after 1.6. Again, it feels like it's so stupid. So 2.7 doesn't have it. 1.6 has a clear text portion. That's insane to me. Okay, which version can detect duplicate MAC addresses? That would be 2.7. Which version can handle frames? That's 1.6, right? Is that 1.6? Yeah. Which version can provide more detail on packet details? That would also be 1.6. That's so silly to me. I'm sorry, bro. I don't mean any insults towards anybody, but that feels really silly to me. Okay, all right. Now we're going to do some exercises, and yeah, these are just straight up questions that we're going to end up answering. So let's do some exercises. All right, these are pretty straightforward. We're going to be doing investigations. So the first question here is using the case1 PCAP file that I've already loaded. It says, what's the OS name of the host ending in 37122? So we're going to go and look at host ending in 37122, which is this Windows machine. And we want the OS name. So we're going to expand on OS Windows. It says Windows NT 4.0. So let's see if they'll accept Windows NT. No. Okay, so it's definitely longer than Windows NT. So the host name, so if we do host details, it's Windows, but the host name, it's OS Windows, Windows NT 4.0 SB1, etc., etc., etc. I'm assuming that's what that is, or maybe Windows Windows NT4. I think that might be the one that they're looking for, because there seems to be a little dash here. So Windows Windows NT4. That's it. Investigate the hosts 131 and so 37122 and 3291. How many bytes were received? How many bytes were received from 37122 to host 3221 through port 143? So our source or our client is going to be this, host is going to be this, and we're looking for port 143. So we're looking for some transactions or transmissions. I think it would be for the sessions maybe. So there we go, 21 and 122, right? So nope, that's not the one. So let me see which one I can find here. So to be able to find this answer, we actually have to look at the details for the 3291 IP address, and under outgoing sessions, we'll be looking at the one that it was sent. So it says on specifically, I mean, it doesn't say on port 143, that's the issue. So the only other thing that I can think of down here, it says port 143, it says 20,000 bytes were sent, and it shows 3221 as the IP address. So right here, it basically says between 37122 and 3291. So from 3291, 237.122. So kind of looking at these, this is kind of like the issue right here. So on port 143 right here, it says that the communication was between this and 3221. So if we go up here, maybe we might be able to find something else where it's like outgoing sessions on port 143 and then being sent to 32121. This is kind of a little bit confusing in my opinion, because on the outgoing for 3291, it doesn't show port 143, so it shows port 1065, and that's the port for 37122. So maybe, oh, actually, you know what? I think it's because it's outgoing on this is 1065, and maybe the incoming on this one, maybe that's what it is. It's on port 143, so 2769. That doesn't make sense either because it doesn't line up with the number of bytes that were sent right here. I say, Okay, so literally the only amount of data that we can get between these two, because the question says it's between these two hosts right here. Okay, so the only amount of data that we can really get is under this one. So this one being the outgoing, right? This is the source. So the question says it's coming from, received from, and it's coming, I'm sorry, I'm right here, sorry. It's coming from this, right? So received from 3291. So we can go look at the stuff from 3291 under outgoing. So from 3291 going to 37122, we have this data. So first of all, the port doesn't line up. So it doesn't say, you know, what the 143 port. The one right here, over here, it says that there's receipts happening on port 143. The number is 20,000 bytes here, and then another number of 746 bytes. And it's been, both of them say bytes sent. So none of those seem to be really lining up. On here, it says that there was 432 bytes sent, and then there was 192 bytes sent. That's basically all we got. And we've been given two different port numbers. So really the only thing that I can think of would be that those two numbers, we have either 432 or we have 192. And so I tried 43, that didn't work. I tried 192, that did work. So that's kind of it. The confusing part for me is that, oh, you know what? I'm so sorry. I feel so stupid right now, bro. I read port 143 on this question, and then on the actual question it says port 1065. That's what like really confused me, because it actually says port 1065 right there. Man, I confused myself because I was like reading two questions at once. Sorry about that. Oh my gosh, dude. Okay, whatever. All right, moving on. We're not gonna hound ourselves over this. We're not gonna dwell on that question. Okay, so the next one is between 37122 and 3221. How many bytes were received from 37122 to host 3221? So through port 143. So this is actually the one that's down here, right? So bytes that are outgoing seems to be none. So if we go up here, it says to 32121 outgoing sessions. We have right here 37122 on port 143, right? Does that seem to be right? So it says were received from 37122 to host 3221. This is under outgoing. So this also doesn't make sense. This should be under outgoing for this one right here, but this doesn't have any outgoing sessions. It only has incoming sessions. Am I misreading the question, bro? It says received from 37122 to host. So it would be outgoing on this, right? Received on this, right? Am I missing it? No, I think I'm reading that right. Anyways, it's 20,769, and I think that's the closest answer because of the number of positions that we have. So 2769, whoops, not 10, 2769. There we go. All right, cool. What's the sequence number of frame 9? So let's go here and let's see what information we can find. I think we can probably move on from the hosts tab now. and see if we can get anything for the frames. So let's see here. Where do we find frame information based on the hint? It says, let me zoom out a little bit more. The hint says, come on, what's going on, buddy? Using different versions of NetworkMiner can help. The attached VM has 2 instances. Luckily, I loaded 1.6. And so there we go. There's the frames. Okay, so now the question says sequence number of frame 9. So if we go to frame 9 here, there we go. And let's open that up. And we want a sequence number. The sequence number can be found under the TCP tab, and it is 2AD77400. So 2AD77400. Beautiful. And what is the number of detected content types? What does the hint say? Parameters can help us. So detected content types, under parameters, we don't have anything for version 1.6, so we're going to go to 2.7. We have a bunch of stuff under parameters. And the number of detected content types, that's a very interesting question. So how do we find that out? So if we filter for content type as the keyword, we'll just get a bunch of different packets that would say, you know, text, plain, etc. And then if we scroll down far enough, there is now multi-part mixed. So it's mainly text plain and multi-part mixed. So it gives us 2 content types. And I wonder if that's actually the answer. It is. Excellent. Okay, so now we can move on to case 2's PCAP. So I'm going to just delete this inside of our, and then remove and reload the file inside of the version 2.7, and then we'll go to version 1.6, and we'll remove and reload the case files as well. So we'll go ahead and load the version 2.7 with the case number 2, and let's make sure that that opens. And okay, we'll give it a quick second. It seems to be loading fairly quickly, so let's give it a second. Okay, cool. The file has loaded. So the question now is, what is the USB product's brand name? So USB product would be connected where? So let's actually see what we can find with our hint here. Investigate the file. No need for external research. So investigating files. So we're going to go into files. Oh, here we go. So USB LAN zip octet stream, and the brand name that we're looking for might be available on it. So let's, if I kind of open the USB to LAN, can I open it? I should be able to open it, right? If I double click on it, I think I should be able to open it. USB. So let's search for USB and see what shows up for USB. And we have a bunch of stuff here. Okay, great. So we're looking for the specific brand name for the USB. So let's see what I can find with all this intel that we got. So the information, I think, actually resides inside of our source host portion. And if we kind of go look at it over here, we can see A6, which is the closest thing to the number of characters that we've been given is A6. DeltaCo, Google, you know, A6, Gstatic. Potentially, I feel like Gstatic could be one, DeltaCo could be one, but the closest one to the actual number of characters that we've been given is A6. So I'm going to try A6 and see if that is actually the answer. And it is. Okay, great. So, I mean, there's a lot of information here, honestly, that we can potentially find. Because if I go to DeltaCo USB, and there's a, hold on. If I just do DeltaCo USB, we'll get all these things. So there's like a bunch of DeltaCo USB devices. So it's not necessarily that DeltaCo can't be the answer. It's just that in this particular case, we're looking for a 4-letter answer. So that was the one. What is the name of the phone model? And this is probably under files as well. So files and images, no need for external search. So files and images, if we are looking for a phone model on an extension, it could be the octet stream extension, not necessarily HTML, maybe GIF, because it said image, JS, HTML, JSON, GIF, etc., etc. Okay, so let's go look at images. Do we have a lot of images? We have a lot of images. And in here, at least we have some previews that might be handy. But we're looking for a phone, and a lot of these previews don't really give me much. So I'm going to try to see what I can find inside of the phone. Look at all the Ned Flanders stuff. That's great. That's awesome. So let me see what I can find relevant to a phone, and we'll see if we can find anything else available to us as well. Okay, so I went through all of these images, and the only one that even remotely resembled a phone was an image of a Nokia phone, but I don't know if that's actually the answer. So if we go down here, we can see the phone over here, actually a little bit more, right here. So there's a Nokia symbol. That's basically it. If we look at any of this stuff, so let's zoom in a little bit, maybe that might help us see these things a little bit clearer, unless I completely just wiped all the images. Okay, there you go. All right, cool. So we see these, there's the A6 USB right there, look at that. So we have the black demo USB drive right there. There's a bunch of things that could potentially be hints of things. But for the most part, there's nothing that really resembled a phone other than that little icon for the Nokia. I'll look through it again just to kind of look at the zoomed in version. Maybe I missed something, but I really feel like the Nokia would be the closest one. So what is the answer? It says, what is the name? So Nokia, that could definitely be it. So if we go down here, I think it might be the Nokia. So let's go look at the Nokia real quick and see what the Nokia symbol CLR, maybe that is, I don't know. If we go back to files, let's see what we can find for files. What if I search for phone? Windows phone symbol. And what does this show us here? So Nokia was not the answer. There's actually another little image right here that looks like this could be potentially a phone. It looks like a phone right here. Lumia Nav 419 something something something. So if we go, let's see if we can find something for Lumia, because there was nothing for Nokia. There's Lumia definitely showed up. If I do Nokia, Nokia symbol is the only thing that actually shows up. If I do Lumia, we actually do have the MMD Lumia 535 SYN. So let's try Lumia 535. Okay, cool. So that one took a little bit more time than I really wanted it to. I had to do some deep diving, and really it helped when I zoomed in on the images, because this, as you can imagine, it doesn't really it's not as detailed, because it could be a tablet for all you know, and then we have all these other images down here that are kind of misleading because that looks like there's a phone in it, but that's more for office. This is like TV, another office. So I guess this is like the closest one to a phone, really. So, all right, there's that. And now what is the source IP of the fish image? Good Lord. So now I have to find a fish image. I don't like this part because I can't search for anything. So let's go into files and see if we can actually search for fish in the files. Crazy fishing. That could be it. Source host 50.22.95.9. Maybe that's it. So let's see, 50.22.95.9. Okay, that's it. That's for sure way easier because we can actually search for the freaking file name. What is the password of the homer.pwn.scgmx? So we're going to go to credentials right here, and we're looking for username Homer. We cannot search through the usernames. This is another thing that's just really annoying. So can I at least do this? Okay, I can organize them, so that's good. So let's see if we can go find Homer. There we go. So homer.pwn spring 2015, I want to say is the password. So let's go and do spring 2015. Great. And what is the DNS query of frame 62001? So we're going to go to DNS right here, and we're going to find the frame 62001, and there we go. There's the frame, and we're looking for the DNS query. It's pop.gmx.com, and with that, we are solid. Amazing. Super happy that we got to the end of this. Okay, so hopefully this was a little bit of a useful exercise for you to the abilities of NetworkMiner. There are a couple of things that I do not like about NetworkMiner, and I'll just be very honest. Number one, I don't like the fact that a version 1.6, which is the older version, has more capabilities than the newer version. That kind of was a miss for me. I don't like the fact that if we're searching through images, I can't organize the image names by their, like, you know, ascending or descending. I can't search through the image files. And there was another one that I forget what it was. I think it was the credentials, maybe. I think it was the credentials that didn't have a search field and I couldn't search for credentials, but at least that allowed me to sort. So that was kind of useful. But there were a couple of things for this where I was like, okay, well, this kind of feels like it's a little bit, I don't know. And we were looking at version 2.7, so it could very much be that the version 3 and above has a lot of functionalities that are, you know, make up for the things that I just was frustrated by. That could very much be the case. But for this particular exercise, for this specific video, those were the things that stood out to me, and I'm not that big of a fan. I will say this, right? So the fact that all of those images were there and we could actually sift and sort through them, comparing that to WireShark, that's a little bit of different, because WireShark doesn't have a simple tab that you can click on that will show you images. It doesn't have a tab that you can click on that will show you files that you can search through file names. So those things are actually really clutch, especially when you're looking for files and things like that. Because WireShark, it allows you to export files and then search through the files and things like that, but it's not as easy and user-friendly as what we just went through. So for that, I would say in those kind of levels of comparisons, I think it was actually very useful. There's a lot of uses for NetworkMiner. For whatever reason, those few things that stood out really irked me, and I spent too much time searching for those images, so I was kind of upset about it. But I think I think at large, I think it's fine. It's a good tool. It's handy. I will try not to be too mean with my criticisms. We're just going to stop it. We're just going to stop it right there. Hopefully you found value from this video, and hopefully you were able to get the answers that I got as well. You can find more information or more videos that could be actually similar to what we did in the same kind of spirit of what we did with the WireShark stuff, the Snort stuff, and Brim, I think, is actually just an exercise room. Snort is actually a tool. WireShark is actually a tool, but Brim, I want to say, is a specific exercise. Let's look it up. Oh my God, excuse me. I'm so sorry. That's so rude. I'm really, really sorry for yawning. No, Brim is a tool. I stand corrected. Brim is actually a tool as well. So that's completely my bad. So sorry about that. So we have 3 other tools that you can kind of look at in the same spirit of what we just talked about when it comes down to network analysis and what we did with NetworkMiner. But with that being said, we're officially done with today's video. If you found this video useful, and if you would like to get more videos like this one, then I encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel. And that includes everything but SOC Level 1. It includes the labs for Pentest Plus. It includes AI for cybersecurity. It includes the new Linux Plus series that's going to be coming out for the new Linux Plus examination, as well as a few standalone videos that I think will be very, very useful to the community at large. So if you have not done so already, make sure that you do that. And if you have any questions about what we talked about today, then drop them in the comment section. If you have any feedback or any kind of reviews or any tips and hints that you think would have made that investigation a little bit easier, please drop those in the comment section. I love hearing from people, and I love learning through the comments, because we have a lot of smart people that are actually inside of this community, and a lot of times they provide really handy tips that are super, super useful. So I would highly, highly encourage you, if you're one of those people, please drop those comments, because they actually are very handy and very useful to me, as well as I'm sure the rest of the community. And I would sincerely appreciate it. I always welcome those types of comments. But if you have any other questions, or if you have any kind of comments, please drop those. And of course, if you have not done so already, make sure that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel. And then, of course, there's the Hackaholics Anonymous community. If you want access to my notes and exclusive downloads, and to get lifetime access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers. We have the supporter, the agent, the guardian, and the Master. Each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below and you will be able to choose the tier for which you want to join. I really hope I see you in the Discord chats. If not, I hope I see you in the comment section. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease. And I will see you in the next episode later.